previously. हेलो हेलो। अरे
भरोसा वो वादा है दिल में जो सच्चा इरादा है। मैंने कदमों का सहारा है करीब से और भी प्यारा है। समझो तो बस एक इशारा है विश्वास ये हमारा है। भरोसा है भरोसा है भरोसा है।
हम भरोसा उन्हीं पर करते हैं जिन्हें हम करीब से जानते हैं, जैसे भारतीय मानक ब्यूरो, जो है भारत का भरोसा। स्टैंडर्ड है तो सही है।
Muni, I promised to tell you earlier about fire safety.
Yes, please tell me, Dadaji.
Since our house conforms to the guidelines given by the Bureau of Indian Standards, we are safe from fire incidents.
Are there any specific guidelines for fire safety?
Yes, Munni. BIS has formulated the National Building Code of India 2016, known as NBC. It articulates the essential elements of building construction. The guidelines in it ensure safe and disaster-immune buildings.
And what about the fire safety guidelines?
Part 4 of the NBC 2016 specifies fire and life safety guidelines. The provisions of Part 4 cover the aspects of fire prevention, life safety and fire protection. Part 4 specifies the classification of buildings based on the occupancy from fire safety point of view and also does demarcation of fire zones at town and city level. These requirements safeguard our houses and buildings so that they are safe and secure during fire incidents. Buildings should include fire exits, fire-safe staircases, escape lighting, signage, smoke detectors, fire extinguishers, fire sprinklers, and ventilation system. And needless to say, do not use lifts in case of fire.
Should all the buildings meet these requirements?
Indicated in Part 4 of NBC are meant to satisfy many requirements for fire safety of life from unforeseen hazards.
Good to have all this information.
I request members to come sit forward. We will start seminar in another 5 minutes. I request members to be seated. We will start seminar. Good morning, everyone. Respected dignitaries, experts from academic institutions, experts from industry, esteemed BIS members associated with various technical committees, my colleagues at Bureau of Indian Standards, members from professional bodies, consultants, representatives from various government departments, members from industry associations, students, and all attendees joining us today online. I, Praveen Sai, Scientist B, Civil Engineering Department, on behalf of Bureau of Indian Standards, welcome you all to this seminar on revision of IS 456 Structural Concrete Code of Practice. It gives us immense pleasure to host this important seminar at Bureau of Indian Standards headquarters today. IS 456, earlier known as Plain and Reinforced Cement Concrete Code of Practice, has taken its new form as draft revision with the title Structural Concrete Code of Practice, which will now include provisions related to plain, reinforced, and also pre-stressed concrete, thus making it an unified concrete standard. Recognizing advancements in this domain and latest engineering practices, an extensive revision exercise of IS 456 was undertaken under the Civil Engineering under CED, Civil Engineering Division Council, Cement and Concrete Sectional Committee CED2. After rigorous technical discussions, R&D studies, and collaborative efforts of Cement and Concrete Sectional Committee CED2, for more than 7 years, the draft revision of IS 456 was released for wide circulation on 27 November 2025 for inviting public comments and stakeholder inputs on this draft revision. Today's seminar has been designed to explain the major upgradations and key changes introduced in this draft revision. Through a series of technical lectures delivered by eminent experts associated with this Cement and Concrete Sectional Committee CED2, we believe that these discussions and exchange of ideas, valuable feedback through this platform will shape this draft revision into its final form and addressing issues related to all stakeholders. On behalf of Bureau of Indian Standards and Civil Engineering Department, I extend my heartfelt gratitude to each one of you for your valuable presence over here today. May I now proceed with inviting our dignitaries to kindly grace the dais. I invite Shri Jose Kurian, Chairperson Civil Engineering Division Council and Chairperson Cement and Concrete Sectional Committee CD2 to kindly grace the dais. I request Shri V.V. Arora, Co-Chairperson, Cement and Concrete Sectional Committee CD2 to kindly grace the dais. Now I invite Shri D. Bhadra, Scientist F and Head Civil Engineering Department, Bureau of Indian Standards to kindly grace the dais. I request D. Bhadra sir to welcome Shri Jose Kurian with bouquet. I request D. Bhadra sir to welcome Shri V.V. Arora with bouquet. I request dignitaries on dais to kindly proceed for ceremonial lamp lighting as a symbol of knowledge, progress, and innovation. I request Jitendra Chaudhary sir also to join ceremonial lamp lighting. Now I request Shri Jose Kurian, Chairperson Civil Engineering Division Council and Chairperson Cement and Concrete Sectional Committee CD2 to deliver inaugural address to the gathering. Inaugural. Vivek?
Good morning, everyone. Bhadraji, V.V. Arora, and so many of our colleagues who've been working together for a very long time, many years. Gives me great pleasure to be standing in front of you because we are nearing the fag end of major effort that we have been doing for the last so many years. So many years to bring this revised code into the being. The work has been going on for a long time, as I already mentioned here, and so many people, so many experts, both from the industry and academia, as well as from other sections of the society, have taken part in this major effort. As you know, the IS 456, which is the basic code for concrete, is the most used code in the history of BIS. There was a time when the code was being sold. This particular code used to bring the maximum revenue to the BIS. Maximum number of codes sold were the IS 456. This can you see? Put it here. You can see this. Where is this one? I can't see. Somebody who's no? Laptop should be here, or it should be here. How do you speak then? Pardon? Then no, but I have to read it, no? This whoever has designed it, it should be here on this, it should come. Yeah, that's all. You can't read the. That's good. It's good. Enough like this. I'm audible. Okay. Which is the one? Yeah. So why, I mean, the BIS role in making a code, it's a long process. I mean, we should understand that exactly what are we attempting to do when we call a code, what exactly is okay. It's visible. What is a standard? So this is the, I mean, we call it by many names: code, standard, guidelines, specifications, and all those things. So, but we should understand what exactly is this particular document. So that is one of the definitions given by the International Standards Organization. Is this a standard? I mean, the idea is to standardize the procedures, the processes that is available here, so that everyone speaks the same language and everyone see the same light. That is the idea, the work of Bureau of Indian Standards. So it is a document established by consensus. This word consensus is very important, because we don't write a code based on majority. So that we should understand. It's a democratic process, but it is not based on voting. Whereas the International Standards Organization, every provision, every code, every action is determined by the vote. Who gets a particular percentage of vote should be there to pass and put a provision in the code. But in the BIS, we don't do that. We do by consensus. We feel that the forum, when we discuss the issues, we can come to a common opinion, considered opinion, acceptable to all. A consensus does not mean in the definition that is accepted by 100% people. So if it is 100%, if it is accepted by majority of the people, that will be minor dissent. It is called consensus. So we discusses it and make everybody, whoever has any difficulty in going with that, understand why we are doing it, the intentions behind doing that, how it will be useful to the society, so that we reach a consensus and then a provision is made in the code. So it's a long process, unlike in the ISO that you display something on the board and throw it for a voting, and the number of votes is counted and the provision is there. So that is why it takes a little more time. We want to bring everybody together as a one mind, so that the provision is acceptable to all. That's one part. And unlike the other societies in the Western side, ours is a very, very fractured society. We got the poorest people in this country, also maximum number of millionaires also in this country. We have got very highly educated people. We also have illiterates in this country. We have got factories whose products are high quality, but the MSME or the lower end, they may not be able to produce that kind of a quality. So all these people are part of our Indian society, and we have to take all of them together. And so that we should create provisions in the code, standards and other provisions in the code, so that it is acceptable to most of the people. Then only the country can progress, because unless you cannot push a particular provision down the throat, that is not possible. It will not work in the society. So that is why it takes time. Many times we are criticized that we are taking too much time to bring a code. Why can't you just take it, write it, and get out of it? That's not possible. That's not correct also. So it is that is the way it is done. It is by consensus done, and it is approved by a body. Ultimately, it is a stamp of the Bureau of Indian Standards, so that it should be the provision shall be accepted by the body, which is the Bureau of Indian Standard. For that also there is a process, and and these provisions will be used by all those users, industry or the academia or anyone who are the user. And there are rules and guidelines and activities of the results aimed at ultimately the achievement of an optimum degree of order in the society. This is what we want. That is why standards are produced, so that there is no chaos created. Otherwise, everybody does his own way, there will be chaos. So the idea is to bring standardization so that there is order in the society. This is the basic need of the making the code. So if you look at the code, what are we going to achieve? So if you look at the holistic picture, it is a technical communication so that the symbols are all, when I write alpha, what does it mean? Should that alpha or beta should be known to all the people. It should mean the same thing to everybody. Then ultimately what you are going to do is cost effectiveness. This is the idea, that we don't produce things which are extremely expensive or of poor quality. It should be the quality a cost effective products are to be prepared. That is the idea. And safety is one of the major important thing. It's covered in all kinds of safety has to be covered in the code. That is the ultimate objective, that the structures that we create are safe to public, to yourself, and also to the structure itself. That's the thing. And so that the consumer, after all, what are we going to do? We are looking after the community, the consumers of the society, because you know that the BIS is part of the consumers ministry. Ultimately, who are our consumers are all these people who are going to use the code. So that is the thing, we are working for the consumers. So the idea, the cost is one of the criteria. Safety is of course very important, as I already said. Cost, human effort, and conservation of essential material. That is, we look at the ecology. So that is the purpose. Maximum convenience of users. We do not make it life so complicated. Make it as simple as possible, and then possible solution to recurring problems, so that everybody knows. Everybody has to invent the wheel. That you create a particular solution which can be utilized by all the people. And then quality. I mean, we have got huge amount of doubt in our mind. What exactly is quality? So that has to be defined. What is quality means when you create a product and we write a specifications and standards, that if somebody produces a particular material or a process according to that one, that is the quality. It should be made according to specifications and standards. So that is how the quality is determined. It is that should be very much understood. Then communication is the key, because when everybody speaks, because I am going to buy 10 tons of cement, that's all I'm going to say. But the other fellow should understand also, he's going to sell cement for me. How do we communicate? We communicate through the code. When the cement means what is written in the code. What should be the, or steel is what, that is written in the code. So when I buy 10 bags of cement, the other party should know what he's going to give me. So that is the communication through these codes. So that is one of the major use, that all the specifications, all the quality, all the tests that are required to make the product cement is written in the code. So that is the communication. When I say cement, what exactly is mean is available in this particular standard of cement. So this is the major issue. So that trade barriers are removed. So that if I buy cement in Europe or cement in China, it should all be same when it comes to the international standards. But at least in this country, when we speak cement, it should be known to all. What is the quality? How much? What are the tests? What is the acceptance criteria? All those things should be known. How is it bagged? What should be written on the bag? All those things should be known. Then only we can communicate. The idea is to create a thing so that we have to say only cement. Both the parties understand what exactly is the cement. So this is true with all cement or steel or anything, water or any chemical or anything. This becomes applicable. So this is one of the most important aspects of standardization, that we speak the same language everywhere. That's the idea. And of course, through this, the technology transfer, we teach them to our students in the classes, and people understand what exactly is the one. The process is also very long. So normally, the whole code writing happens in the working groups. That is, for each of the sectional committees, we have got panels. Under that, there are working groups. When, for example, 4, 5, 6 to be done, we created 3 working groups. Actual work on this code happens in the working group. These are the people who discusses, come to consensus, and write those English in the code. If the whole code is written, the primary work happens in the working groups. So it is extremely important that we get dedicated, knowledgeable people into these working groups, and they are the people who write the words in each one of the codes. Once the working group does it, he brings it, they bring it to the panel. We had 3 working groups for the 456, and they bring it to the panel. The panel goes through each sentences, commas and spellings and everything, and make their critique of the whole thing. That they issue the comments, and then the panel, and then it goes to the sectional committee where they go through all the process whether it has been done correctly, and then it goes for wide circulation normally for 3 months, and from there the comments come. And once these comments again go back to these working groups, and they resolve all of them. Each comment is written. There'll be 1,500 comments. Each one of them is critically addressed, written, accepting or not accepting, and the reasons for not accepting. That is all written there. And then a final document comes through the panel, clears it, and come to the sectional committee. And from the sectional committee approves it, goes to the Civil Engineering Division Council. The chairman approves it and adopts it. And that is how the process ends, and you get a code in your hand. So this is a long process and a very, 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 very difficult, arduous, and very time-consuming process. That's the thing. So we come to the other discussions. Of course, you will be hearing from experts who have participated in this particular code. The draft code which we are going to release is called Structural Concrete. We have changed the name, Code of Practice, 5th revision of IS 456. I take only a few more minutes to do that. This is the history. On the average, we take about 20 years to revise a code. So now you know the reason why. Because many fora base criticize that why can't you produce a code every year? It's possible to do. But then if you follow the processes and you want a correct sentence in the particular thing, correct aspects are mentioned, it takes a little more time. So we had in 53, 57, 64, 78, 2000. Now we are in 26. So we have taken more than the average this time. I hope it will be through. This is the thing. So there are 2 major objectives that we had. All over the world, there is something called a unification of codes, because the concrete itself is spread across so many realms of subjects in different areas. It is there. It's in the same civil engineering division, under the same session committee. There are several codes on concrete. The idea is whether we can all bring together into one. The American Concrete Institute have done it. They call it the concrete manual, which has got everything that has to be dealt with concrete is under one book. Of course, it's a very thick book, but everything is in one book. You don't have to refer 20 different references to make it through. So our idea is to, it's not easy. Our idea is to travel towards that uniform code of concrete. So the first attempt has been made. What we have done is we have put the plain, this time, but simple thing is we have done pre-stressed concrete and reinforced concrete and the plain concrete into one particular document. So that is why it is called structural concrete. So the first step is there. Afterwards, we have to do so many things. So many of the concrete which is spread across has to be brought into this particular revised code. One by one, each revision will take it up. Second important issue is to harmonize with the international standards. So international standards got a meaning. Once a document is international standard, it has to be accepted by all the countries, member countries. India is one of the founding members of the ISO, International Standards Organization. So if they produce a code, we have to perforce accept it. So that is the issue. So the problem is, especially when you go, for example, people who are qualified, we have a code IS 456, a consulting company in India, when they go to Europe or an African country, which is the code they are supposed to use. So each country will prescribe their own code. That means this consulting firm will have difficulty. You have to go from this code, you have to study the entire new code and come into this one. That is where the international standards help. So if you do work according to the international standard, the other country has to accept. You can go to France or you can go to Canada or go into US. If you are using an international code, they accept it. So the idea is to harmonize our code, our Indian standard, along with the ISO. They got a standard for that, harmonizing 19338. So we are trying to make it as close to this 19338 to the extent possible. So these were the 2 major activities that we have undergone in this particular development. Once this code is prepared, we will send it to ISO. They will create a panel 5-6 countries go through this one, and if they declare that's an international standard, they will put it in the website that IS 456 of the BIS is an international equivalent to an international standard. So your consultants, whether working in India or in France or Canada, can use IS 456 structures. So that, and it has to be accepted by the international community. So that's the second effort. That also took some time because of this one. It has taken much, this one. So I stop it here. Rest of the things, I think, Arora ji and Jirudra, they will tell you. So thank you very much for listening to me. I hope you have understood that the time taken was one of the major criticisms that we get everywhere, why we will take time and how important it is to give time to this particular standard. And the major objective is to traveling towards an international code and a unified code. Thank you very much for listening, and all the best for this one. I take pleasure in inaugurating this particular workshop. Thank you very much.
Thank you, sir, for briefing us about standardization philosophy, objectives of standardization, and procedures followed at BIS in standardization process. Now I request Shri V.V. Arora, sir, co-chairperson, Cement and Concrete Sectional Committee CD2, to brief us about the background behind revision of this IS 456.
Thank you. Mr. Jose Kurianji, Bhadraji, and fellow delegates. Well, I will speak for a few minutes on the background of this, how we started and all that. You see, in the last 2 decades, we are covering 2 decades, the thrust had been on the use of higher strength of materials. Worldwide, people had been doing research on this, developing newer materials. There has a thrust on use of waste materials, and sustainability issues were always discussed. In the last decade particularly, there was a lot of thrust on the sustainability. Now, when we are to revise the code, we have to incorporate the latest, that is the tendency. Now, in India also, we started work on these issues long back. It is not that we started when we revised the code. More than a decade ago, we had also started research how these aspects are linked to IS 456. High strength materials means high strength concrete, so that is related to 456. Use of waste material, we are using a lot of waste materials in the concrete production, so we had to work on that. And then sustainability is the durability. Durability and sustainability are interlinked. Without durability, you cannot have a sustainability. If you keep on adding waste material and there is no life of the structure, there is no meaning of sustainability. You are using it double the material. So we have to work on the durability part, and to ensure that the structures are durable, we have to check the performance. So we move towards performance-oriented specifications. And on these all these aspects of the high-strength concrete, for incorporating high-strength concrete, we had to study in detail the properties of high-strength concrete. And for this, we started research more than a decade ago, around 2010 or so, we started these projects on the, not only in NCB, these studies were being carried out in IITs also, Delhi, Chennai, and other places. And though some international literature is available, but our own experience has to be there when we are making our code. That gives us a better code. So a lot of research was done in India itself on Indian materials, basically, and Indian environment, which is more important in these aspects. So a lot of research was conducted on high-strength concrete design parameters, use of waste materials, and the effect of those waste materials on the durability. Then specifically for the performance-based design of the durability, also the research started more than a decade ago, and a lot of work was done before starting the code also, that how we can design the structure for a known service life period, so that we can quantify the things and we can determine whether whatever materials we are using, they are sustainable or not. Because if the structures are durable, then only those materials are sustainable. So this involves input from the various Indian research data, though we referred to international literature also. So now this code which will be coming up, this incorporates our own material research, which whatever we conducted, and we are little more confident on that. like it is not that we are only copying some European literature or American literature. We have our own data on this, which will keep on improving. See, improvements will remain on there. As the code comes, people start more research on those areas on which some institutes are not working. So all institutes, they start working on those aspects also. So then if there is some lacuna, some improvements can be done, we keep on getting suggestions and improvements can continue. So we hope, and I will be pleased to say that in some of the areas we have gone more advanced than the other advanced countries in this standard. In the performance-based durability design, other countries have not yet adopted this. They had some research on this, but they have not adopted in their national standards. Like America, they have got some reports on durability and service life design, but their national standards, they have not made it mandatory kind of thing. So whereas we are putting it in the standard because we are confident we have done our work. So that is how we are going it. Similar model codes have been prepared elsewhere. They are like model code, Eurocode. There is talking about something, but even Eurocode has not incorporated the performance-based design of variability. Though they talk of service life, but still they have not given that kind of flexibility. So this code is kind of an advanced code which is coming up. Though little more time it has taken in publication, and we are trying to expedite it to finish at the earliest possible. And we will be pleased to get the feedback and all that. We'll try to whatever best possible. Thank you all. This is what I wanted to share with you. That's all. Thank you.
Thank you, sir, for giving brief aspects considered in revising this IS 456. And now I request Shri D. Bhadra, Scientist of Head of Civil Engineering Department, to present memento to Shri Jose Kurian, sir. इस तरह से I also request Shri D. Bhadra, sir, to present memento to Shri V. Arora. Now I request Shri D. Bhadra, sir, to deliver keynote address to the gathering.
Respected Sri Jose Kurian sir, Chairperson Civil Engineering Divisional Council, as well as Chairman of the Cement and Concrete Sectional Committee CD2, Sri V. Arora, Co-Chairperson CD2, dignitaries on and off the dais, esteemed speakers of the seminar, delegates who have come and joined this seminar, and those who have joined virtually. Good morning and a very warm welcome to you all. It is my privilege on behalf of Indian Standards to welcome you all in the seminar of revision of IS 456 Structural Concrete Code of Practice. Thank you, Kurian sir and Arora sir, for setting up the tone for this workshop cum seminar which we are having, because we request you to go through the. I think all of you have gone through the standards, and your comments and your feedback and your deliberations on this will make the standard more resilient. As sir has already explained, Kurian sir, the process of standard making, and we BIS being the national standards body, we are dealing with all types of standardizations and civil engineering is one of the core standardization department out of the 17 technical committees which we are having in BIS. This CD2 of Civil Engineering Department deals with the standardization in the field of all types of cement, pozzolana, testing sand, concrete, aggregates, and instruments for cement and concrete testing. And IS 456 is one of the parent concrete design standards used in the country by all stakeholders from civil engineering fraternity ranging from academic institutes to practicing engineers involved in design of buildings and structures. It is most widely used as a guideline document by all state PWDs, practicing engineers, structural consultants, as well as a teaching material in academic institutions across the country. So, as you are all knowing that this standard is under revision, and we have already had this wide circulation from November 2025 for a period of 3 months, and we have attracted more than 1,500 comments on this standard. This seminar serves as a medium towards dissemination of the information about the major changes made in the draft standard. The construction landscape in India is evolving continuously with the increasing demand for urban construction, smart cities, disaster resilient structures, energy efficient systems, and sustainable constructions. We are truly honored today with having distinguished guests from the industries, academy, and professionals from various fields of construction and built environment. Your presence here today is a testament towards commitment to the shaping safer and more sustainable and resilient ecosystem in our country. It is our hope that today's deliberation will serve not only to familiarize stakeholders with the upcoming changes in the draft revision, but also provide an opportunity to contribute valuable feedback, insights, and real world perspectives that can further strengthen the provisions of the draft standard. I would also like to thank the Cement and Concrete Sectional Committee CD2, the panel on revision of IS 456 CD2:2 P5, and its associate working groups for their tireless efforts in bringing out this comprehensive revision of the standards. As Kurian sir has already told, and also Vivi Arora said, that a lot of background work has gone into it, and this standard is a culmination of all those efforts. But we still have a long way to go for finalizing the documents. And here, uh, this seminar is uh, one of the opportunities where you can give your valuable feedback, insights, and perspective in the draft standard. So thank you all once again, and I wish the seminar a great success. Thank you.
Thank you, sir, for highlighting the importance of IS 456 in the country in civil engineering domain. With inaugural session being concluded, I request participants to join for tea and refreshments arranged at cafeteria outside the auditorium, and we will assemble back by 11:15. Thank you.
सारे सूरज सारे सागर
सारा अंबर सारे तारे,
उत्सव हो हम सबका जीवन,
संकल्प हमारा है
पाथे सभी के सपनों का, लेकर हमें आगे बढ़ना है। कुछ रचना है, कुछ सचना है, कुछ रचना है, कुछ सचना है, नई राह बनानी है। सोच नई संधान नए कौशल के नए आयाम,
हम जहाँ चले जिस और चले हम कदम हमारे हो,
आकाश को गाना है,
विश्वास जगाना है,
हर इंद्रधनुष सुंदर जगमग धरती पर लाना है। कुछ रचना है, कुछ सचना है, कुछ रचना है, कुछ सचना है, कुछ रचना है, कुछ सचना है, नई राह बनानी है।
Welcome back everyone. We shall now resume with our technical sessions. Today we have in total 6 technical sessions. Now I invite Member Secretary Cement and Concrete Sectional Committee CD2, Shri Jitendra Chaudhary, Scientist C, Civil Engineering Department, Bureau of Indian Standards, to deliver presentation on overview of IS 456 2025 draft. Sir. विवेक
साइड वाला हटा दो, साइड वाला इसको हटा दो।
नहीं यहाँ कुछ नहीं दिखेगा।
अच्छा अच्छा ठीक है इधर ही आ रहे हैं। ठीक है
बस इस
ठीक 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 चलो ठीक है। Very good afternoon, everyone. So this session will be, I'm going to brief about a little bit overview about the draft standard which has been issued for the wide circulation. So before issuing, let me know how many of you have gone through the draft standard. Well, it was issued in wide circulation last year, 2025. Okay, so I can see a couple of people who are already aware of the draft standard. So this session is basically, I want to highlight about what major changes we have done in the draft standard, and in the coming sessions, more and more technical detailing of those particular clauses will be discussed by our eminent speakers today. Okay, so before going to the draft standard, I will just a little bit discuss about the evolution of IS 456, how it basically evolved in the past 70-80 years basically. So the first version was published in 1953 as a code of practice for plain and reinforced concrete for general building construction. So at that time, the scope was limited only to the general building construction and requirements. And thereafter, it has been revised in 1957. That was the first revision. Then the second revision was brought in 1964, where the title was Code of Practice for Plain and Reinforced Concrete. So you can note the difference in the titles basically. So there, in this second revision, the scope was enhanced not only to the building construction but also to the other structures basically. And secondly, the second very important change was that working stress method of design was introduced for the very first time in the second revision. Then the third revision was brought out in 1978 as a code of practice for plain and reinforced concrete, where limit state method of design was introduced and working stress method was continued for that time also. So both dual design philosophy using the design with LSM as well as working stress method, both the design methods were kept, was introduced in third revision and was continuing till date. Then the fourth revision was brought out in year 2000, which is the presently code which is under practice, and where in this revision the prescriptive requirements of the durability in terms of maximum water cement ratio, minimum cement content, maximum cement content, workability points, acceptance criteria, all those provisions have been introduced in year 2000, and the code has very well received by our construction industry and engineering fraternity, and it is currently in practice till date. And the fifth revision came in the draft format in year 2025, which we are going to discuss in the today's session basically. So this first change was brought in the as a title, that is, you can see earlier everywhere in all the previous versions basically of the standard, it was for plain and reinforced concrete, but this time, as the chairperson has also mentioned in his opening remarks, that we have also integrated the provisions of pre-stressing concrete, which was earlier covered in IS 1343, into the draft standard. If you have all gone through the draft standard, you will not find any particular section which is dedicated to pre-stressed concrete. But the provisions have been integrated with the other clauses of with the plain and reinforced concrete. Like some provisions you will find in the structural materials section. In the design and detailing section, pre-stressing requirements are given. In the durability section, pre-stressing requirements are given. So the provisions are there, but it has been integrated, not at the particular section is there. If I will talk about the broad structure of the draft, so you can see, for every standard, you can see the initial conventional items, the scope of the standard with the references, terminology and symbols and abbreviations. The fifth was basically the basis for design. So this particular clause basically highlights about what all the performance requirements and design requirements to be taken care by our structures when they are going to meet the requirements which are imposed on our structure by the loads which are coming on the structure. Then clause 6 is dealing with the loads and its effects. So this time the loading clause has been very briefly elaborated, and we have also categorized the loads, and we have given the different load combinations for all the different criterias. Then clause 7, another very major comprehensive work has been done on the structural material section based upon the various international literature available, R&D studies done at NCB, esteemed academic institutions of the country, including IITs and ITs. And so all those research work, all those material provisions which have been given in the structural materials section, they are backed by all those research and R&D studies which has been done. And they are also harmonized with the provisions of ISO standard as well. Then clause number 8 particularly deals with the structural analysis and methods of analysis which are there. Not much change basically from the earlier version. All the methods of analysis are basically just coming in continuation from the earlier versions. Only the a little bit modifications were there, so that we our next speaker will be going to discuss on those methods of analysis. Then clause 9, the entire basically design thing, or we can say the design backbone of the entire draft is covered under clause number 9. That is one of the most important clause on the structural design and detailing. So there we have introduced the different design criteria which are there, all the detailed requirements which are over there. Then clause 10 tells about the construction aspects. What are the different stages of construction involved in any construction project, what things to be taken care and the precautions to be taken care during the construction. And the quality assurance framework, earlier very limited clause you can see in IS 456-2000 where not much details were given for the quality assurance. Little bit aspects about the testing, entities, all those things were covered. But this time very comprehensive framework of achieving the quality assurance in any construction project has been provided in the different levels of the quality assurance system. And then clause 12 deals with the special concrete section where different other types of concrete very specific for a very specific applications are covered over there. So the first change you can mention in the draft standard. So that is basically we have done the categorization of the structures in clause 5, if you can see. So based upon the functional importance, the negative consequences of the event of failure of the structure and exposure to the hazards, the structures have been classified into 4 categories. One is the special structures, critical structures, important structures, and normal structures. So special structure basically deals with structure which has been very special and iconic and recognized by the government of India. And the other critical structures which, for example, I can give the hospitals, medical care units, all those buildings and infrastructure which are required during the emergency time as a method of disaster mitigation. They should be functional even after the disaster has been happened. So such kind of structure category of critical structures. Then we are having the important structures. So all those residential buildings, complexes, houses will come under the category of important. And those structures which do not fall under all the above 3 categories will come under the normal structures. Now, why this classification has been done? Because the load combinations and the design requirements have been also classified based upon the category of the structure. So how we have classified basically? So these special and critical structure will fall under the category of select structure. That one nomenclature term we has given as a select structure to these special and critical structures. Now coming upon the second, the biggest modification that has been introduced in this present draft standard is the design criteria. Earlier till 2000, 2 limit states what we have discussed earlier, that that was there for the design. One is the limit state method of strength, and then another is the limit state method for the serviceability. So we were designing and proportioning the sizes of all the members based upon the limit strength method of design. And once our section is ready, all the reinforcement are ready, we have come up with the section sizes. Now we will be going to check for the serviceability aspects basically. So this time, along with these two, the serviceability and strength design criteria, other aspects of design criteria have also been brought out. So what are these? Strength, basically, it will deal with the axial force, moment, shear, and torsion capacities, which we are estimating earlier. It is the same philosophy we are going to estimate this time also. Serviceability, we will be going to do the serviceability checks for the deflection, crack width, vibration, so that the structure or structural elements should not deflect much, because it will be going to affect the adjoining structural members by creating additional stresses and strains. And secondly, it will also affect the aesthetics of the structural members or elements. Now, the third important the criteria, design criteria, which has been introduced is the durability criteria. We have seen in the past couple of years, couple of decades, that most of the structures, particularly the reinforced concrete structures, they are failing not as part of the structural design, strength design, but they are not able to sustain their functionality requirements. Basically, you can see the once the structure is constructed, after the period of 5 years or 10 years, the cracks started appearing on the surfaces of the structural elements. There are some crack with large openings. Reinforcements are coming out of the bars. So all these aspects, basically, how our structure or structural elements will fight with the environmental exposure conditions. So that capacity is basically governed by the durability criteria. So all those, you can see the different tables and different classes have been given in the durability chapter. So we have categorized the deteriorating agents based on the exposure conditions. Different agents are there, and how we need to do the durability checks, that are also defined in terms basically for normal structures with that design service life of 50 years. The explicitly table is given in the standard, but for structures having the serviceable life of more than 50 years, they are also, you can evaluate their parameters based upon the factors which have been given in the durability chapter. So resistance to the environmental exposure condition during the expected service life of the structure. Fourth design criteria is the robustness criteria, means resistance of the structure and structural elements against the blast loading, fire loading, and impact loads. Then integrity and restorability criteria, these are the qualitative criteria basically. Integrity means the presence of alternate load transfer paths, redundancy in the structural design, so that in case of failure of one structural element, there should be alternate path where the load can be load coming from the superstructure can go to the foundation basically. So that is basically the purpose of it is already there also in the earlier design philosophy, but now it has been particularly recognized as a separate design criteria as an integrity. And then restorability is basically the ability of the structure to restore and take again its shape after the removal of the loads basically. And this basically is particularly relating with the maintenance and retrofitting of the structure. So these are the 6 design criteria, but whether they are applicable for all type of structure, which we have discussed in the last just slide. So the answer is no. Design criteria basically, so strength, serviceability, and durability. These are the most important design criteria, and that's why the draft has, the committee has suggested that it should be mandatorily applied and done for all types of structure, whether if it is falling in any of the 4 categories. Now, the other 3, robustness, integrity, and restorability criteria, they are mandatory for the select structure. Select means that, you know, the 2 categories, special and critical, but they are optional for the other categories of structure. It will be at the jurisdiction of the owner and the competent authority to suggest if those other 3 design criteria will also be applicable to normal and important structures. Okay, but as of now, we have kept it as optional. So this is the first big change in the design criteria. So the process would be similar. You need to just evaluate which is the most worst condition of the load combination. Generally, in most of the cases, the strength criteria basically governs the design. So you do the initial propositioning and all the evaluation of the materials as per the strength criteria, and you need to do the basically checks basically for the other criteria. So that is basically the process of design, which is same. Third most important modification what we have done is the classification of the loads. So earlier the load which are coming on the structure has been provided. Now we have classified the loads into two categories. So one is the force loads and second one is the deformation loads. So force loads basically are the dead loads, imposed loads, earth pressure load coming from the adjoining soil, snow load, pre-stressing load, wind load, liquid pressure load, machine vibration load, and blast load, and impact load and construction load. Now the deformation loads includes the creep, effects of creep, shrinkage, elastic shortening, temperature effects, both ambient air and the fire. So basically the distribution is that temperature due to ambient air, why we have classified these two into these two nomenclature. So ambient air is basically what we are telling, that the difference between the outside temperature and the internal core of the concrete. And what is the temperature gradient basically when we are going in the section of the particular structural element. So based upon that temperature gradient, there are basically additional strains which are going to the adjoining structural members. So recognizing that effect, basically this particular deformation load has been added. And temperature due to fire effects, basically it is because of the external fire which has been happening, and that is why the surface temperature is rising, and because of that one again temperature gradient would be there. Then the fifth one is the foundation settlement, and the last one is the earthquake loading. Okay, so these are the two classification of the loads which we have added in this particular. So the respective standards will be giving the loads, how to estimate and calculate the loads of different categories. The ones which are not there, so IS code already provides how to calculate that load. Now, another important chapter is the structural material, that is clause number 7. So here we have categorized all the 3 structural materials which we'll be going to use in our concrete design. One is the concrete making material, ingredients of the concrete. Second one is the reinforcement steel, and third one is the pre-stressing materials. So the concrete making materials, basically we talk about cement, aggregates, water, mineral admixtures, chemical admixtures. So in the various types of cement which has been permitted in the use in the production of concrete. So we have categorized the 2 broad points basically. One, the cement which is for general use in plain reinforced and pre-stressed concreting. So all the standards are there, OPC, PPC and PSC are already there. Composite cement and LC3 cement has been added in this particular revision in line with the amendment number 6 which has been issued to IS 456 in year 2024. And the second classification we have done the cement for specific application purpose. So all the specific varieties of cement has been added over here. So, and when you are going to use these specific categories of the cement, you also take the precautions which have been given in the draft standard. Means when you are going to use the sulfate resisting cement, what kind of ambient temperature should be there, what kind of environmental exposure condition is there. So based upon that thing, and which categories of structure to be used for these specific types of cement, you need to take and consider those particular precautions over there. Second one is the aggregates. So aggregates used production of concrete requirements of IS 383, that is coarse and fine aggregates for concrete. And this standard has been taken up for revision, and currently the draft has been finalized. So this revised version of IS 383 is basically developed in 2 parts, part 1 and part 2. Part 1 will be dealing for the coarse and fine aggregates for the concrete, and part 2 will deal specifically with the fine aggregates which is be used for plastering and mortar purpose, masonry purpose basically. So all the requirements for the aggregates, whether it is a natural aggregate or the aggregate from other than natural sources, will be governed by the requirements of IS 383. So that should be used for the aggregates. Third one is the water. So here again, much more and more discussion and deliberations have been done in the technical committee and the panel, and we have recognized that in the country there are various regions which face the scarcity of water to be used in the production of concrete. Many times people use any category of water for mixing the concrete, and it later on it affects the properties and the strengthening as well as the requirements of the concrete. So in order to recognize the different other sources of water, so different types of water has been given in the standard. So potable water, which we all use for the drinking purpose, natural surface water, treated water, water which is recovered from the processing in the concrete industry, and water from underground sources and recycled water. So all these sources of waters have now been added in the requirements of the water. But when to use these sources of water, all should meet the requirements which have been given in the standard. The preliminary inspection requirements basically in terms of the physical parameters, oils, detergents, color, pH, odor. This is the preliminary inspection requirements which you can done as a physical verification. Apart from these requirements, you also, all these sources should meet the requirements of this permissible limits of the solids for the mixing and curing of water. So organic solids, inorganic solids, sulfate requirements, chlorides and suspended matter. Once all these limits have been met by these all sources of water, so it can be used for the mixing and production of concrete. Now coming to the mineral admixtures basically, so fly ash is permitted as per IS 3812 part 1, GGBS slag as per IS 16714, silica fumes 15388 requirements are given, metakaolin, and of course the ultrafine materials, ultrafine GGBS as well as ultrafine fly ash. So all these sustainable materials, byproducts which are coming from the industry have been permitted as a part replacement of cement, and limits have been specified in the draft standard for all these types of mineral admixtures, and also the combination also with fly ash and also these fly ash and slag with these ultrafine materials. So we have given some initial mixed proportions basically, how much quantity and requirement you need to mix those particular thing. So of course, I have seen that many comments have been received on this particular section of mineral admixture, and that will be taken care when we will going to discuss all those comments. Then coming to the other thing is the chemical admixture. So chemical admixtures which are used in the production of concrete should meet the requirements of IS 9103. And this standard also parallelly we have taken up for revision, and this standard is now going to revise in 7 different parts. As of now, IS 9103 is one single standard which is giving 5 different types of chemical admixtures. But now it has been thought that because many new varieties of chemical admixtures are coming in the market, and so as to recognize all those things, so we have added and modified this 9103 into 7 different parts basically. So those parts are under development, and very shortly we will be going to issue all these parts in the wide circulation for obtaining the feedback from the industry. So all these revision in the material standards have been taken care parallelly with the revision of IS 456, so that once this 456 will be there, all the material standards will also be available, so that you need not to search and go for the specialist literature and other things basically. So that is one of the aspect for the this committee, which has been looked care on all the perspective of the revision of the document. Now, minimum grades of the concrete. So the grade of the concrete to be adopted will be governed by the durability and strength requirements, the criteria which we have discussed earlier. However, the minimum grade of concrete which should be used has given by the standard. This is the minimum grades of the concrete which is to be used. For the plain concrete, it is M15, reinforced concrete M25. In the pre-stressing, for pre-tensioning M40, and post-tensioning it is M35. And these values have been finalized and fixed after a lot of discussions in the committee and panel, and we have reviewed all the different literatures also. Then permissible grades of the reinforcement steel. So the provisions of the draft standard are applicable to the following grades of reinforcement steel. So as of now, the standard allows all these 4 grades, Fe250 to Fe550. And the reinforcement steel, the material properties and requirements should conform to the requirements of IS 1786. That is basically the standard, material standard for the reinforcement. And this standard has also been taken up for the revision exercise, and this is already very shortly it is also be going to be finalized before the publication of this concrete code. So coming to the next one is the pre-stressing materials. So first one is the pre-stressing steel, taken care for the tendons which are made by single or group of wires, strands and bars, shielding ducts and joints, mechanical couplers which are used for the pre-stressing systems, which covers the anchorage blocks and other things, and pre-stressing grouting basically, which is used for the pre-stressing. So our dedicated expert, Professor Tandon is here. He will deliberate more upon the pre-stressing materials and the sections over there. Okay. So these are all the things which the committee has done in the field of material science and revision of all the constituent materials of the concrete. Now, next one is the aspects of quality assurance. So we have introduced the comprehensive quality assurance framework in this particular revision of the standard. So first one is the graded level of quality assurance. So you will find that 3 levels of quality assurance have been added in the draft standard. What are the 3 levels? We will come in the next slides. Then requirements of the quality assurance and quality inspection, because these are the 2 very important crucial points as part of the quality management system. So what are the requirements in the pre-construction phase, planning phase, and how to to be incorporated into the after the execution phase, monitoring phase. Basically, what are the checks which are required, what are the documentation are required for the materials, and all the construction aspects are covered into this quality assurance and inspection. Sampling and testing of concrete, detailed requirements have been given. Different methods have been provided for the sampling and testing. Requirements of quality assurance during the production of concrete in the reinforcement steel and the pre-stressing steel. All have been separated, and different tables, specified tables have been given for the 3 requirements. And then testing of the structures and structural elements. Testing of structures and structural elements have also been provided. So what are the 3 levels of quality assurance system we have introduced? So the minimum requirements of quality assurance in construction have been categorized under 3 levels depending on the importance of the project, height of the structure, organizational setup, and project size. So QA1, QA2, and QA3, normal, medium, and high. So QA3 is more robust and rational approach of the quality assurance level as compared to QA1. So if you will find the details in this particular table, applicability of the 3 levels of quality assurance in the construction. So here we have defined all this QA1, QA2, and QA3 for which type of structure, which type of construction, and also depending upon the volume of the concrete, which type of quality assurance level one can choose. And this is for the guidance. This is the minimum requirements which have been given by the draft standard. It is up to the responsibility of owner if he wants to choose for a normal or important structure. Also, if you want to choose QA3, so he is allowed to choose. That is up to his choice. Then for the testing of structures for the quality assessment, following tests have been given over here to assess the quality of the concrete structures and load carrying capacity of the structure. So core tests are there. Load testing, vibration testing, as well as impact testing have also been added in this particular revision. Then coming to the clause number 12 on the special concrete. So this the provisions of draft standard provides guidance on the selection, production, testing, and application of these, because these are very specialized concrete systems for the structural use. So we have given the guidance in one particular clause about all these special concrete. 456/2000 version was already through an amendment. We have added the this self-compacting concrete and roller compacted concrete, but other different types of like SFRC, fiber reinforced concrete, high performance concrete, structural lightweight concrete, polymer modified concrete, and this one alkali activated concrete has also been added. So as of now, we have added as a kind of a guidelines for these different kinds of specialized concrete system. And we will be in the future revisions, we will be further modifying and further elaborate all these provisions while we will gain more experience with the use of these concrete systems, and also based on the feedback which will be received from the construction industry. So this is the clause number 12, and thereafter we have added annexures to supplement the clauses which are there given in the draft standard. Most of the annexures basically are for the information. Some are also for giving the guidelines. So this is all the entire framework of this draft standard, and so this is all from my end. Thank you very much. So if anybody is having any question, we can take 2-3 questions over here, and then we can move to the next sessions. So any questions? Quick questions? Sir. Sir. Mehti sir.
This steel LP550. Actually, 1786 covering up to 600 or 66. So are you going to delete those things from 1786? Because they are coming up to 550.
Yeah, it will be harmonized with IS 1786 because that is the parent code for the material requirement. Okay, so that we will harmonize with 456. Okay, yeah. Next, Tandon sir.
Yeah, just a couple of suggestions.
Sure, sir.
This categories of structure that we put here. There is some difference between this and 1893 as far as saw. But this has come from 1893. That is the first time that we saw these categories of structure. I think we should have a harmonization of these.
Yes.
The second thing is that this category, the special structures which are being I think it should be removed. We've already got 3 more. There is R1, there is important, there is critical. Now you make special also. Sorry, because when you start looking at the code and applying it, for every type of structure, even the concrete cover has to be calculated. So why do you want to have so many categories? I am not able to understand. Perhaps there is some reason for it. But I think that it should be seriously thought of what to do. Now, a simple thing like concrete cover to determine. You have got so many calculations to be done. For normal structures, it is given. But normal structures is the lowest category of all these things. If you have a slightly higher category, you have to start calculating the cover. Okay. But I think that this is making the code practically difficult to use. I mean, I am not debating whether the thing is here, but we are not doing research here.
Not from the content consultants.
No. You see, we are not doing research here. We are making a code of practice. It is called code of practice still, I think. So people who are practicing structural engineering should be able to, decide about the concrete cover in a matter of 2 minutes?
I think you should hear.
Okay. This is just my suggestion. And even for whether there is chloride, whether there is carbonation, there is a different calculation to be done to find the cover. I mean, that is something which we should seriously think. That is only my suggestion. I am not debating whether what has been put here is right or wrong. I mean, technically it may be right.
I think we should discuss it after Mr. Arora finishes his
Okay.
presentation.
Other thing is about this table 53, which has got crack width. I think that definitely requires to be changed. You cannot have 0.1 millimeter crack width as if it is just 0.3, 0.2, 0.1 like that.
That is mistake. That will be corrected.
कभी भी zero भी है कहीं पे. Crack width 0.
That table need to be corrected.
Okay.
That, sir, that will be corrected, sir, because it is a draft standard. We are taking feedback. You have suggested very good points. Of course, we will take care. We will deliberate it more, and
Yes.
we will do the corrections as required.
Thank you,
Sir,
Thank you, sir.
Abhay, you can just open mic. Yeah. I think you are having some question. Acha, yeah. Okay. Yeah, please. Mic open कर लीजिएगा.
by introducing quality assurance and quantity. What, if I'm not wrong, as per the your cube sampling and all. So it has been mentioned that if the concrete is being taken from RMC units, then the frequency have to be changed from 50 cubic meters per one set per 50. Now my suggestion here is that in India, almost 90 to 80 to 90% of the RMC units which are there are not standardized or QCI certified or BIS certified. So there may be a chance of that the quality of concrete may be compromised, or there may not be that robustness. So if some different sampling can be yeah, so durability of concrete. I correct myself. Sorry. So durability of concrete. I think if we stick to the current sampling frequency, then there is definitely some better quality assurance which can happen. Just small suggestion only.
First of all, congratulations for bringing out an overall overhauled version of the document with a large gap. So trying to cover so many of things from the research many organizations are doing. As a practicing consultant, we have been facing a problem or a difficulty while we were using the earlier or the current version of the code. And I believe that when we take up the revision of the code, as Dr. Kurian has shown in the beginning, that why the code is being revised. So incorporating latest development, this, that, showed 3 points. But one of the important thing which is missing, I believe, is feedback from the users regarding the difficulties, confusions, and misinterpretations in using the document. We have been debating on many projects when we do the design and a proof consultant is there is a big challenge as a practicing consultant we face. So there should be a mechanism of taking a feedback that should also form the basis of the revision. So I don't see that feedback is there. I don't know whether there is a channel of feedback, whether we can say कि भैया ये तो समझ ही नहीं आ रहा मुझे क्या करना क्या है कोड में क्या लिखा है मैं कुछ और समझ रहा हूँ मेरे सामने वाला कंसल्टेंट और समझता है. So this is one, that feedback about the difficulties and confusions from the existing document should be rectified in the revised version. One very important point is about the joints in the concrete structure. We just have 9.4.1.5 relative movements at joint. Every small and very vague version. The length of a structure in which where expansion joints have to be provided shall be determined after considering various factors. For example, this is normally structures exceeding 45 meter in length are designed with one or more, वो NOR print हो गया, one or more expansion joints. But the user, if you take the feedback, providing an expansion joint in a structure is a nightmare for the life of the building. Its maintenance, its durability, all the expansion joint leaks and create the problem. So we have learned how to design the building without expansion joint or longer buildings, 100 meter, 200 meter. We have designed 300 meter building. But there is no clear-cut mention or details about the joints, particularly expansion joint in the buildings, in the concrete building, in the code. I am referring to a book by Mark Fintel, Handbook of Concrete Engineering. Its one chapter gives such a wonderful treatment of the joints. Maybe if that can be incorporated as a separate chapter, that will help a lot to all the designers and the executors. That is wonderful treatment. About the shrinkage strip, we do not use the word shrinkage strip in the code, while it is being provided at almost all the projects. It is there. It is a very important aspect. So shrinkage strip, expansion joint, with buildings without expansion joint should be there. Temperature load calculation. There is a huge debate. Professor Varyani in his book has written something very good, and people do not understand well. Many people, I'll say, that how to take care of that temperature stress. Probably those calculations are needed here in that document. I'm sorry that I did not send those comments earlier, but today I got the opportunity, so I'm just speaking. So these are some of the things which I would like to bring to your notice and solution. Thank you.
Yeah, thank you, sir. Basically, you have pointed your feedback basically, and we will try to improve the provisions regarding the joint. If required, we can get an additional annexure for the basically joints. How we can improve those particular provisions. Okay, thank you very much. Achha. Sir, sir.
First comment was very interesting comment that we are not looking at the feedback. The feedback. In fact, I explained the system because of that. When the people at the working group level make it, by the time it comes to the panel, that particular criticized by the entire CD2 people, we got 750 comments at that level. And then now after that, all those rectification has been done. It is sent for wide circulation. And I don't know how many you have received. It's more than 1,500 comments have come. So that we'll definitely look into those comments before we finalize the whole thing. Thank you very much for that one. The other thing is that I don't know, Chaudhary should have explained that this code is not the end product. We have got two more companion volumes to come with us. One is an explanatory handbook, explanatory commentary should come. The same working groups are being assigned that each of them should work and give a commentary. So that will explain what is the reason behind each of those changes will come. Along with that, we will also publish a handbook, how to use this particular code. These two should come immediately, but how long will take depends on so many, because it depends on how many people work with us to do that. That will only make the whole thing clear to you. I agree with you. It is a lot of...
I have points on this. Sir, what feedback you are saying is comments on the draft report, which is there. I am talking about the feedback on the existing document. It is much different than the comments on the draft report. ये तो आपने जब चेंज कर दिया, that time people are saying ये होना चाहिए या ये समझ नहीं आ रहा है वैसा. But अभी जो use कर रहे हैं, वो नहीं आ रहा सर consistency.
Sir, one minute, let me correct it. It's not correct statement. We continue to get such observations from the field, and invariably they are discussed in each of these committee meetings, and wherever necessary an amendment is issued. The background of why amendment is issued because of the critique from the field. So this is a process, continues after it is published, continues forever.
Yeah,
So
please let me know where I can send those feedbacks. As
Yeah, sure.
If it is there, okay.
Sure, sir.
Second,
Sir, I think, sir,
second thing is on the same. When there is a handbook or the explanatory, actually such a sea change in a document will certainly need few months for the practicing people, even academicians, to learn and deliver. So there should be a conditioning period when this code is delivered.
Yes, sir, it will be
Both
there.
the codes should be applicable for a longer.
No, sir, it will be there. It will be there. I think we can take one more comment and we can close. Okay, we can discuss other things. I think participant can discuss with the speakers in the breaks basically. Okay, I think, madam, one comment. Yeah.
My suggestion is about the handbook, because we are dividing the structure in the 4 categories, and then in IS 456 we are saying converting it to 3 categories, special or something. 2 are combined together. So for these 3 type of structure in handbook, we should have the solved examples complete, because only then the people will be able to implement it, and in that the various variations of the water should be given. That if water of this category, the problem is like this. And something about the curing aspect also has to be covered, that if admixtures are used, how the curing is done. Say special admixtures somebody is. So that is very important, which should be included maybe in the code or maybe in the explanatory handbook.
Okay. Thank you, madam. Thank you. I think we can go to the next session. Sai, you can take it.
Thank you, sir, for providing a brief structure of new revision IS 456 and explaining the scope of various clauses involved. Now we go to the next session. I invite Shri P.N. Oja, Joint Director, National Council of Cement and Building Materials, Balabghar. Shri P.N. Oja, currently serving as chairperson of Cement Matrix Product Sectional Committee, CD 53. Bureau of Indian Standards, and is an active member of several other important BIS committees, including Civil Engineering Division Council, Cement and Concrete Sectional Committee CED2, Structural Safety Sectional Committee CED37, National Building Code Sectional Committee CED46, and Concrete Reinforcement Sectional Committee CED54. He is also serving as convener and member of multiple BIS panels and working groups responsible for revision of key Indian standards, including IS 383, IS 2386, IS 516, and many more. At international level, Shri P.N. Oja represents BIS in turn India as an expert member in ISO technical committees that are relevant to concrete, cement, and lime. Shri P.N. Oja has also published more than 125 research papers in international journals and conferences. With his extensive expertise in cement, concrete technology, durability, and alternative materials, he has made significant contributions towards development of Indian standards. I request Shri P.N. Oja to deliver his presentation on requirements of structural materials.
So thank you very much for giving me this opportunity. Actually, whatever I wanted to speak, the 50% of the things Jitendra ji has already spoken about the materials. So structural materials and mostly concrete making materials. Concrete is a structural material first. And as a structural materials, there are 3-4 aspects. What is the input materials? So input materials aggregate, cement, water, chemical admixture, and mineral admixture. And all those should satisfy their respective standards. So this is a fundamental. Okay. So the satisfying the requirement is a specification. But a story doesn't end here. All the materials which is complying the specification is not suitable for all use. So application, so selection of material as per application should be understood by the civil engineers. And particularly I will emphasize on that part because the requirement, as in my one word, they should satisfy their respective standards. Okay. Then third aspect is after specification, then material selection, and then third aspect is after selecting concrete mix proportioning. So concrete mix proportioning earlier it was mainly for strength. Okay. So strength, and then for when we are designing the concrete for strength, constructability requirement is there, so workability is also there. In earlier also, we are having provisions in IS 456, presently existing IS 456. There is a table in which we have some prescriptive requirements, and according to that, minimum cement content, maximum water cement ratio, and all those things. Taking care of that, we were satisfying the durability criteria also. But the things is changing now. So we will have to understand the materials when we are going for the design for durability, because which materials a little bit better performance in which exposure condition, and when we are dealing with the which design criteria, particularly in the design for durability, which exposure conditions. So I will be focusing my presentation a little bit on these aspects. So structural material, chapter 7, as Jitendra ji said. Okay, I cannot go here because mic is here. Okay. So, yes, I will be comfortable in that. So, when I will be focusing on mainly concrete and ingredients only. So, aggregates first. So, aggregates, the simple word has been written, the complying with the requirements laid in IS 383. So, it directly refers to IS 383, only one line. So, one line is not sufficient. So, anyone who is dealing with IS 456, it refers that he must understood the IS 383, what it is requirement, what there is a requirement. Here is only one line. So let us discuss IS 383 a little bit. So IS 383, as Jitendra said, we are revising it in two parts. The first part is coarse and fine aggregate for concrete, and the second part, fine aggregate for masonry and plaster. So earlier, these two, masonry and plaster, we are having two codes now here. And when this will come, that code will be withdrawn. In this IS 383 part 1, we are defining the aggregate coming from the two sources, natural sources and other than natural sources. And here is a catch. So right now, whatever is, the people are understanding, and people are understanding natural aggregate and manufactured aggregate. What manufactured aggregate is, most of the time they understand crushed aggregate is a manufactured aggregate, but it is not like that. So everywhere, Delhi, Mumbai, everywhere, the crushed aggregate is being called manufactured aggregate, which is not right. Okay, so this nomenclature is being taken care by these two categories, natural aggregates and other than natural aggregate. Okay, very brief I am explaining. And there are the definitions, terminology, natural sand, crushed sand, mixed sand, fine aggregate, and composite fine aggregate. So this is for fine aggregate, and coarse aggregate, uncrushed, crushed, mixed, coarse aggregate from other than natural sources, and composite coarse aggregate. So why mixed coarse aggregate and composite coarse aggregate? So composite coarse aggregate, when the two natural sources and other than natural sources, the two type of aggregates are being mixed as per stipulation in IS 383, then it can be called composite aggregate. So all these definitions are there. And again, all in aggregate, and then heavyweight aggregate and lightweight aggregate. What can go through the IS 383 part 1. It has come out from the wide circulation. The comments has been dealt. CD2 has decided to publish this standard. So one can go through that. Okay. And if you will see, all the requirements, a specification of aggregate has been placed in the four categories of properties, and that is the physical requirement, the physical property, mechanical requirements. It is sometimes must, so mechanical requirements, mechanical properties. The third category is durability requirements. So durability properties, and most of the time it is dimensional stability of concrete when any kind of aggregate is being used. And the fourth is chemical and hazardous substances requirements, because when we are dealing with the industrial waste as an aggregate, this clause is must, and these properties are must. And according to these four requirements, I'm coming to that first. And in this IS 383, these are the aggregates from the other than natural sources. Some limits are there. And if for fine aggregate, these are the sources of aggregates other than natural sources. And you might see bottom as aggregate, fine aggregate has been there. And how to design, we have developed a concrete mix design methodology also. Perhaps 10262 will be revised, then we will incorporate that example also. But here the percentage has been given. Okay, and corresponding to those four categories, the IS 2386, which is a test method for aggregate, that has been revised, and corresponding to the first, all the test method for physical properties of aggregate has been placed in the first category, part 1, determination of physical property. So 18, 19 tests are there, and one of the most important tests is angularity number we have introduced. And what benefit of angularity number is, one can select the fine aggregate and coarse aggregate to have a better packing density to produce a higher grade of concrete. Okay, so that is the benefit of involving the angularity number. One can go through the provisions. And second is determination of mechanical property. So apart from the three mechanical property we used to, there are other mechanical properties. Same mechanical properties in dry state and wet state, sometimes polished stone value for pavement concrete, all those things. Those were not there. So we have introduced in this. So this is the second category. Again, durability category means the specific, all these durability, dimensional stability problem related with the strength, related with aggregate has been placed here. One is weathering action and due to sulfate and exposing the sulfate. And the second is alkali aggregate reactions. So different tests, and to mitigate that, those are the different provisions. According to that, all those tests had been included here. And other tests like pre-lime unsoundness or iron unsoundness, all those tests has been there. Okay, and provisions and specification is in IS 383. And the fourth one, the chemical requirements are hazardous substances. These test methods has been put here in the fourth category. And since petrographic examination of aggregate is not a test, it's examination, so it has a separate standard. So in this way, the aggregate system, so not only a specification, but test method has also been revised. And before that, we thought that before IS 456 coming, these standards should be revised. And to have a representative sample of aggregates from the sources, which can be tested in the laboratory, how to get the representative sample. So sampling plan. So there is a sampling method, IS 2430, very old code was there, that has also been revised. So this is only for the information of all of you. Now coming to the cement, Jitendra ji has already said, we have a two category. One category of cement is for general use. Okay, so OPC, PSC, PPC, both type, composite cement and limestone cement. So, and they should satisfy their standards. And this is the specific applications, but I will focus how to select the cement for a particular use. So I am not reading each specifications right now. So let us see. I am not crossing my boundary, because I will have to deal when the selection of cement is done required. Then I will have to talk something about the durability. Okay. So the first design for durability is design for carbonation-induced corrosion environment. Okay. So when you are selecting any cement, so first is, so we should know at a particular water cement ratio, what is the this value of KCK. KCK means carbonation coefficient. And for carbonation coefficient, higher the value of carbonation coefficient, lower is the resistance provided by the concrete, means the more vulnerable the concrete is for the carbonation. So one can simply calculate at a particular given water cement ratio for all type of cement, and one can see that. So I have taken the example at water cement ratio, Rasan likh diya hai sahab. So sorry. So at water cement ratio of 0.5, KCK value is 2. If you will put that water cement ratio in that formula, so it will come 2. And same water cement ratio for PPC and PSC, if you will put, it's come 4.55. So which one is better in carbonation-induced corrosion environment? One can easily understood. And the method is higher value of carbonation coefficient, lower is the resistance provided by the concrete. So this is the formula available in the draft code. Okay. So if it is accepted, one can have this idea to select your kind of cement for a particular use, right? And other percentage, how to calculate, this formula also gives some idea, some notes. Okay. Now, coming to the resistance provided by the concrete against chloride-induced corrosion. So this is the formula. And chloride-induced corrosion, how it happens? When chloride enters inside the concrete and reaches at the reinforcement level beyond a threshold limit, then this is the limit state, and the resistance provided by the concrete against chloride-induced corrosion environment is represented by chloride diffusion coefficient. So let us calculate the chloride diffusion coefficient. In that one, carbonation, in this chloride diffusion coefficient for each type of cement. So this is the formula has been given. And the one thing we should mind it, higher the value of chloride diffusion coefficient, lower is the resistance provided by the concrete against chloride ingress. So let us calculate for M35 grade of concrete, because that is the lower grade of concrete in chloride-induced corrosion environment at a sea coast, and that's why I have taken M35. So for M35, at water cement ratio 0.4, at which chloride diffusion coefficient comes 277.6 mm square for OPC. And it comes 125.7 mm square per year for PPC. And it comes 57 mm square per year for PSC. So which one is better? Anyone? Which one is? PSC. So PSC is better. If you have option, you can select PSC. It clearly shows. So when you are designing for durability and when you are selecting the type of cement, you should have all these points in mind. And according to that, you can select the material and then do the concrete mix proportioning, and you can adopt at your project. Okay. Cost and all those things will evolve. RMCA strategy will also evolve with due course of time. Okay. Third, this table has been given when we are designing for durability, and this chloride diffusion coefficient, electrical resistivity, and RCT, the value, the relationship has been given in a tabular form. So what is the in fourth column remarks? With OPC, it may not be possible to obtain chloride diffusion coefficient less than 200. It is not possible. For lower value, blended cement needs to be used. The last line, with PPC, values of chloride diffusion coefficient less than 0 may not be possible. And then third statement is, for values less than 100, PSC needs to be used. So again, whatever has been explained in the previous slide, this point also reinforced this concept. PSC is better, then PPC, then OPC. So one can select, and this also indicates how to select the cement. In which I am talking about now chloride-induced corrosion. If your structure is in carbonation-induced corrosion, I have explained in the previous slide. Okay, so the 2 points. So now the third aspect of durability is what? Sulfate. So sulfate in problem, how to select the cement. So this table has been given, and that is the exposure class according to the sulfate: S0, S1, S2, S3. No risk, moderate, severe risk, very severe. And very severe is with related to the magnesium sulfate. So magnesium sulfate is more dangerous than sodium sulfate or any other sulfate. And for that reason, the sodium sulfate has been categorized in the S3, the severest, very severe category. Okay. So you see the last column of this table, type of cement shall be used. So in the first category, all cement permitted for reinforced concrete. But in the second and third, except OPC, almost all the cements are there. So what does it indicate? OPC doesn't perform well in the sulfate attack situation. Okay, and this third category, all the cements is equally good, but you will have to lower down the water cement ratio. Okay, and in the fourth category, only sulfate resistant cement or Portland pozzolana cement is applicable, and even if more severe, then some membrane will have the concrete surface, outer concrete surface. So all these three slides, 4 slides, whatever I have explained, clearly indicates how to select the cement. And when a structural design says, no, आप एक thumb rule दे दीजिए, थोड़ा सा मटेरियल साइंस को भी जो कंक्रीट से डील करते हैं उनको इज्जत दीजिए, कंसल्ट कीजिए, अपने साथ रखिए और सलाह लीजिए. ओके है? ये तो ड्राफ्ट कोड में है सर, आपके हाथ में है. मैं वहीं से लिया है, ये कोई नया जनरेट नहीं किया है सर, वो भी वहीं का है सर, केवल कैलकुलेशन कर दिया है थोड़ा सा नॉट मच। और एक चीज और लिखा हुआ है कि where chloride and sulfates in the soil and groundwater is there. So most of the time in coastal area, when the structure is there and the structure has two parts, one is superstructure and one is substructure. So आधा जमीन के नीचे, आधा नहीं बोलिए, मान लीजिए कि ऊंचा बिल्डिंग है तो 10%, 20%, तो कुछ जमीन के नीचे, ज्यादा जमीन के ऊपर, लेकिन कुछ पोर्शन है जस्ट लाइक स्प्लैशिंग जोन, जस्ट लाइक नॉट स्प्लैशिंग जोन, जस्ट लाइक स्प्लैशिंग जोन, जो थोड़ा ग्राउंड के नीचे है और थोड़ा ग्राउंड के ऊपर है। उसमें क्या है कि द अवेलेबिलिटी ऑफ ऑक्सीजन एंड वाटर बोथ आर देयर, एंड इफ क्लोराइड इज आल्सो देयर इन द सॉइल, sulfate is also there in the soil, then with availability of oxygen and water, there is a severe chances of not only sulfate attack, but corrosion also. Okay. So in that case, the line 3, the note line 3, where chloride encounter with sulfate in soils and groundwater, ordinary Portland cement with C3A content from 5 to 8% shall be desirable. Because C3A ज्यादा होना भी खराब है और कम होना भी खराब है। कम अगर है तो क्या होगा, ज्यादा होगा तो क्या होगा। एक में इट्स रिलेटेड विद द रिएक्शन ऑफ C3A and chloride binding capacity of the system. So from that point of view, it should be in the middle range. Okay. So that point will also have to be. And अगर ऐसा नहीं हो रहा है तो क्लियरली लिखा हुआ है कि स्लैग सीमेंट इस्तेमाल कीजिए, वो इस टेबल से भी क्लियर होता है। Okay, so using the and type of cement, selecting the type of cement, कोड में सब है, इंटरप्रिटेशन की जरूरत है, वही मैंने बोला मटेरियल साइंस को थोड़ा इज्जत दीजिए, ठीक है? आप देंगे, मैं जान रहा हूं। बनाना है, आपको बोला ना कि ओपीसी उसमें भी है, ऐसा नहीं है। मटेरियल इज स्केर्स, जहां रिक्वायरमेंट है वहां है। अभी आ रहे हैं, अभी मिनरल एडमिक्सचर नहीं डील किया है, सो वी आर कमिंग। नहीं, यहाँ M50 लिखा हुआ है। M50 we can get, we will have to design. If we are not giving, just a minute. If we are not getting, we have an option to select OPC and put GGBS. We have option. Mineral admixtures are there, so we have option. Okay.
This comes under what class of designation? I want to go S2,
ये एक्स्ट्रा है, इसीलिए तो नोट में दिया हुआ है। ये चारों क्लास में नहीं आ रहा है, इसलिए ये नोट में दिया हुआ है। सल्फेट रेजिस्टिंग सीमेंट क्या है? इट इज बेटर, बट अगर नहीं है तो आप इस्तेमाल करिए। हाँ, ये आपका पॉइंट यहाँ पर एक मिस ये मेंशन करना चाहिए। हाँ, वो आपकी बात, पीएससी ऐड करना चाहिए विथ प्रिकॉशन। यू आर राइट। सो देन कमिंग टू द, और भी ये नोट्स को ठीक से पढ़ने की जरूरत है। नोट्स में अपार्ट फ्रॉम दैट वो थोड़ा सा ये है, तो नोट्स को ठीक से पढ़ने की जरूरत है। ओके, देन नाउ कमिंग टू द जनरल रिमार्क्स, वेयर टू यूज डिफरेंशिएट।
Oja sir, just a minute, sir. People who are asking the questions now, please use the mic because we have the audience on the YouTube channel also. They also want to hear your questions. Okay.
Okay.
So you use the mic only.
So general statement for selection of cement. OPC can be used for PCC, RCC, pre-stress concrete, but marine condition mein it is not good, and chemically aggressive environment mein it is also not good. It has been just shown from the slides. Okay, this conclusion is coming from the slide. PCC, RCC, pre-stress concrete, PPC can be used a little bit slower strength compared to OPC, needs extended curing, good for marine environment, and careful about calcined clay cement. अभी ज्यादा proven नहीं है. Be careful. Okay, calcined clay based cement, क्योंकि बहुत कम प्रोड्यूस ही नहीं हो रहा है. calcined clay based PPC नहीं प्रोड्यूस हो रहा है. And PSC, it can be used for PCC, RCC, pre-stress concrete in foundation, particularly where a splash zone, and I have given the example, and only slightly slower strength development compared to OPC, excellent for marine environment and chemical attack. वो slide भी prove करता है. Composite cement can be used PCC, RCC, pre-stress concrete in mass concrete and foundation, a little bit slower strength development compared to OPC, needs extended curing, good for chemical attack environment, but relatively higher carbonation, need a special consideration in mixed design if we want to use in the carbon. Okay. Then LC3, बड़ा बात चल रही है LC3 की. So it can be used PCC, RCC, pre-stress concrete, slightly slower strength development in comparison to OPC, good for chemical attack condition because it incorporates those materials, relatively higher carbonation, needs a special consideration in mixed design if we are in. और वो मेंशन हुआ है कितना से वाटर सीमेंट रेशियो को कम करना चाहिए सेम कंडीशन के लिए, and shall not be used in very low temperature environment because limestone in there and thaumasite formation can take place, so it should not be used in the lower temperature environment. And HSC, high alumina cement, refractory in furnaces, kilns, chimney, general purpose cement नहीं है. And SSC, super sulfated cement, it's mainly marine concrete के लिए और foundation के लिए use होता है. High resistance to chemical attack, low heat of hydration, and excellent durability in marine and acidic environment. Requires wet curing for at least 3 days to prevent surface powdering. It is less suitable for high temperature application and not recommended for steam curing. So ये मतलब with care use करना चाहिए. Materials जब हर सीमेंट बना हुआ है तो इसका different purpose है and differently application. वो अपने अपने respective standard को satisfy करेगा, but that is not all. We will have to know for our application purpose.
Sir, can I?
Yes.
Yes, sir. Here, mic आ गया ना sir?
बोलिए.
There are many projects where we have thick rafts, 3 meter, 4 meter thick in the high-rise buildings. And there is an invariably problem of the heat of hydration, temperature cracking and all that. So they suggest, Vineet Bajaj, my friend, he suggests go for the temperature controlled concrete. It's very difficult unless and until you have a concrete technologist on the project guiding you. But none of these cements which you have shown is advising to be used for that mass concrete of the raft as it is.
So कोई सीमेंट इसमें टेम्परेचर कंट्रोल्ड सीमेंट नहीं है. आपने बोला वो टेम्परेचर कंट्रोल्ड कंक्रीट, एंड कंक्रीट शुड बी डिजाइन्ड to have a lowest possible heat of hydration. Correct. And a mock test should be conducted to confirm, and then appropriate precautions will have to be taken at site also.
Are we including? Are you including that statement in the code?
In mass concrete, we have mentioned कितना thickness के बाद उसको mass concrete बोला जाएगा, और क्या precaution, but only it is a guideline, not detail. Consult whenever project is going on.
Design section में Amandeep, you must deal with that.
प्रचार नहीं कर रहा हूँ मैं अपना.
नहीं, that's another thing. Consultant is required everywhere.
So when there is such type of a specific requirement, then you will have to consult, जो मैं बार बार बोल रहा हूँ, and then उसकी डिजाइन होगा, then उसकी मॉक स्टडी होगी, सीमेंट का भी हीट ऑफ हाइड्रेशन होगा, कंबाइंड जिसमें वो अपना आप मिनरल एंड मिक्सचर मिलाएंगे उसको मिला करके होगा. सो स्ट्रेंथ रिक्वायरमेंट, एज वेल प्रॉब्लम कहाँ होता है, डैम कंक्रीट में ज्यादा प्रॉब्लम नहीं होता है, बिकॉज द ग्रेड ऑफ कंक्रीट इज 15 और समटाइम्स एंड दैट टू एट 90 days, so minimum cement and cementitious content and one can design easily. We are doing it, but where is the problem? When tall building designed by Madam Alpa Seth, most of the time she is expert of the
No,
tall building.
please, sir.
Just
I'm saying we are also facing the same problem.
Okay, CD 38 की head है, just it is a joking example.
Actually, 16700 specifies certain norms.
Yes. So when we are doing it a foundation for the tall buildings, most of the time it is going more than 1.2 meter.
Yes.
And when the foundation is going more than 1.2 meter, it comes under the mass concrete.
So nothing is
And
mentioned
when
in
mass
the
concrete-
16700 also for that. I'm saying somewhere.
Irony is वो अपने jurisdiction से बाहर जाके yesterday there was a meeting of CEDC. Okay. So उन्होंने provision किया है अपने jurisdiction से बाहर जाके that वो ये होना चाहिए, वो होना चाहिए, that is beyond jurisdiction. उनको mass concrete में CD2 को refer करना चाहिए.
Jitendra, please note
Because
down.
whatever the concrete.
Sir, this aspect we have noted down, sir. We will take care in the relevant committee, sir. Okay.
Concrete पे उस code में वो analysis of design का standard है. बट वो सारे मतलब सारे प्रॉब्लम तो आप नहीं डील कर देंगे ना. आप जैसे मान लीजिए कि देयर इज ए प्रोविजन ऑफ हाउ टू डील विद द श्रिंकेज एंड क्रीप एनालिसिस इन द केस ऑफ टॉल बिल्डिंग. देयर इज एनालिसिस, बट एनालिसिस करना ठीक है, बट हाउ टू डिटरमिन द क्रीप ऑफ कंक्रीट, दैट इज नॉट योर कप ऑफ टी. हाउ टू डिटरमिन द श्रिंकेज, ऑटोजोनस श्रिंकेज एंड ड्राइंग श्रिंकेज, दैट इज नॉट योर कप ऑफ टी. सो फॉर डिटरमिनिंग दोज प्रॉपर्टी you should consult the testing laboratory material scientist who is expert. So मैं अपना बात नहीं बोल
Put that into material section.
हाँ, NCB को refer करिए. Okay.
Sir, Oja sir, please sir stick to the presentation, sir. Okay.
So
Time is running.
discussion हो गया तो. So implication of cement type is need to be aware of relative advantage but limitation also. Strength development rates could be different. Curing requirements can also be different. But concrete can be designed to achieve the desired characteristics. So this second point is very, very important. One can design the concrete for requirements. Whatever the requirements from concrete we are expecting. And remember, it is a concrete we are designing. Choice of cement may not matter of a structural consideration except for certain circumstances for durability. So one can design, अब ये कि कार्बोनेशन कोफिशिएंट ओपीसी का कम था और पीपीसी का ज्यादा था, तो केवल पीपीसी ही इस्तेमाल होना चाहिए, सॉरी पीपीसी नहीं इस्तेमाल होना चाहिए, ऐसा नहीं है. वन कैन डिजाइन विद द पीपीसी. देयर आर अदर मटेरियल्स आल्सो, कोरोजन इनहिबिटर है, केमिकल एडमिक्सचर है, यू कैन लोअर डाउन द वाटर सीमेंट रेशियो, बट यू नीड टू ब्रिंग डाउन द कार्बोनेशन कोफिशिएंट इन द रेंज फॉर व्हिच यू आर डिजाइनिंग योर स्ट्रक्चर. That is important, and this is the philosophy behind design for durability, which Arora Sahab will be explaining to you. Okay.
Dr. Oja, मेरा एक छोटा सा question about strength development rates. The previous table also shows the strength development rates are different for
वो सब मैडम qualitative statements हैं.
Yeah.
ये qualitative statements, relative statements हैं. डिजाइन, ये इस स्लाइड का मीनिंग है कि प्रीवियस स्लाइड में जो भी कहा गया है, यू मस्ट डिजाइन द कंक्रीट फॉर स्पेसिफिक रिक्वायरमेंट, ये बात मैं बोल रहा हूँ.
नहीं, बट डेवलपमेंट रेट्स आर डिफरेंट. दोस रेट्स आर strength rates are given in the code, or for that the expert has to be contacted.
सब चीज रिक्वायरमेंट स्पेसिफिकेशन में दिया हुआ है, 3 days, 7 days, 28 days strength for a specific cement, but that is a requirement, that is a specification. What is your cement is that can have over and above. तो all those criteria वो जानना चाहिए, और उसके बेसिस पे कंक्रीट को जो रिक्वायरमेंट है मेरे स्ट्रक्चर का, मेरे एक्सपोजर कंडीशन में, फॉर विच आई एम गोइंग टू डिजाइन, द कंक्रीट शैल बी डिजाइन. और राइट नाउ हम जो मेरा बोलने का फर्स्ट सेंटेंस था कि वी आर डिजाइनिंग फॉर स्ट्रेंथ, we were designing for constructability requirement in terms of workability and to some extent durability. Now it is elaborated procedure is there. For simple structure, there is a table. Arora Sahab will be explaining to you. But for difficult structure, having service life more than 50 years, you need to select the materials, and cement and cementitious material is one of them.
For normal structure, we can refer the code, but for
Madam, ये सब चीजें थोड़ा सा मैडम थोड़ा सा एलिबोरेट में डिस्कस करेंगे ड्यूरिंग द पैनल डिस्कशन. वी हैव ए पैनल डिस्कशन एट द एंड. Okay, combined together, whatever the question will be, we will discuss it. So remember, the concrete we are designing, choices of cement doesn't matter. Then fourth point is, need to choose cement in a way that to increase overall sustainability. This is also a guideline, but it has not been written specifically. Overall sustainability means lower CO2 emission, lower environmental impact, and enhanced material circularity. Next code may have some clauses also on this. Okay. And then ingredients, mineral admixture or supplementary cementitious material. So fly ash up to 35% replacement, higher level allowed when water cement ratio is less than 0.4. And why it is? Because fly ash se problem hota hai carbonation induced corrosion environment ka, but if the water cement ratio of concrete is less than 0.4, wo diffusion of carbon dioxide becomes less, and that's why it has been allowed. And if the grade of concrete is more than M40, durability requirements are met. Minimum fineness 280, and this is deviating from IS 3812. IS 3812 in the future, that will also be revised. And silica fume up to 3 to 10%, metakaolin up to 15%, GGBS up to 50% for RCC, and in case of sulfate attack and alkali silica reaction, mitigation can be up to 60%. So there also a little bit relaxation has been given. And ultra fine granulated blast furnace like UGGBS up to 20%, and ultra fine fly ash up to 20%. So this is the recommendation of the supplementary cementitious material and ultra fine supplementary cementitious material. This is, sir, this is not degrading. Actually, what you understand that it is crossing 320 meters square per kg. All the test reports are manufactured because we have sampled almost 20 power plants, and no one is producing the fly ash because they are not producing fly ash. So the no one's fly ash is 320. No one. We have done the experiments, we have done the research, we have compiled the test data, and we have given the amendments draft also to the BIS. But BIS have so many works, so right now it is not being discussed. It will be discussed in due course of time.
Okay, thank you.
Okay. So pre-stressing for material, concrete for pre-stressing is same for RCC, sir. So right now I am talking about the concrete making materials. वो भी ये अब आप ये लिखवा दीजिए कि आरसीसी एनपीसी प्री स्ट्रेस कंक्रीट अगर इतना स्पेसिफिक है तो we should modify.
What about maximum cement content?
That is missing.
Maximum cement content.
That is missing. I will be coming. अगर नहीं होगा तो कर लेंगे. ठीक है. Then combination of fly ash and GGBS. So mostly people are get confused in terms of loading. Sometimes वो batching plant में बोलते हैं कि 3-4 component mix करना possible नहीं होता है, वो भी एक problem होता है. तो we have limited allowed. ये philosophy है committee का. And total 45% से ज़्यादा नहीं होना चाहिए. Fly ash maximum 20% and GGBS maximum 25%. So this is the recommendation of the committee. Okay. And combination of ultra fine material with fly ash and GGBS. This is ultra fine materials, the purpose is different, and fly ash and GGBS purpose is different. So the committee thought fly ash when it is with silica fume, दोनों मिला के 35%, and जो ultra fine additive है means silica fume up to 10%. Fly ash, ultra fine fly ash 35%, ultra fine fly ash can be up to 20%. Fly ash, ultra fine GGBS maximum 35%, and ultra fine GGBS can be 20%. When ultra fine GGBS is being used, GGBS maximum 50%, and GGBS with silica fume 60 maximum, 10% silica fume, and GGBS with ultra fine GGBS maximum 60, 20 can be ultra fine GGBS. So this is the recommendation. And again, for PPC and PSUs, this clause comes. So this is when combination is there. Now coming to the fourth component, chemical admixture. It should satisfy the IS 9103 requirement, and there are so many clauses to deal with that. One can go through it. Now I am coming to the chloride content shall not be independently tested for each batch before acceptance. All these things are there. It is a very, very easy. One can understand and can make a comment if it is not understood. But now coming to the chemical admixture, this is the tabular form which has been given. And what we indicate is air entraining agent, retarding, accelerating, water reducing, high range water reducing, shrinkage reducing, corrosion inhibitor, and permeability reducers. And a typical active constituents has been allowed. Other than that can also be, but the intended purpose is in the table number 2nd. So all these admixtures is allowed, okay? And right now we do not have evaluation purpose for all these admixtures, chemical admixtures. And for all, one thing is shrinkage reducing admixture has been allowed. Shrinkage compensating admixture is not allowed. So a specific line is there. We don't allow the shrinkage compensating agent. Okay. And for all these, we are revising the IS 9103 in 7 parts. These are the 7 parts. All the draft has been submitted to the BIS by NCB, and it is under discussion. And I hope before IS 456, all these parts will come. Okay. So, and each standard, each of them, there are 3 type of requirement: general requirement, a specific performance requirement for whatever the intended purpose is, and compatibility requirement, because most of the time more than one type of admixtures are being used in the concrete. Now concrete has become multi-component concrete, so these standards are under development. And for water, these are the testing requirement Jitendra ji had discussed, so I will not devote much time. And this table he has also discussed, so I will not devote much time. Grade of concrete up to M80 grade has been allowed. And sir, वहां पर प्री स्ट्रेसिंग आ रहा है सर, हालांकि जितेंद्र जी ने भी डिस्कस किया है. सो प्री स्ट्रेस कंक्रीट, पोस्ट टेंशनिंग मिनिमम ग्रेड M35, प्री टेंशनिंग M40 और स्टैंडर्ड डिविएशन, ये सब चीजें दी हुई हैं स्टैंडर्ड में. वो कंफ्यूजिंग है, तो प्री स्ट्रेस कंक्रीट हम बोलेंगे सर. हाँ. So now, after all these materials specifications and how to select, what will be the impact on concrete mix design? What other information is needed, which is right now available in 10262. So you can see the level of quality assurance, jo Jitendra ne bola, we will have to define, because that will define the quality control, this, that, all those things. And additional is design service life, 50 साल, 75 साल, 100 साल, because just wait a minute, here last slide, almost second last slide. And design durability test requirement, and all those durability test requirement, जैसे RCPT, this, that, price diffusion coefficient, उसके भी standard नहीं है. So those standard drafts has also been submitted to the BIS, and those are also being discussed. So we are taking care of in a holistic way how 456 project can be successful. Okay, so all these test requirements, and these are the concrete mix design and nominal mix and all those things has been given. क्या होना चाहिए, कैसे होना चाहिए. So summary slide, last slide. The revised IS 456 gives a more comprehensive list of cement type and clarity in the usage of different exposure classes. We have only 2 lanes to see that. Okay, and more choices, detailed assessment of water is there. One can go through it. I have not deliberated more on water. Ultra fine materials are included. Chemical admixture types are detailed. IS 9103 is under revision. Reference to maximum allowable OPC content of 450 kg per meter square is missing, जो कि existing में clause number 8.2 4.4.2 में है. those clauses should be added. Thank you very much, and thank you so much.
Thank you, sir, for giving us brief idea about various upgradations made on structural materials and background behind them. Now I request Shri D. Badra, Head Civil Engineering Department, to present bouquet and memento to P.N. Oja, sir, as a token of appreciation.
क्वेश्चन होगा तो बाद में भी कर सकते हैं, पैनल डिस्कशन के समय।
Moving forward to next technical session, I invite Shri Amandeep Garg, Managing Director, Creative Design Engineering and Consultant Private Limited, Ghaziabad. Shri Amandeep Garg is a civil engineering professional with over 29 years of experience spanning standardization, consultancy, construction, research and development. He has actively contributed to revision of National Building Code of India and many other important Indian standards, including IS 456, and is presently associated with several important BIS sectional committees as a technical member. Shri Amandeep Garg also represents BIS in ISO technical committees, ISO TC 71 and ISO TC 98 for development of international standards. He also holds professional membership in Institute of Engineers India, Association of Structural Rehabilitation India, Indian Association of Structural Engineers and Indian Concrete Institute. With this, I request Shri Amandeep Garg to kindly deliver presentation on loads, methods of analysis and structural design.
Thank you. A very good afternoon to all. After a wonderful discussion of Ojaji about the building concrete materials specifically, durability and so many other aspects have been touched, I would be touching on the types of load we are going to consider in IS 456 and the philosophy of structural design analysis that is being proposed in this revision. So as we all know that this standard is under revision and this is the wide circulation draft. Lot of thousands of comments have already been received and all these comments are being discussed. At this moment also, if you have any suggestion to make, please to make, so that all these things can be considered while we are finalizing the document. So with this, so we have to understand the scope of this document. The provision of these documents are applicable for design, construction, maintenance, and assessment of plain, reinforced, and pre-stressed concrete structures. As already discussed, it is about the structural concrete, wherein we have considered that minimum grade of concrete to PM15 even for PCC. It doesn't mean that 148, 136 type of concrete will not be used in construction. It is for the structural concrete that we are specifying the requirements in IS 456. Other lean concrete or bed concrete or other purpose concretes will continue to be used in the construction industry. So the provision of these standards are applicable only to the design of concrete structures made with normal weight aggregates and not to the structures made with lightweight or heavyweight concrete aggregates. Special requirements of structures such as shells, folded plates, arches, bridges, chimneys, blast resisting structures, hydraulic structures, liquid retaining structures, earthquake retaining resistant structures are covered in the respective standards and have not been covered in this standard. So respective standards have to be considered when we are dealing with the special type of structures or special type of loads. So as we already discussed and have been discussing since morning, that there are new approaches coming in this standard. Earlier, we were mainly concerned about the safety, like strength aspects, then serviceability aspect, and a little bit of durability aspect that is covered in this current standard of IS 456-2000. Lot more things have to be considered by the structural engineers. Now robustness, integrity, restorability, these things have come as limit state now. Till now, we are considering limit state of collapse or strength and limit state of serviceability. Durability has been covered by virtue of the defined parameters of the concrete. But in this now, we will have limit state of durability, limit state of robustness, limit state of integrity, and limit state of restorability in the, when we are going to finalize this standard. Ductility, environmental adequacy or sustainability, economy, aesthetics are also some parameters which are being touched upon in the standard, not directly used in the calculations, but it is the wisdom of the structural engineer or the consultants to use all these aspects. So this is, I've already told that these are the two limit states which is being considered in our current standard. And now durability, robustness, integrity, and restorability has been added. Now process of design is prescriptive. When the design basis report specifies that the structure shall satisfy the requirements of strength, serviceability, and durability. Closed loop process, when the design basis report specifies the structure shall satisfy the requirements of all other limit states also. So as we go on improving the systems, it will be like closed loop process. So we should understand how we are going about it. We are starting from the selection of the structural system, then examine the constructability, undertaking initial proportioning of structural elements, that how we are going to have our structural planning of any project, and then design for the strength. First point will be that we have to see the limit state of strength or limit state of collapse. Then next comes to the limit state of durability, design for durability, concrete cover, grade of concrete, type of cement, cement content, water cement ratio, and so many other things. VV Arora Sahab will also explain about the durability, and some things have been discussed already by Oja Sahab. So once we decide, because design for durability is important at this stage, because the covers and all these things are going to have your impact on your member sizes, thicknesses, and all these things. So as in step 2, we design for durability. Then we come to check for the serviceability. In serviceability, we have 3 aspects: deflection, crack width, and vibration. So all these things, if we are done, we are okay for normal structures, our design is over. It is not that all the 6 limit states we have to use for all these structures. But if this, after this, we have to understand if our structure is select structure, as already explained, which are critical or very high importance value structures. If the owner desire that I have to consider this structure as to be a kind of select structure, then we have to move forward, and then we will have to check for the robustness. Then we will go for the integrity checking. And lastly, we have to see that our structure is having limit state of restorability. With this, if we are able to meet the requirements, then we are done with the structural design. So some important terminologies of the standard I am just mentioning, though many of us already understand it, but it is how it has been covered in the standard. Now, expected service life. This term is coming from for the first time, that we want, because we have to design for the durability. For that, we should know what is the expected service life of the structure. If you are designing for a 50-year design life, then maybe your durability design will be only limited for 50 years. But if we have to design for 100 years design life, then our design requirements will be accordingly, and our selection of cover and so many other things will be based on that expected service life. Then durability criteria. Under the action of design loads specified in the standards, capacity of a structure or permanent or part thereof to sustain deterioration of materials under physical, chemical, or biological, environmental actions within the specified limits, and serve through expected service life without any avoidable disruption. So our main objective is that there should not be any avoidable disruption within the service life. So that is durability. It is not that we are thinking that we have designed it well, and after 15-20 years, we are facing a lot of issues in the structure for the retrofitting requirements or rehabilitation requirements because of the concrete deterioration or the reinforcement deterioration. So that aspects we have to see that we meet the criteria of the durability to avoid any disruption within the expected service life. Coming to the competent ground now, because this is also a term which is being used in this standard. The competent ground is the ground which is basically used for the foundation of the structure. So the ground on which the structure is to be constructed, it should be free from hazards like liquefaction, slope failure, and vertical bearing failures, and can resist safely the loads imposed by the superstructure. So this is, though we all understand that our ground should be firm when we take up the building, but many a times we do not think about that whether the structure is resting on a liquefiable soil or there may be some fissures or some other type of issues on the ground, and without knowing that we generally simply design the buildings. Strength criteria, serviceability criteria, all these things we have already discussed. I am not taking time for explaining all these things. Robustness criteria and integrity, all these things have been explained by Mr. Chaudhary. So I'm skipping these 2-3 slides because we have to meet the time schedule also. Restorability criteria, I would just like to have 1 or 2 points there. That under the action of design load specified in the standard, capacity of a structure or part thereof to sustain no damage in such structural elements which are difficult to be stiffened or strengthened after damage. Now, this is very important point. When we are talking about the restorability criteria, nowadays when we have to take up any building for retrofitting or strengthening, many of the structural elements we find that we cannot access them or we cannot strengthen them, just like your lift walls. We cannot take strengthen from inside. Outside also there may be some restrictions. So all those elements should be strong enough that there should not be any damage. And only those structural elements which can be stiffened or strengthened later on can have damage during any design load. So all these things have to be taken care. Maintenance is the important part, which was earlier not being considered very important probably. Many of the government or other private buildings, we are seeing that they do not conduct structural audits timely, or they are not taking maintenance activities from the structural safety point of view. Though routine maintenance from the painting or electrical or some other aspects are being covered in the manuals of the maintenance, but structural aspects are not properly covered in many of the projects. So maintenance is also important, and for that, process of preserving the condition of the structure such that it continues to meet the performance criteria throughout the expected service life is also defined. So coming to the basic design process. Now, the design of the concrete structure shall begin with performing the conceptual design, which involves choosing the overall form like shape and overall geometric sizes. It is the first step when we see any architectural drawing, that where should we put our columns, what should be the column sizes, beam sizes, general arrangement, all these things have to be considered first. The structural system like structural grid along the 3 Cartesian directions, the type of structural elements, and the material of the construction, etc. These have to be selected first. Then go for the detailed design basis report. Now, the code first time acknowledges that there should be a proper basis when we take up the design. So design basis report has to be prepared, and the design basis report which is prepared by the structural engineer and approved by the owner before the start of the design for all the considerations. Yeah, sir, you want to say
any format being added here? Model format for the DBR?
Sir, the points to be covered in the DBR have been mentioned. There is no as such in this standard.
Because this list seems to be quite short. There should be many more things as far as DBR is concerned.
Because when we are designing for 6 criteria, then the design for durability has no mention here. Okay, so while preparing the design basis report, there should be agreement about the exposure class, the dominant deterioration mechanism, and the service life. So all these 3 conditions to deal with the design for durability is missing here. Okay, so a structural engineer should needs to take care of it, to take care of the help of the material scientist here also while preparing the design basis report, because here the design basis report is not for a structural design only. Design basis report is for all the 6 criteria, in which criteria on the structure, which criteria is applicable, in which respects, that should be mentioned. So the 3 statements, exposure class, the design, the dominant deterioration mechanism, and the service life. These 3.
We agree.
I suggest to add a model format as an annexure maybe.
Sir, it can be covered in the commentary or the detailed handbook.
पता नहीं कब आएगी, जब तक तो बहुत सारी बिल्डिंग हो चुकी होंगी. I suggest to.
कमेंट्री में वो 3 चीजें डील नहीं हो पाएंगी. जब यहाँ 3 चीजें
आप कह रहे हैं वो ठीक है. Sir is asking about the detailed format. So format can be covered in the annexure. I think let us see if we can add in the annexure. But in the main text, we have given the basic requirements of the DB.
One question. You're talking in the last slide. You're talking about maintenance of the structure. So is it related? We have related it to the important structures, the importance of the structure, that or all the buildings have been given the same kind of criteria. Maintenance has to be done at this frequency.
No, maintenance has been defined here that maintenance is required, but it has to be wisdom of the owner that how they are going to have. It is not about any specific type that only the special structures requirement in it. All buildings or all structures requirement. Yeah, please.
Yeah, on the previous slide where we talk about that if there can be the situation that because of the access issue or feasibility issue for the execution, strengthening is not possible for some concrete members. So is there any examples also provided in the IS 456 for the practicing engineers, that as you mentioned some example also as a ritual like that?
At this moment, no example has been specified. We have specified the limit states that we have to deal with. It is going to be basically required for the high importance buildings only. All the last 3 limit states, these are for very special buildings, and for that it will be the detailed assessment has to be there. There is no general guidance at this moment. Of course, your suggestion can be taken care, and we can try to provide some examples also.
Yeah, and the second point where the strengthening is possible for the members. So maintenance, this one. So any period is also referred in IS 456 for the maintenance?
No. Okay. No, there is no asset maintenance requirement given in the IS 456, but it is from the regulatory point of view, National Building Construction Standards or Model Building Bylaws, all these documents specify, because it is a matter of the land, and land is covered by the government, that they specify it, and 3 to 5 years general period has been specified in the documents of BIS, but it is ultimately the government who has to decide that after how much time the audits or all these things have to be taken.
Thank you, sir.
Excuse me. Yeah. On the same slide, can you go back? So this is regarding restorability criteria for elements on which cannot sustain damage. So my question is with regard to seismic condition, where anyway we assume damage is happening because we use R in the design. So whether there can be any example where we don't allow structural element damage?
Well, as we all have a concept of strong column, weak beam system. So generally we do not allow damage in the columns, or we all want that yielding should be in the beams or the other structural elements. So this is the one aspect, but still at some locations, if the beams are also not accessible, or if there are certain elements which cannot be later on stiffened, all those areas have to be provided with higher strength so that yielding do not take place at those locations.
But then for seismic analysis, then R has to be one for those elements. So, but that is not covered in 1893.
So it is a part of IS 456 design requirement. 1893 is basically giving the criteria to deal with the earthquakes. So,
but both are linked, I suppose, because finally forces will come from there.
That is right, but for certain elements, you can always provide higher strength. IS 1893 do not restrict you to provide strength in certain elements. It is giving you the guidelines for the calculations of the earthquake forces and the system to design to meet the earthquake forces. R5 you are allowing means you are allowing the yielding of the stream.
Yes.
But if you are going for R1.5 or 1 or
ऊपर वाला
2,
तीन all structure.
at that level probably there will be
ऊपर
no
वाला
yield.
तीन all structure.
So coming to the methods of analysis, the static analysis will be deemed to be sufficient. Now here there is no significant change. Though the document is going to be very, very thick, a lot of new requirements are coming and a lot of things are here. Many people will fear that now we may be moving towards non-linear analysis. No, at this moment for normal buildings, we still have normal analysis, static analysis and dynamic analysis, linear analysis. Only 3-dimensional non-linear analysis in select structures. Now coming again, only for the select structures. The non-linear analysis has been recommended and for estimating the effects of examining additional robustness integrity criteria. Both material and geometric non-linearities shall be considered. The characteristics of non-linear member models assumed therein, such as initial and degrading stiffness, cracking yield, ultimate strength, and cyclic hysteresis rules, shall be consistent with those of the material used. These may be estimated analytically based on the properties of the constrained materials or ascertained experimentally. So, non-linear analysis has been introduced in this standard, not required to be taken for all the structures, but only for the important or critical structures.
Again, for dynamic, you mean seismic condition?
Yeah,
or
for seismic conditions, just like ICT 93, the requirement have to be met. It is again, when we do dynamic analysis, it is again a linear analysis. It is not a non-linear analysis.
And do you also think to introduce crack section stiffness, which is there in the American standards?
The stiffness modifiers have been specified in IS 456 now.
Okay.
So coming to the structural analysis, linear and non-linear methods are admissible. Structures shall be analyzed by linear methods considering set 1 load combination. I have not taken load combinations in my presentation. There are 3 sets of load combination. Set 1 load combination is for normal structures, and set 2 and set 3 are for the select structures with the different type of special requirements. So non-linear analysis shall be carried out when set 2 and set 3 combinations are considered. Construction stage perform linear or non-linear analysis as required. So all these things are general linear analysis. We all, as per the current Indian standards, as we do, we continue to do same. Yes, sir.
So just one clarification. What do you mean by select structures? Is it a category? We've got many categories.
Yes.
4 categories.
So first 2 categories, critical and what we call as more than critical and special.
थोड़ा एग्जांपल लिख दीजिए कौन से क्रिटिकल मतलब ये
Yeah.
Actually, this classification has come from the 1893 Part 1, which has been withdrawn. Okay, so if you will see that, the withdrawn standard, that is based on the recurrence interval. And that concept has been brought here.
Yeah, here basically the earthquake safety and the design life.
So earthquake safety, recurrence interval, and the amount of risk associated. So all those criteria has been the background behind the categorization of this structure. And if you will see the withdrawn standard, 1893 2025 Part 1, then the philosophy is there. So from there it has come.
So design life.
I am not discussing
So
whether it is right or wrong.
From there we bring those criteria here also, no?
Yeah.
Sir, again, one more question. Non-linear dynamic analysis you mentioned. So that means non-linear time history analysis you're talking about? By non-linear dynamic analysis, you mean non-linear time history analysis?
Yes, you can do non-linear time history
But
analysis.
then it requires a lot of input
Yeah,
parameters.
response spectrum also you can do.
No, response spectrum is
Non-linear response spectrum as well as non-linear time history. Both you can.
non-linear response spectrum. You mean non-linear static pushover analysis?
Yes, that is
Sir,
the
static
calculation.
pushover analysis is one thing. When you say non-linear time history analysis, detailed material inputs are required, whether that are given in the code.
That is That is
because you then need hysteresis behavior of the concrete, which is very complicated to model internationally also. A lot of people, like, it can be misused like anything, because hysteretic damping is a big thing which reduces the nonlinear demand. So it can be misused like anything if you give like that.
No, one more point, sir. Actually, in nonlinear. One more point, sir. In nonlinear, I also commented on that. You have a concrete compression nonlinear for like robustness and in other cases, but you don't have in tension, because if you have a lot of numerical model need at least in tension, you have given fiber reinforced concrete, you have that in tension curve like fracture toughness based. You need that kind of properties, otherwise you cannot do nonlinear material.
Yeah, I understand. Actually, this time,
And, then, and that too also in cyclic.
Yeah,
so that's why I commented, if you are resting to nonlinear pushover is 1 point, nonlinear time history is 1 grade higher to that.
That is the concept has been introduced this time only for the select structures. Specialist literature would have to be referred to, and material properties have not been specified in the standard, but as it has been specified, the acceptable material properties based on your experimental assertion or properties which are well determined or well established, that can be used.
I think, Mr. Garg, this may we may simply write for dynamic analysis, refer the earthquake codes. We should not talk about this here.
That I think that is acceptable, and we can simply refer to IS 1893, and we can have detailed guidelines in IS 1893 for that. So mainly we can consider, yeah, but if some other aspects are there, yes. Yeah, primarily for earthquake safety only.
No, actually, he said for other nonlinear, for impact and blast, you have already referred to the other codes.
Yeah. So the different concern standards would have to be referred.
Sir, if this goes in the same language, that for a select structure, we have to do this. Okay, then select structure defining, as Tandon sir said, that if you are, the select structure is quite general. Every structure needs to be designed for earthquake these days.
No, it has been defined properly. Which are the select structures? These are the select structures which are iconic and very high importance values if they carry. For normal building structures, it is not a select structure. It is only like very special hospitals or disaster management related structures, or some airport type of structures which are having international impact. All these type of structures will only come into the select structure. So airport will have international impact because it will have international connectivity issues if the airport goes down.
If you are building which collapses on collapses at the borderline of India and Pakistan, and part of it remains in India, and Pakistan remaining goes to Pakistan. That is what is. So I think that these words should not be used loosely.
So international impact has meaning like that only, which can impact international commuting or international some kind of business or something like that.
But I think better to write that, no? Either write it or remove it.
In the standard, we can avoid it rather.
I think that the international impact.
Okay, right, sir. So we can. It can go to the commentary or somewhere you may write. So member secretary has already noted it. So linear analysis may be carried out by any of the following conventional method as detailed in clause 8.2 of the draft standard. Then straight time method is also now allowed, and simplified methods as outlined in 8.4 clause. So these are the 3 simplified methods. 3 methods have been defined. This time we have allowed straight time system also. So nonlinear analysis, again, it's a matter of point that it has to be referred to IS 1893 for the detailed requirements. So here it is just being touched upon.
Maybe relevant for in case of wind.
Yeah, for any cyclic load type of system, blast is there, then maybe earthquake and maybe storms, cyclones.
I think that wind and earthquake particularly, it should be defined there. I mean, it should be mentioned there so that people don't go around designing every structure for all this.
I think, sir, for earthquake, for normal cases, you can go for linear analysis. When there is an option for the third, extreme severe, and there is a overstrain omega is there you can go for nonlinear. If you go for nonlinear, you get the advantages of that because of the large deformations.
Right. So these are the modifications, cross-sectional modification suggested. You can have a glance. Section properties modification, stiffness modifications.
The same as IS 1893 gives?
Yes, sir. Yes, ma'am. So boundary conditions when modeling the connection between members shall be considered to be rigid, while those between column and column basis shall be considered to be flexible. Now here some better guidelines have come. Earlier there was no proper guidelines probably for the consideration for the foundation, whether we have to consider base as fixed or flexible. So here guidelines have been given where we have to consider the base as rigid and where we can have flexibility. Limit state of robustness is for blast, impact, and fire. So all these details you can refer from the standard. Here probably time is less to be discussed. And similarly for integrity, restorability. Now coming to the design process.
So just one point, one very high demand was there in fire. There is for extreme fire, there is a requirement of doing progressive collapse analysis. So this also keep in mind, it's very highly demanding. It's not very easy to do.
We'll take care. So process of design, one is prescriptive and one other is the closed loop system. So closed loop process, as I already discussed, for the special structures, the select structures, where we are doing all the 6 limit states design, we will have closed loop process. Otherwise, for simple buildings, for normal buildings, we will have simple prescriptive process as we are doing today. So coming to the near to the conclusion. So we have 2 sets of design loads, force load and displacement load. We have 6 limit states now, 3 mandatory and 3 optional as per the requirement of the project criticality, and 2 approaches for limit state safety. One is strain limit state, axial force, bending moment, and the strength limit state, which is shear force and torsional moment. So force loads already discussed in the morning. These are the displacement loads. Structural analysis, as I discussed, linear elastic displacement method is generally being used for normal buildings. So therefore, the strategy is still to do linear analysis. So with this, I close my discussion. Yes, please.
I have a query in mind, maybe just a silly thing. Why do we need stiffness modifiers for elastic loads like gravity and wind? There is a crack width which is allowed 0.1 mm in that. So for long it was not there. For years, we had no stiffness modifiers for the gravity, the elastic load basically. Only with the seismic it was there because it was going into the non-linear zone.
So generally nowadays we are not designing with the working stress method or the elastic method of design. At this moment we are designing for the limit.
But even then we are allowing only 0.1 millimeter.
Where we are going slightly beyond the elastic areas.
Correct.
So for
now
that,
when the structure is started to be used in the first loading cycle, the structure deflects, deforms, comes back to the original. It goes on for long, for say 1 lakh cycles, 10 lakh cycles of the loading, repetitive. That is what is the your elastic stress strain curve for the gravity
Right, sir.
and wind. So where the stiffness modification comes into picture?
So for the complete design life of the structure, say suppose the life of the structure is 50 years and after 20-25 years, there's small cracking which is increasing and there is a stress distribution and there is a cracking. For that,
Is there a data that after 25 years this much will be the crack width? Because, or if not, then for first 25 years, why am I stressing the structure for that modifier?
we are not stressing this.
We are
designing
making 0.35 for the gravity also. See here.
Sir,
we are going to as low in the beams as 0.35. It's right from day one. When my loading cycle doesn't affect at all, there is no crack in this structure. Why I need stiffness modifier for the elastic loads?
So for slab you are saying?
For anything, I'm saying for any member.
Sir, for generally if you see for the beams and columns, there is hardly any impact on the structure because we are taking 0.7 around value.
It has an impact, sir.
So it will
particularly in the lateral force, particularly in the earthquake analysis, it affects much. But I'm saying that in the gravity analysis, when the load is elastic for 10 lakh cycles of the repetition of loading, my stress strain curve is still the linear.
Yeah, that is fine, but here it is writing that it has to be only for the gravity load condition also. We are not only designing for the gravity loads. Now, everywhere we have to have a design.
I'm saying if suppose there is a location, there is a place, there is an element which is not designed for earthquake, only designed for wind, gravity and wind, can I avoid this table?
I'm not sure because in India we do not have zone 1 or zone 0.
We were not having this table so far in 456. And if a structure is not being designed for 1893, I was not using those stiffness modifier.
That is fine. I think we can discuss in the committee.
So why do I need that now? It's in earthquake, my stress strain curve is different. I'm going to the non-linear zone. But in wind also, I am in the elastic range only.
Yeah, if it is.
So why do I need stiffness modifier?
I think we can discuss in the committee. Thank you. Thank you, everybody. If there is no any question.
Thank you, sir, for your discussions on basic design procedures, terminologies, and methods of analysis and loads. And I also thank participants for their key inputs and feedback. I hope it will be taken care by CD2. And I request the D. Badra, Head Civil Engineering Department, to present bouquet and memento to Shri Amandeep Garg as a token of appreciation. We shall now break for lunch, and remaining 3 technical sessions will be after lunch. And lunch is arranged at cafeteria. Please assemble back by 2:30. Please assemble back by 2:15. Okay, fine. Please assemble back by 2 p.m. Fine.
The amount of fire safety protocol has to.
Namaskar. Today we are joined by Shri Sanjay Pant, who is Deputy Director General at Bureau of Indian Standards. Mr. Pant, thank you for speaking to us. It's a pleasure having you here.
Thank you, Jai Sahab.
BIS has always been known for setting standards for products and services. How did this building construction standard come about? Tell us about the standards that you're setting for building constructions.
Building construction is an important area. India is poised to become a developed nation by 2047. It's not possible that our industrial activities, economic activities, educational activities, healthcare activities can be done properly without proper infrastructure. Buildings are one of the important components of infrastructure, and therefore it is important that we have the right quality of buildings. And therefore, Bureau of Indian Standards since 1970 thought it appropriate that we bring out a comprehensive National Building Code of India. And it was NBC 1970, as I said. There are large number of Indian standards for building planning, design, construction, more than 1,000 building materials. But it's very difficult to understand them, a large of them. Therefore, the building code interweaves all this information, makes it a cogent reading, and therefore the building code has come about.
And what are the main components of this building code? Does it deal with the standards of construction alone, or does it also deal with safety, like fire safety, sustainability, and other stuff as well?
Yes, very rightly. The building code deals with building materials, building design, construction, operation, maintenance, repairs, retrofitting, the comprehensive aspects of the entire chain of the building aspects. Yeah.
We are just meeting a couple of days after an unfortunate incident in Saket. The building collapsed, killing 6 people. Do you think these building standards, if they would have followed, could these kind of incidents be avoided if the BIS standards are applied in total in the construction of these buildings?
Yeah, collapse of building, in fact, it's a complex phenomena. Maybe it could be of various reasons. First thing is the building materials were of not the right quality. Secondly, the structural design was not appropriate. Thirdly, maybe all right materials as well as structural design, but the execution was not right. The collapse of building was not maintained by the owners. So therefore, it is very important that we comply with the standards of building materials and components, the structural design codes that BIS has formulated, the execution codes, the construction codes, as well as the upkeep and maintenance of the buildings. And therefore, you are very right that if the National Building Code or building standards were followed, such an incident would not have happened.
So how do you enforce these codes? These are just voluntary at the moment, right?
Yeah, a very good question. Building construction is a state subject. And under entry number 35 of Schedule 7 of the Constitution of India. Then further, there is an Article 243W, under which a new amendment on municipality was brought out as 74th Constitutional Amendment, under which the regulation of building is vested with the urban local bodies. And therefore, the documents like National Building Construction Standards or Indian Standards on Building Construction, these are voluntary in nature. But then largely the entire gamut of building construction is dependent on these construction. These national building construction standards that BIS has formulated, in fact, it is used in a multi-pronged strategy by the entire country. First, it is used to prepare the building regulations of the country. Secondly, it is used as a construction manual by the government construction agencies as well as private construction agencies, the builders, the developers. Thirdly, the code is used by the building professionals like architects, civil engineers, structural engineers, town planners, urban designers, building services engineers, and contractors. And finally, this is also a very good educational material. The civil engineering and architecture is taught substantially based on the Indian standards on construction.
So if an audit has to happen for the building that unfortunately collapsed, BIS standards would be something that the authorities would be looking at, isn't it?
Perfectly right.
Related to that, in April, end of April, if I remember correctly, NCR, there was a big fire at a multi-storied housing complex in NCR region. 8 flats were gutted because of supposedly not following the safety norm. Do BIS standards also bring in the safety as regards as fire and other such hazards?
Let me tell you, the current document is called National Building Construction Standards 2026. This document is entirely evolved around 4 pillars of safety. That is structural safety, fire safety, and public safety and safety in construction. Fire safety, as you have mentioned very rightly, is an integral part of the document. Fire safety has been dealt in the document from the point of view of fire prevention, life safety, and fire protection. That is, first of all, there should not be any fire. So the building construction itself should be done using such material which are fire resistant rated material. In fact, we have to understand the nature of the building from fire vulnerability point of view. So the document divides the kind of building into 9 typology. Group A, residential; B, educational; C, institutional; D, assembly; E, business; F, mercantile; G, industrial; H, hazardous; and J, storage. So these, for example, residential building, the vulnerability is different compared to educational building and healthcare or hospital building, where people are not capable of their self-preservation. And therefore, the amount of fire safety protocol has to be commensurate with that. And therefore, the code provides that first, as I mentioned, fire prevention by understanding the nature of the building, using appropriately fire-resistant rated materials, and then life safety. Even if there is a fire and propagation is delayed, the people need to evacuate. So there is a component, egress components.
So as in the evacuation of
evacuation.
Like you said, these building codes are all voluntary, and it's a state subject. So is BIS in dialogue with states to ensure that the codes are implemented in the urban bodies that are being constructed? Because we are seeing a massive urbanization that is happening, and like you rightly said, if we have to become a developed nation by 2047, urbanization, it will be the theme. Are you in dialogue with the state governments to implement these?
Yes, very rightly you said. Maybe by 2047, 50% of India would have been urbanized, and you need a large stock of buildings, including residential buildings. And therefore, BIS is working in collaboration with all the states and union territories. In fact, the building standards are used in framing the local building bylaws and building regulations. That's number one. And we organize a lot of seminars, conferences, training programs. We have a National Institute of Training in Standardization at Noida, and which is charged with the responsibility of training the state government officials also. So we are regularly in touch with them, training them, communicating with them, organizing seminars, workshops for them. And therefore, we are trying to do as much as possible to educate them and bring them to the level of understanding that has been given in the building standards.
The standards, if I understand correctly, has allowed hospitals to go vertically higher than what was prescribed earlier. Explain to us what these new norms mean for a healthcare facility, public hospitals, and likewise infrastructure?
As you know, land is a very scarce resource, and there is no other way but to go vertical. And therefore, like other buildings which are residential and commercial building, we have decided that we can go vertically in case of hospital also, while maintaining safety. And because the vulnerability is altogether different in case of hospital. So the building standards provide that that the safety should remain intact even if we go vertical, because healthcare facilities at a substantial height pose a substantial challenge for mitigating, and therefore it has introduced a concept of progressive horizontal evacuation. And in a hospital building, in the same floor, we will have compartments. If there is a fire in a particular compartment, it cannot propagate or go into the another compartment. So another place of safety is available with operation theater, all the medical healthcare facilities. So progressively evacuation will happen from the seat of fire, from the area where there is a seat of fire to the area with the compartment on the same floor. So the complete evacuation out of the building may not be necessary. So this is how we have tried to deal with this subject.
Yeah. One of the other thing that is pressing is the India falling. There's several parts of the country falling in the seismic zones. How do you ensure that our buildings, our construction there are no seismic threats to the buildings?
Very pertinent question, because India is a disaster-prone country, and we are visited regularly by cyclones, earthquakes. Apart from the safety of the building itself in its design and construction. So building is to be designed, as the codes provide that the building is to be designed to deal with dead load, imposed load, wind load, snow load, and earthquake forces. Building construction standards have incorporated the basic wind speed map of India and similarly seismic zoning map of India. The entire country is divided into 4 zones from seismically. Zone 2, 3, 4, and 5. The 5 being the most severe. For example, the area in the Himalayan region and some of the parts of the Gujarat, they are most vulnerable. So buildings have to be designed considering the possible earthquake forces that may frequent in such areas. So the building code gives a comprehensive feature as to how to plan and design these buildings to withstand the possible earthquakes in those particular zones, and also erect. In construction methodology also, there are features available where the building in the event of an earthquake will shake and finally vibrate and come to its own original position without any severe damage.
If that is possible, then possibly we'll save a lot of lives. And
yes, because we cannot prevent earthquakes, but we can have our buildings which can withstand the shocks that may come with such earthquakes.
What about the buildings that were built before the code came in? Because your code can be applied for future projects.
Yeah.
There are a number of buildings in this country which are old enough, which may not follow your codes, construction codes, or for that matter, the seismic guidelines that you have. How do we ensure that?
Our first, I remember the first seismic zones that we have formulated was in 1962. And since then, attempts are made to disseminate it, and based on earthquake codes, the building should come up. But you are quite right that there may be a large stock of buildings which may not be complying with the earthquake code, and therefore we have developed the codes for retrofitting, repair, and retrofitting and rehabilitation of buildings itself. So the entire process is in place, where you have to do rapid visual screening, understanding the weaknesses, do non-destructive testing, understanding the weaknesses of the structure from earthquake point of view, and retrofit it. So buildings today are being retrofitted, particularly the important buildings, which are lifeline buildings like educational institutions, hospitals, or the buildings which are seat of power from where the entire disaster management has to be managed. So these buildings are progressively being retrofitted as per the Indian standards.
But to retrofit, there has to be an audit. Who does that audit to find out what old building is right and what is not right?
I think very good question. Buildings we have provided for regular periodic audit of buildings, whether it is from fire safety point of view or structural safety point of view, as you said, earthquake safety point of view. And periodically, after every 3 to 5 years, the buildings need to be revisited by a team of experts. And this protocol has also been included in the Indian standards.
These days, the commercial complexes that come up, they are a combination of food courts, entertainment zones, and likewise too many other things. How do you ensure that there is safety for all of them? Because at some point of time, few things take priority and few things don't take a priority over each other.
As I mentioned, there are 9 groups of buildings, and this is another 10th group of building, you can say, which is a mixed occupancy. So different types of occupancy, food court, as you mentioned, has a source of fire also. So it has got a different vulnerability, and therefore the code provides that in such cases of mixed occupancy, the most severe provisions will apply.
Okay.
So accordingly, the buildings have to be planned, designed, and executed to take care of the most severe provisions.
As we progress, I think the buildings are also becoming more modern and more clitty. There are glass buildings that are coming up, particularly the commercial office complexes. How do you ensure that those glass buildings, with all those glitter and lighting and everything, they are also safe and not prone to fire and other safety hazards?
Yes. Quite right. The glass buildings are not like ordinary windows. They are structural glazing, and they have to withstand, as I mentioned, there are various loads. So dead load, imposed load, wind load, they have to evolve to withstand all these vagaries of nature. And therefore, these have to be designed as curtain walls with spider fittings in place. And they need to withstand the wind forces and seismic forces, and therefore, and including fire safety in the event of fire safety. So the code provides how to design such curtain walls using glazing, and also ensure their fire safety using appropriate sprinkler system at a particular location within the built environment.
But after a particular interval, there has to be these kind of safety features.
Yes.
So, together with this modern building infrastructure, there are new things that are coming up, which are evolving. We still are evolving. EV charging stations, for that matter. Every complex, we're moving away from fossil fuels to electric battery operated vehicles, and EV charging infrastructure is now not just common in residential, but also in commercial complexes and office complexes. What special features or safety features need to be incorporated to help secure those premises as well?
I think as a modern document, the National Building Construction Standards and NBCS 2026 now gives an ample provisions for EV charging infrastructure. For it gives guidelines for parking of electric vehicles in a separate buildings, or in the building where we reside or work, including in basements. Only thing it prevents that these should not be parked in the last basement, because of the possibility of flooding of in an eventuality the last basement, causing the damage or a fire incidents.
So ideally, they should be situated either on the ground floor or in the first basement.
Yes,
that is what you.
Yeah.
So the building code, you've already come out with 2 volumes of very elaborate and very comprehensive guidelines. Is there likelihood that you might update it with more modern information, more norms, more volumes to be expected soon?
Yeah, the basic code is already out, as you mentioned, and it has already become very popular, and a lot of downloads from our website are there. It is available for free download from BIS website. It is a 3,000 page document. But as you rightly said, there are other issues. Actual execution or construction is also there. And therefore, we are also coming out with associated handbooks. One is on construction practices, management and safety. The other one is on landscaping and outdoor display structures, because not only indoor environment, outdoor environment should also be good. And the third one is on approach to sustainability, because whatever we do, whether it is selection of building material, construction activity, execution or maintenance, it has to be done sustainably. And the last is the existing built environment has to be protected. Therefore, the fourth handbook, which will come very shortly, is asset and facility management.
So in order 4 more handbooks, and
Yes.
possibly you might then update everything into one comprehensive volume as well in future. Like other technology and other areas, construction is also an evolving technology with lots of developments that happen around the globe. Is BIS also collaborating with international bodies to evolve, to keep pace with the changing times and changing technology that are coming in construction and other areas as well?
I think this reminds me to just also share that in this revision of the code, we have brought out some of the new developments, which are the first worldwide. One is introduction of 3D printed concrete constructions, and you can just print your house. There are already incidences in the country where the printed buildings have come up, and also a fast construction activity. Through a prefabricated, pre-finished volumetry construction, the entire room is cast in the factory and is transported, and it is then placed in place, and jointing is to be done. And so these are some of the developments. Rightly, as you mentioned, we are in touch with the best practices globally. We have access to the developments which is happening globally, and we are in touch with them so that our code remains one of the finest building standards in the world.
Lastly, your code is very popular in our country. A lot of people follow it. A lot of builders and construction follow this code. Are there any countries abroad which have actually reached out to BIS for adoption of this code, or in some form or the other, as well as to train their own standard setting experts in?
Yes, I think it's a very, very important question you have asked. The National Building Construction Standards, or NBCS, that we have formulated is very well sought after document worldwide. In fact, some of the African and Latin American countries have asked BIS to help them frame their building code, and we have communications from them. In fact, BIS organized a conference of the ambassadors of some of these countries in Bharat Mandapam in New Delhi very recently, and they all participated. And we resolved their queries and how BIS or India can help them in developing their building code of the stature that we have in our country.
So possibly also help them train as well. You might hold training workshops for these countries.
We have been holding regular training programs, and in our training institute at Noida for developing countries. And this building standards are one of the important subject areas where we teach them.
Sumant, it was a pleasure speaking to you, and hope your standards are implemented in full toto.
Thank you, Jaydeep Saab. Thank you so much.
Thank you so much for speaking to us.
Thank you
so much.
मैंने सुबह बोला उसको, सर मैंने he's the overall in charge. I told him that, this is very as it is. One is afraid that if it is going to be, pushed back, if you try to push it like this, it may have the same sort of a fate as 1893. And he says, why you are in charge of you, your responsibility. We took 3 years. We took 3 years to give our draft. And when we finally see this draft, it has got nothing to do with whatever we have been sending for 3 years. I don't know. He asked me who is making the changes from whatever. I said that I can't even recognize any part of it. As far as researching is concerned, in the whole code, whatever has been put, I can't recognize any of it as if it is written by me or our group rather. He said that then you should have mentioned it before. There are three meetings, this meeting, that meeting. I don't know, anyone could have. And today also they were discussing, one of the two things in your building code is something about the foundation and how important it is to keep the early thermal effect. That is inside that code. It has got nothing to do with concrete. It has got nothing to do with anything else. But it is so good that you put it there. And now they were discussing, because I told them that, whatever you are discussing, thermal effect, they are even in the tall building code. And this guy, he says, no, that is because they have crossed their line of application. I mean, stay within their lane kind of thing. Why they are all no. Yes, not that categories of structures. If you see, there are 4 categories of structures. I said the first place, you should never have 4 categories. What you put as the special structure, you got, I mean, they have run out of adjectives. They are not critical, important, very important, and then finally, yeah, special. Yeah, okay. Oh, ऑनलाइन मीटिंग है तो हमने फिक्स किया
साढ़े 4 बज जाएगा अगर सर आपका कोई पीपीटी है? हमारा पीपीटी है यार, उसके वैसे लेक्चर नहीं देते। और तो हमारे प्राइम मिनिस्टर क्या होता है ये भी क्या होता है इसमें टेलीप्रॉम्प्टर लगाते हो वो टेलीप्रॉम्प्टर भी आजकल कोऑर्डिनेटेड सिंक्रोनाइज मल्टीपल होते हैं वो आपके सिस्टम पर डेली वर्क में I was working as a contractor for Response, the road bridge design. And I was doing it on the details. अभी तो आप करो एक बार कैप्टन से करो मैंने बोल दिया सर आगे मतलब कम से कम 4000 लोग यूट्यूब पे देख रहे हैं ये आ गया ये आगे उसमें जो यूट्यूब पर बात कर रहा है वो समझ नहीं आया सीमेंट का इक्वेशन समझ नहीं आया
पीपीटी लगा ना
एक्चुअली क्या है कई जगह पे ऐसा होगा कि एक सिस्टम प्रॉब्लम है एक फेल हो रहा है नहीं वो टोटल आ जाता है कितना बिल जो आएगा डिफरेंस आ जाएगा बाद में आ जाएगा हाँ लाइक 40 लाइक 25 है YouTube पे अरे सर ये टेक्निकल लोगों से ये क्या है चलता रहेगा ये बाद में बोल कल ये लोग अभी बहुत दिनों से ऐसा बैठे हैं अरे हमारी कमेंट कभी
We will now proceed for technical session 4. I invite Shri V.V. Arora, Co-Chairperson, Cement and Concrete Sectional Committee CD2, Ex-Joint Director, National Council of Cement and Building Materials, Balabghar. Shri V.V. Arora has more than 40 years of experience in construction, design, research and development, quality assurance and training. His area of work include concrete technology, durability, service life, design of concrete structures, and use of waste materials in construction. He is also convener of working group under CED2, which is responsible for revision of IS 456. He is also associated with several BIS and IRC committees related to design and construction. He has also contributed to international standardization work through working groups under ISO Technical Committee TC 71 on reinforced and pre-stressed concrete. He has published and presented more than 50 research papers in national and international journals and seminars. I request Shri V.V. Arora sir to deliver presentation on durability and service life design of structures in IS 456.
Thank you. Good afternoon to all of you. Maybe feeling a little sleepy after having good food. So I'll be speaking on the durability service life design. Durability word has been discussed for so many times since morning. And this is a service life design is a new introduction to the 456. Earlier it was not there. Proposed revisions in IS 456. Now, I will not give much of introduction to this. Now, the durability, what we really intend to say by durability, durability is basically what many definitions are there. It is basically the level of duration over its design service life. You know, it is linked to service life. During the service life, it should not impair the performance of the structure in terms of strength, serviceability, and utility. So strength should also not be impaired, serviceability should not be impaired, and the utility, actual function of the structure should also not be impaired. And then during the intended service life, and without special maintenance, with anticipated maintenance, normal maintenance should be there. But if it requires extraordinary maintenance, that means that is you are losing the utility. Now, what are the major changes we are making in this is concept of performance-based design we are bringing to durability is being introduced, where the performance-based means we measure the performance by calculations and by testing also. Concept of service life is being introduced, and we will define how what is meant by service life. That also we will define. Provision for durability design for 50 to 100 years have been given in this document. Exposure classes are different for different duration mechanism. This is also a revision in the document. Earlier we had only mild, moderate, severe, and extreme, and that was not related to what kind of deterioration mechanism is there, what kind of exposure is there. Now for different exposure, we have got different exposure classes. And map of India has been included, showing the climatic zones. So it is easy to find where you are located, to which exposure class you will be applicable to that structure. Effect of quality control levels to be considered while designing, because that durability also depends upon the quality achieved. So, and as in this code, we have introduced different quality levels. So they are also being linked to the durability design to some extent, not too much, but some effect will be there. Detailed service life design procedure has been given, and we have given for normal structures, we have given simplified tables also, and then for important structures and for longer service lives, detailed service life procedures have been included. Sorry. Requirements of protection against sulfate attack and alkali silica reactive, they have been modified, and that have been discussed already by Mr. Oja. So, and when we are doing a service life design durability, we are following a concept of limit state design. As is being done in our structural design, we are using limit state. And as in the morning, Mr. Kurian had mentioned that our code is being aligned to ISO 19338. And ISO 19338 says that the codes which are complying to ISO model code, they should be using the limit state design method. So to comply with that, now we have brought in the limit state approach here also. So some factor of safeties will be there, partial factor of safeties will be there in durability design also. But that will not make it much complicated, only factor of safety to be added. Procedure for using durability test mixed design stage and for quality control being added. What are the ways to do quality control and mixed design that has been added, that we will discuss. See, deterioration mechanisms. First, we have to understand there are many deterioration mechanisms which affect the concrete. There are certain mechanisms which affect the concrete basically, like sulfate attack and alkali aggregate activity, which cause cracking in concrete irrespective of the reinforcement. And other common thing is, which is for RCC structures, that is corrosion of reinforcement. By and large, all our structures deteriorate because of the corrosion of reinforcement, which leads to cracking and degradation of concrete ultimately. So that is why the corrosion and corrosion is being mentioned, linked to both concrete as well as the. So we will be confining my presentation to this corrosion of reinforcement, which is due to carbonation and chloride. So we will be discussing only on this part. Sulfate already covered in the morning. Sorry. Now this is the common scene when we see it. So where even if the structure is standing, you lose the utility point of the. So these things should not happen. So we have to avoid this, and that our design has to be accordingly. So potential, as I said, we are covering these two mechanisms in our basic corrosion of reinforcement avoidance. First is the permeation of the atmospheric carbon dioxide in the concrete. That is called carbonation-induced corrosion. When the carbon dioxide enters, so it causes the depassivation, and depassivation leads to the corrosion. And second is where the chlorides are present, or the offshore structures and all that are in swimming pools or some industrial buildings. Presence of significant levels of chlorides, chloride ions in the concrete. When the chloride enters and reaches a threshold level near the reinforcement, that also causes depassivation and breakage of the passive layer, which leads again to the corrosion. This is the same thing diagrammatically mentioned, that whenever the depassivation occurs in the presence of moisture and the oxygen, then only the corrosion will occur when all three are present. Depassivation should be there, moisture should be there, and oxygen should be there. So then depassivation can be because of carbonation or because of the chloride ion induction. Now we are having a durability design which we are introducing is a performance based, as I said earlier, which in serial 1 we see the performance requirement involves the performance requirement we have to define. So first we define the performance requirements, then we do the when we give procedures for achieving the durability to meet those requirements, and then we verify and measure. So that is the basic procedure. So our performance requirements are design service life, we have to fix it. What is the design service life? And the exposure conditions. So they are our things which will be affecting the structural durability to meet these requirements, so that the structure performs for the given service life under the given exposure conditions. We have to achieve the durability. So how we achieve the durability? We achieve the durability by designing a suitable cover, providing a suitable cover, and the concrete quality should be such, type and quality of constituent materials, including admixture, should be such that it can resist that environment. And cement content and water cement ratio of the concrete matters. Cement type also matters here, but type of cements we are using. And once we select the appropriate concrete and cover, then we do a final testing also of the durability, that is to measure the performance. Other factors involved are the workmanship and shape and size of members and maintenance. This maintenance we are not covering much in detail, but in general we are saying that regular maintenance should be there. But for workmanship quality, some factor of safety we are putting for the level of quality construction. So to some extent that covers the workmanship issue. So what should be the service life? For that also some guidance has been given in the code. For low-rise structures, the 50-year service life is recommended. For mid-rise structures having height between 15 to 50 meters, the code recommends service life of 50 to 75 years. And for structures with more than 50 meter height, critical and important buildings such as hospitals, healthcare, etc., 75 to 100 years is recommended. Monumental buildings, bridges, more than 100 years can be there, but our design procedures are up to 100 years. Beyond that, again, you can refer specialist literature. Now, coming to the exposure conditions, these are more detailed than the existing table, and they are, as I already said, they are different for different mechanisms and environment conditions. So this is a map given in the document, which has got 4 different zones: hot and dry, wet and climate, and which we are referring in exposure classes, those same zones mentioned in the map. So these are, for example, is hot and dry, warm, humid and temperature, composite, and cold. Now these areas are demarcated on the map, and that map is included in the document. So first is the corrosion induced by carbonation. So for carbonation mechanisms, these are the 4 exposure classes we have mentioned in the code. And for corrosion induced by chlorides, we have got a separate exposure classes, CH1 and CH2. But this is for other than seawaters. Then third category is the corrosion induced by chlorides from seawater. For that, we have got basically 3 other conditions, SW1, 2, and 3. First is exposed to airborne and salt, but not in direct contact with seawater. Second is permanently submerged. And third is tidal zone. But in the first one, because it is not directly in contact with water, so we have got a further subclasses of ABC depending upon the distance from the sea coast. So if structures near the sea, depending upon exactly how much they are from the sea, so that is one exposure class. Then permanently submerged, there is another exposure class, SW2, and SW3 is tidal or splash zone. Then how to achieve the durability when we have got these exposure classes? And now coming to the what is the current international status on these studies on the durability service life design? What documents are available? We had ISO 16204 in 2012 available. However, that is only a model code. That gives the basic models which we had been discussing for the time-dependent models for determining the duration of a period of time in the structure. But those models are generic in nature, and then the coefficients mentioned in those models equations, they say that country level it can be decided, depending on area it has to be decided, depending on type of cement that will vary. So that those codes cannot be directly specified or directly used. And then other code as the FIB model code, 2010 was there earlier, which came in 2012 or 13 earlier. But that is also a model code, and there also the coefficients were not so explicit. There were issues in that. Now model code 2020 has come, which is published in 2024, only recently. And that we have not yet studied also. But by 2024, our draft was already ready. So we have, in fact, done a lot of study, as in the inauguration speech also I was saying, that based on our lot of studies over the years and the decade, we have decided all those basic coefficients and parameters applicable for our country, and decided the models to be used for the achieving the durability. Effective type of cement, this has been explained in the morning by Mr. Oja. PPC and OPC, PPC and PSC are more durable than OPC in coastal environment. OPC is more durable as compared to PPC, PSC in case of non-coastal or non-aggressive environments, where only carbonation is critical. Point to be taken care of while using PPC are early age strength, curing period, and extra cover. This discussed in detail in the morning. Now coming to the limit state, because we are using a limit state design, we have to define the limit state. What is a limit state? Because for strength, we know what collapse is a limit state, or serviceability limit state is there. So for durability, what is exactly the limit state? So that we have to decide. See, what are the stages in the when the structure is exposed to environment? So first comes the depassivation, that is stage 1. When the depassivation layer goes up, and for carbonation, the pH value goes down, and in case of chloride, the threshold level is achieved. So that is called depassivation. When the corrosion starts, what we see is that when depassivation is there, the corrosion starts. The starting stage is one stage. Second stage is when the cracking starts appearing because of the corrosion. That is the cracking stage. Third is when the plaster starts falling, or concrete spalls. And then collapses later on when the structure loses the load carrying capacity. Now, what should be the limit state? What we have decided is limit state for carbonation. For carbonation, we are keeping a limit state of the initiation of cracking. When the cracks start appearing, that we consider as the limit state. So we have to design our structure that if it is a service life is 50 years, the 50 years the cracking should not happen. And when the cracking starts, that means your end of service life. So that is the limit state definition when the structure are exposed to the carbonation mechanisms. Now this consists two parts. One is depassivation, other is the propagation of corrosion. For depassivation, we have got models and equations which are time dependent. We can determine the time based on those parameters, depending on the carbonation coefficient and the material used. We can calculate this T1 level. But for T2, propagation, though a lot of research has been done, but there are no acceptable models as of date. Corrosion rate, people are measuring, we have also done it, but that is not an acceptable time-dependent model is not available. So for the secondary part of T2, we are giving a table which gives a fixed value of the years, that so many years you can consider as T2, and for the remaining years, we do the calculation of part. So, but however, for the chlorides, when it is exposed to chlorides, then we are keeping a limit state of depassivation only, because in case of the chloride attack, when the threshold level is reached, after that, corrosion is comparatively faster than what is in carbonation. So that short period, we are considering only as a factor of safety, and we are designing the structure for depassivation, for which models are available. Acceptable models are available. So first, coming to the carbonation mechanism. For carbonation, when more the calcium hydroxide, more the service life, which is in case of the OPC, it is available more. In case of PPC, it is consumed by fly ash to some extent, so it gets reduced. More the cover, more the service life. Less the porosity, more the service life, so a dense concrete will perform better. More the CO2 concentration in the atmosphere, less the life. So CO2 concentration of the atmosphere also matters, though it doesn't vary too much within the country, but still that factor is there. Other main factors are humidity and temperature. So for that, we are considering the climatic zone also. So for which we are given a table of weather coefficient. We'll come to that. So definition of limit state is this, as I will discuss. We can skip this also. Now, how we design it? Our action and effects are characteristic value of CO2, that is our action, and climatic coefficients are our action. And resistance should be provided by the carbonation coefficient. That concrete has to have so much of carbonation coefficient, so that we can define, and nominal cover we have to define. So with that, we will specify the durability. Okay, I need this much of cover, this type of cement, and I want this kind of carbonation coefficient. So a structural engineer can specify that. And then we have to achieve that at the mixed design stage. And after the mixed design, we have to verify it by the durability testing. So verification is by first the calculation and then by the testing, durability testing. The calculated service life is divided in two parts, as I have said. Total service life is initiation period and the propagation period. For propagation, we are giving a fixed value. So initiation period is total life minus the propagation is the initiation period, for which we will be doing the calculation. The basic model is this, which is available in the literature for many years, maybe more than a decade or so, rather more than that. K into W into T, that is the depth of carbonations or the depth of cover, you can say. It is carbonation coefficient into weather coefficient into time power X. That power used to be 0.5, but now we are changing with the type of material, so we have put it X. X value will vary. But this is a basic model. Now we have to specify, we are linking it to the carbon dioxide level also, and because it is a limit state, we are linking it to factor of safety also. So we are refining it to this equation. It is basically the same equation, slightly modified, where instead of carbonation coefficient, we are using design coefficient. That is what design value we are using. And in T for time, we are using TI, that is initiation period we are using here. And then we are linking it to a factor of safety, gamma F is there. And CO2, design CO2 level divided by 500. This 500 came from the fact because most of the studies were in the carbonation chamber where the calculations were equal to 500 ppm. So if actually is little less than that, so it is a modification factor. Now, the values of carbon dioxide to be considered in the design are given in the code. That values vary from 350 to 450. 350 is for all areas under exposure class C4 and areas in exposure class C1 to C3, but away from urban areas, rural areas because their traffic is less and all that. So that is the lowest level of 350. That is the common level available of carbon dioxide in the atmosphere. 400 is for internal members of air-conditioned buildings and exposure class C1 to C3. 450 for external members of urban and non-aggressive industrial areas, exposure to C1 to C3. So that is a minor difference we have created where CO2 can increase. Now, to proceed further, then once we have decided this, what we're saying is carbon dioxide level, from this we go back to this equation. Now, once we put this, and as you were saying that we have to calculate the cover. Now, you can assume a cover here. You can take your own cover and you can specify the K1 value that this should be the coefficient, carbonation coefficient for the concrete. So that can be specified by the structure engineer, not the cover. You will fix it. You can cover C, you can input, and you can calculate the K1 here, and then you specify the K1 value. So then in the code we can put that note also to make it more clarified further. Now X here is dependent on the type of cement, because for PPC we are having I think 0.45 and for OPC 0.55 perhaps. So we have to decide type of cement, cover, and then we have to specify the carbonation coefficient. That structure engineer will specify that type of cement will be this and required carbonation coefficient should be this. And for those values, the mix design consultant or material engineer will design the mix.
The structural engineer will say only about the cover. That for this member, I need this cover.
No, but service life also he has to take a decision. No? For what service life he is doing, durability.
Service life will be decided by the structural engineer.
It can be. See, if you have a separate material consultant available, then he can decide it. But otherwise, normally structural engineer, because for all normal structures, he has to specify.
Sir, structural engineer, generally, I mean to say.
It is coming under the structural design sector. It is coming here. Fine.
So, structural engineer, how many things he will decide? Carbonation coefficient, type of binder, the value of X, this, calculation, all those. So, a structural engineer is looking at the structural design aspect. So, he will decide the concrete cover, then exposure class, environmental class, deterioration mechanism, yes, all these things is a scientific aspect. Material science only can deal with that.
Okay. It may be teamwork, but point is, no, just a minute, just let me. As in the morning you said yourself, I think you only mentioned that basis of design should cover this exposure clauses and all.
Yes.
So once basis of design report is finalized, then only structure design will be done. So structure design knows that basis of design, what is the exposure class and all that will be decided.
What is the service life? It will be decided by the client. He will decide how much year this structure should survive. That will be picked up by the structural designer, and the design basis report. This will be the one parameter. I am designing this structure for 100 years, 150 years.
Yes.
And then you, structural engineer and the material engineer should have to work.
Yes. Yes. So that is my point.
We'll draw a flow chart.
Sir, point is for larger projects, you can have two teams working together, but for normal projects, small project, only structure engineer will be working. No?
For small projects, 50 years, we have given the table. No? Directly table is available. So all these problems of design comes when the service life is more than 50 years. And when more than 50 years, structure is important structure. Not
So
for classification, but for general perception.
See, structural designer is doing the 6. Once we say that structural designer has to check the 6 limit states. Now, structural designer may take help of the material consultant, or depends on the owner. Project owner will decide. If project owner appoints a material consultant, then he will decide. If the owner leaves it to the structural engineer, the structural engineer will decide. I can modify my language to this level.
Sir,
Then it will be decided by the owner. So it will be the prerogative of the owner to decide whether he has to hire a separate material engineer or he will leave it on the structural engineer. So whosoever is a consultant, I will say, okay, I will leave it, use the word authorized consultant. Is that okay?
Sir, the design life has to be specified in the codes.
No, that we have suggested. No, we have suggested design life.
Let me finish. The owner is not as intelligent as you people, who is going to decide the design life? Because service design life has a different definition. It has got nothing to do with, they will say 500 years.
Sir, this is a table. This is given in the code.
But sir, this thing is for normal structures. You are saying beyond 15-meter height, a building, that is not normal.
No, not for normal. It is not for normal structure. Sir.
No.
This table is for all buildings. This table is for applicable to all buildings. You see, first is low rise, then mid rise, then structures, then monumental building. All are covered here.
Definition is
All are covered
if
here.
anything is to
Only
be
thing is,
modified,
why I say owner is,
modify this.
owner can take this guidance, or he can, for example, for normal low rise building, he may decide 75 years also. And then we have said 50 to 75, then he can adopt 60 years also. So finally they will decide. This is what is given in the code. This is given in the code, so accordingly we have to move further.
It's possible to design today and give to you. That's the point. Yeah, you're good. That is
Now, so let us continue. We'll try it. So now once we decide the carbonation coefficient required and we type of binder required, then we can calculate the water cement ratio from here. That is for the mixed design initial assumption, basically initial stage. Then we will test it and check it. Like we assume water cement ratio for strength and then we test it later. That is how it is. Then characteristic value and value of, so we define the K1D. From this we can work out this. This is, I can skip also. This is only a factor safety thing. Nominal value of cover to be considered. We have given here also some factor of safety. For quality assurance levels, if it is normal, then you have to apply a factor of safety 1.1 in the design cover also. If the factor of safety is high, then only one can be taken here. So slight modification we have made here. Then climate coefficients, W to be used in the equation. That for that also the table is given here. For depending on exposure class, we can select the climate coefficient to be used in the equation. That is not much complicated, very simple thing. This I already discussed. Then propagation period, I said, it is already defined in the code. So this is a table given in the code for the propagation period in case of carbonation. So from the main service life total, we have to deduct this value. And for the remaining, we have to do the calculation, initiation period. Now this table is for the different exposure classes. And some note is also given here for important structures. Better assessment can be made using available models for important structures. You can do it. Otherwise, you can use this table only. So corrosion initiation period, as I showed this equation earlier also, once we have got this binder decided and the cover decided, we can work out this. We can either work out the initiation period or we put the initiation period and decide, go the reverse way. Either way we can do it. But if you have done the mixed design, you have worked out the coefficient, then you can check the design life here also. Either way you can do it. Now verification of performance of testing. Now we have given two types of testings. One is short-term durability testing, other is the long-term durability testing. Short-term testings we included for the carbonation mechanism is the electrical resistivity test and the oxygen permeability test. Now things to be noted here is electrical resistivity test is a must because that is for mixed design as well as for quality control. So for mixed design, electrical resistivity test has to be conducted. It is mandatory. But for quality control, if you can use the oxygen permeability test, for which a Indian standard is also available now, and if you do that, then you have to do both the tests in the mixed design stage, so that initial values of oxygen permeability you decide at the mixed design stage. Then you can, for compliance, you can use the permeability test. This is electrical resistivity test on the left side, and the right side oxygen permeability test is given. And for long-term testing, we have got the carbonation coefficient test. This is also called accelerated carbonation test. It is accelerated, but still it takes time, so we call it a long-term test because it takes minimum 70 days plus initial 28 days and conditioning. So How much total period? 4 months. So 3 months or something you can take it, 4 months it takes. So that is why we call it long-term test. So for important structures, you have to do this testing. For normal structures, you can do the electrical resistivity test. Electrical resistivity test has got a less coefficient of variation than the oxygen permeability and RCPT, so that is preferred. And we have given ready-to-use tables for that values of resistivity required for the given carbonation coefficients. Now, this is the procedure when we design it for that. But for normal structures, we have simplified the life of engineers by providing the ready-to-use tables also, like in the previous code it was there. But these tables are a little more exhaustive than the previous ones. Now, this is the table we have. Now, depending upon the type of exposure and type of binder here, because earlier the binder was not linked, here we have got separate for OPC, PPC, and PSC. The requirements of type of cement, what you are using, then you can decide the minimum grade, minimum cover, maximum water cement ratio. And then at the last column, you can see, even if you are using the tables, the last column is the requirement of the test given, electrical resistivity. So that you can use this parameter, but then you have to design a mix and then you test it again for the resistivity. You have to achieve that. If you are not able achieving that, then you have to modify your mix accordingly. So this is continued table. Earlier was 2 exposure classes C1 and C2, then C3, C4. Then we have notes under the table. For QC test, value of durable test obtained during mixation stage. Yes, if we have got a minimum requirement of resistivity, but if you are getting a better value at the mixation stage, then that better value has to be used in the quality control also. For that, you cannot go for the lower values mentioned here. So the stringent of the two you have used. What is mentioned here or what you have achieved at the mixation stage, stringent of the two you have to use it. And for composite cement at the last, the water cement ratio shall be as given for PPC. For Portland limestone calcined clay cement, the water cement ratio shall be reduced by 0.05 from that required for PPC. And then there are some other notes for depending on quality control levels and all that I am not going to detail into that. Now coming to the chloride ingress. For the chloride ingress also the basic procedure is similar to what we are doing in carbonation, but the equations are different. And as I said, we are not considering propagation period there, only depassivation period we are using there. Limits of durability for duration due to chlorides will be given the threshold value of chlorides. Here, there we only see whether the cover concrete is carbonated. So that is simple test here. In the case of chlorides, we have to check the threshold value, for the permissible threshold value of the chlorides. That much concentration of chlorides should not be there near the reinforcement, which is done by slicing and measuring chlorides at that level. So here, there we have the carbonation coefficient. In case of chloride, we have the chloride diffusion coefficient. So in this equation, we have to use a surface chloride values also, to which it is the RCC is exposed to, so that is the maximum level which is available. So that surface value of chlorides is given in the code for different exposure conditions. And design values are to be used with the after applying a partial factor of safeties. Now these are the characteristic values of the surface chloride to be considered for different exposure conditions. For SW1, depending upon the distance from the shore, the values are changing. Then suddenly it will be more when it is immersed in chlorides. Now that was the surface chloride level. Now we are starting from that chloride level. So that chloride starts diffusing into the concrete and concentration near the surface is high, slowly goes on reducing near the reinforcement, and it keeps on increasing till the level time near the reinforcement, this threshold level is achieved. That means depassivation has occurred. So threshold levels are given like this. For concrete made with OPC, we are giving a 0.4% by weight of cement as the threshold level. So if this much concentration of chlorides is there near the reinforcement, 0.4% by weight of cement, then you have achieved the depassivation, you can declare it. So that is the end of service life kind of thing. Similarly, for concrete made with PPC or concrete containing more than 25% fly ash, we got 0.3%. And for concrete made with PSC or concrete containing GGBS more than 50% is 0.3%. Now, PPC and PSC, they perform well in case of the concrete exposed to chlorides, as in the morning was discussed at length. However, the negative aspect here is that threshold value for that cement is less. At 0.3% concentration, we call it a depassivation. But in case of OPC, we call it 4.4%. So we permit more chlorides in case of OPC. In case of PPC and PSC, we permit less chloride to some extent here. But still it performs better because diffusion is very slow. That point, even for reaching 0.3%, it will take much more time in case of PPC and PSC. So still they are more durable than OPC in case of chlorides. Now, this is the equation which is based on the Fick's law that is followed. There we had the carbonation coefficient equal to CKW. Here, this is the equation which is which involves the error function, and it is need to be solved. So this involves surface chloride, the threshold levels, and the initial chloride in the concrete. Cx2 is there. X means the depth, at depth left, how much concentration is there. So that we are limiting to threshold level. CS we have given, CI we have to check, because whenever you are making a concrete, the initial chloride content in that concrete, how much is there? If that is high, so quickly you will achieve the threshold. If initial chloride content is low, so then it takes more time for that to reach at 0.3 level. Because initially we are permitting only 0.15%. So from 0.15 if you are starting to 0.13, it will take lesser time. But if your initial itself is 0.1 or less than that, then you will have more life. So initial chloride content, that water, what you are using, cement, what you are using, that chloride also matters in case of chlorides. So CD here is the chloride diffusion coefficient. That's within the root we have mentioned CDT. So that is the chloride diffusion coefficient we have to input here. So these are the equations where linked to the water cement ratio. These equations we have a lot of experimentation. These equations have been worked out for different water binders. These equations will give you some idea of the chloride diffusion coefficient which you will achieve. So for initial mixed design, you assume these water cement ratios. You can work out from here for OPC, PPC, and PSC. 3 equations given separately. So depending on type of binder, you can know what is the requirement of chloride diffusion coefficient. Sorry, you know the chloride diffusion coefficient, you can work out the water cement ratio for mixed design here. Then verification using the testing as the further verification, short-term test and the long-term test. In this case, the tests permitted are electrical resistivity test and RCPT test in case of chloride exposure condition. And out of these 2 tests also, what we recommend is still electrical resistivity test, because resistivity test has still lesser coefficient of variation than the RCPT test. So preferred is that, but because RCPT is commonly available, so that has been permitted here. Later on, we will see the experience, feedback, and then further decisions can be taken in passage of time. Because initially labs will procure electrical resistivity, but every site will not have it. So for site quality control, you can use RCPT values.
One question here. The equations you are giving for the diffusion, chloride diffusion coefficient. I just wanted to know what is the source of this equation.
This is developed by detailed research at NCB and IITs and all that data we have collected, and we have created these equations based on experimental data.
These equations derived?
Yeah, they derived, of course. All equations are derived, sir. In engineering concrete, every equation is derived from research only.
We have not seen any papers.
No, many papers, we have published papers on this. We have published papers. But American and European paper you may not see because this is our data. Now, in long-term test, in that this case is unidirectional chloride diffusion test. This is recipe test, short-term test. RCPT test is this. And long-term test is when the samples are immersed in the chloride for 3 months and then for 90 days. And then by profiling, we know we do the profiling, slicing, and then we do see how much chloride has gone to what depth. So that is plotted. With this plot, we work out the chloride diffusion coefficient by regression analysis. This is to be done in the lab only, not individuals have to do it. This is a testing to be done in the laboratory. This is long-term test only for normal structures, which may not be possible always. For important structures, this will be done at the mixed reagent stage by the laboratory. So they will work out the chloride diffusion coefficient using this. Now this is just an example of how OPC, PPC, and PSC charts are there in the question analysis. So at threshold level, you can have different covers for different cements. So similarly for this chloride also, we have got ready-to-use tables like we said for carbonation. So similarly for this chloride also, we have got ready-to-use tables also. Now in these ready-to-use tables, at the end, in the last 2 columns, we are given the values for 2 tests. Option is there, a recipe test or the RCPT value. There we had value only for electrical resistivity for carbonation. Here we have got 2 options available, but I prefer again electrical resistivity. So notes you can read, and now thank you very much. No, some people have been asking earlier.
We will restrict to 2 questions now.
Okay, 1 or 2 questions. Remaining can be the panel discussion.
Yes.
Are we giving the US on the climate zone map? Are we giving the list of also in which some important towns and cities?
List of towns and cities. Yeah, that comment has come earlier also. So we have not yet included, but we will try to include it. So we need to expand this map and try to do that. We have not yet given so far. But we have thought of giving it and we may give it.
Sir, these tables that you have given, they are only for normal structures. Now, as normal structures of a particular type, what I'm wanted to ask is that you got 4 types of categories of structures. Firstly, all those 4 will be different. Can we not have similar tables as a part of the code, as a part of the not handbook, explanatory handbook, commentary, so that one doesn't have to see all this.
Okay, I will answer that. See, we are calling it a performance-based design. Means we are giving you some flexibility here. Beyond the minimum level, that tables, those tables have 2 purposes. One is they are ready to use for normal structures. Second purpose of that table is that those values we have mentioned that these values are the minimum values. Less than that, we are not permitting. So that significance is of that table is that. Now, if you are designing it for 75 years, you have got a freedom that you can adopt a cover of 25 mm, or 30 mm, or 35 mm. Accordingly, you can choose the concrete, or you can have a lower cover. No, that cannot be done in tables. Then you will have so many tables. So that flexibility is there.
But we can have a software.
Sir, these are 2 equations which you can put in any Excel sheet. So I can make an Excel sheet and give it to anybody who needs it. So these are only 2 small equations which you have to use it. You are using for design, you are using hundreds of equations. For durability, you have to use only 1 equation and then you are saying you need a table. And that equation is also a very simple equation. Rest data is given in the code.
So it looks tough, it is simple.
It is, there's nothing. For a structural engineer, that is.
That one has not used
Sir,
this,
I tell you.
but it looks a little complicated.
No, it looks like, but once you do it, it will be, you can make a sheet and all that. That is very simple. In the morning I said, certain equations we have to put a note. Like equation we are given, so we can mention there that if cover is decided, then we work out the coefficient from here. So that will make it simplified. So now this equation doesn't say whether you calculate the cover or whether the code only says you can calculate service life, but actually you have, that is the input. So that clarification we can add here. Ki code says this is the equation to calculate the service life. Actually we are going reverse. We are putting in service life and then we want to calculate the parameters. Equation is same, of course, but we have put it in that way. So we can put a note there that will make it more simplified. For a structural engineer, this is the most simplest thing because they are doing so many calculations and this is a very small thing for them.
That is all buried in charts and details, they don't see it.
Anyone, one more question? Yes.
The question is simple, terminology different.
It's actually
No, you can press it long press करेंगे तो छोड़ दीजिए. Okay.
फाइनल डिस्कशन से पूछ लेना, नहीं याद आ रहा है.
No, hand mic ले लीजिए. नहीं, hand mic.
Yeah, I must thank. Also, I'm a panel member, but still I thank BIS to introduce this section because in our industry we sometimes get a lot of requirement of service life of a structure 75 years, 60 years. We didn't have any criteria what to do to meet the basic criteria. Although we know that degradation of structures and can we give a provision of climate change as some factor? Because for longer service life, climate change can be affected on your temperature. And the coefficient what you are taking now may not be valid at the end of the service life. So is it a possible, say for instance, some 10% or 15%, just roughly? Thank you.
However, to compensate for all that, we have tried to keep some margin of safety for the longer service life. So, sorry, this mic was off. So, we have tried to put slightly margin of safety when we are doing for longer service life. So, and I think somewhere I have mentioned also perhaps in the code that some additional factor of safety may be taken. So, as of now, we are taking it under the factor of safety only. And later on, we may be able to do that when the research comes on that. No, whatever the equations and whatever data is given, that's some, we have considered little bit of margin of safety there.
That is already inbuilt, you wanted to
one
mean.
more there, and they see data has to be generated with, as the new thing comes in, more research also starts. No, when initially there was hardly any research on the carbonation. Our country is totally exposed to carbonation, but we were following Europeans, they were working only on chlorides. When I gave the first paper long, I think about 20 years ago, 15 years ago perhaps, that time, very limited carbonation research papers were there. After that, slowly when we started doing it, now you see many IITs, NITs, carbonation research is going on. So once this thing comes on, then more research will start, people start doing it on these areas also. Like even for the blended cements.
I would like to comment in one line. This design is just similar to for load design. Okay, the load design, what we are doing, the putting the load, calculating the resistance provided by the concrete structural members, and then we are doing the provisions as per that. This design is also similar. Here the load is environmental actions, उस slide में दिखाया हुआ है, and the resistance provided by the concrete against that deterioration. Okay, so when you are estimating the environmental actions, there is a associated uncertainty there. Yeah. And for those associated uncertainty, there is a partial factor of safety which is being multiplied there. Here, when we are calculating the resistance provided by the concrete, here also there is a partial factor of safety which is divided there. just like load factor design, load design. And in that way, we are designing and we have equations, those two equations over a period of time. So third type of dimension has come. We are having equations, resistance, load over a period of time. And looking with this philosophy, we are designing for durability. So associated uncertainty in terms of climate change has been taken into consideration in the associated uncertainty. One can estimate there is a more associated uncertainty. One can assume accordingly the more means partial factor accordingly. And that
So
will
what
take
he is
care of
actually
it.
saying is, what he actually want to say is that if you are designing for 50 years service life, then your factor of safety maybe should be lesser. And when you are designing for 100 years, we should be considering something extra.
That
So
has been taken. There is a table in which what is for 75 years, what is for 100 years, there is. And that's why I am saying associated uncertainty.
So
has
that
been
will
taken.
keep, and then it is a continuing process of improving and all that. By that time, we will have more. Okay, thank you very much.
We will now move forward to technical session 5. I invite Dr. Brijesh Singh, General Manager and Head CCES, National Council of Cement and Building Materials, Balabgarh. Dr. Brijesh Singh is a distinguished concrete technologist, researcher with over 18 years of experience in concrete technology, quality assurance, condition assessment, sustainable construction materials, and advanced concrete composites. He has authored more than 170 research publications and 10 book chapters and is actively associated with several BIS and ISO technical committees. His contributions have been recognized through several prestigious awards, including Outstanding Concrete Technologist Award, Professor V. Ramakrishnan National Young Scientist Award, and NCB Best Scientist Award, and many more. I request Dr. Vijay Singh to kindly deliver presentation on importance of construction and quality assurance aspects. Sir.
थोड़ा फास्ट बोलना है अच्छा So okay, good afternoon everyone. So I will try to finish it quickly because we are running late. So today I will be talking on the construction and quality assurance provisions which are going to come in the new standard, that is IS 456-2025 draft. So when we talk about the quality control and quality assurance, we come across different terms like quality, quality assurance, quality control, and acceptance, and all those things are well known to you in terms of its definition. But till now, what we are following is a simplistic quality assurance framework, which is given in this IS 456 in very brief. But the new IS 456 brings a very comprehensive quality assurance frameworks, which consist of different quality assurance levels. Some we have discussed from the morning itself. And the chapter 11 is going to talk with respect to the quality assurance. And this is very important. Whatever research, whatever equations, whatever modeling we do, ultimately it's the role of a site engineers to make sure that those things get translated into the structure in forms of its performance. So basically a total quality management system needs to be followed. A proper quality policy as well as a quality plan for design, drawings, detailing should be made. And in that context, the design basis report becomes more critical. So at the time of design basis report, these things needs to be sorted out, that in which class the structure needs to be in terms of its quality assurance, what kind of materials to be used, because you need to have a structural engineer, you need to have a material scientist, a complete team is needed if you are going for a very high quality assurance level. If it's a normal quality assurance level, even a normal structural designer can do it. But if it's a quality assurance level 3, which I'll be talking in the coming slides, there you have to be more careful. So when we talk about any quality assurance, the first and foremost part is the inspection. These things we are doing partially for many projects, and in some projects, if you talk about the quality assurance plan, these things are dealt in detail, particularly with respect to the materials to be used for the concrete making, source of the materials, the testing of the materials. When we talk about the site issues, the tolerance in the formwork, and then if we talk about the reinforcement work, bar bending schedule, detailing, then concrete production, And then at the last stage, the post-concrete inspections. So all these things we are doing, but we are doing in a very, you can say, a limited manner. But if we talk about the new code, it gives a more detailed framework. From the morning, you are hearing about the different quality assurance levels are getting introduced in this new IS 456 2025 draft. And this section 11.1 talks about the quality assurance level 1, 2, and 3, depending upon the importance of the structure. For example, whether it's a normal structure or a medium structure or a high-rise structure. And it also depends upon the number of stories or the floor area, as well as the different kind of the importance which are going to be associated with the structure. And this is similar to the EN standard 13670. And in India, there is an Indian Road Congress standard, IRC, I think 112, that also talks in brief about these things, but not in detail. Now, when we talk about the comprehensive quality assurance framework, we need to tackle all the aspects, and that starts from the design basis report itself. So once the design basis report is ready, we need to talk about the design and drawings. And it again depends upon what is your quality assurance level. If your level is 1, then you don't have to go for a third-party vetting. But if your quality assurance level is 3, in that case, a mandatory certification from the third party, I meant to say the proof checking of design is mandatory. Again, if your quality assurance level is 3, which is for an important structure, your quality manual and quality assurance plan has to be more comprehensive and in more detail. Then when we talk about the supervision, also in case of the quality assurance level 2 and 3, which is for a medium and a high range, there should be a requirement for the site engineers, what should be the experience, what should be the qualification, because more critical is the structure, you need to have a more experienced engineers who understand the quality assurance framework. As far as the concrete making materials and concrete testing is considered, a lot have been talked from the morning itself that you have a different Indian standards, particularly for aggregates, cements, admixtures, fibers. So there are so many materials of, for example, reinforcing steel, pre-stressing steel. So there are codes and we need to follow these testing protocols as per these codes. However, the new code has a certain important aspects which are going to be there, particularly with respect to the durability testing. Till now, whenever we are going for the quality assurance of any structure or quality control, we don't do any test with respect to the durability at the site. But a new code is making sure that for important structures, if you have a quality assurance class 3, you need to go mandatorily for the non-destructive test and up to some cases, few concrete core tests. So this entity is being given more and more importance in the important structures where the quality assurance level 3 are being used. And then also in quality assurance level 3 and in some cases 2, some chemical tests on the hardened concrete samples are also being included, particularly with respect to the chloride and sulfates, because the quality of water, if it's not proper, this chloride and sulfates can create a severe damage to the structure. And many of the structure itself in this NCR region has undergone the distress even after 5-6 years. So we are talking about a service life of 50 years, and what we see in the context, after 6, 7, or 8 years, the structure goes into serious distress. And if it's a chloride-induced corrosion, the repair is even more tedious. So we have to be careful, and we need to understand these different quality assurance levels. And in the beginning, we have to select and make sure that all the materials with respect to the concrete, steel reinforcement, pre-stressing materials are as per the required specifications and as per the quality assurance requirements. So whenever we talk about the quality inspections, the inspections before the start of the work, then during the work and after the work. So all these things are known to you. So I will not go into detail, but when we talk before the start of the work, all the design, drawings, etc. needs to be properly developed, built, and then if it's an important structure like quality assurance level 3, then in that case you have to do the proof checking and make sure that everything is documented properly. While going for the inspections, we need to make sure that all the test results, materials which are being used are getting checked, tested, verified. All the documents with respect to your bar binding schedule, reinforcement detailing, all these are there at the site. Concrete production, particularly if you are using a ready-mix concrete, your batch mix printout, slump test values, all those details needs to be documented, because in case if something happens in future, you need to do the cross-check what was happening during the construction. If you see the quality assurance plan we do now, we don't have the document available many times at the site. So if you have a more stringent quality assurance level, all these documents will be made available and it will be easy to find out any kind of distress or damage which is there in the structure. Now coming to the section 11.4, which talks about the sampling and testing of the concrete. So it's similar to the IS 456-2000. However, there is some tolerance given particularly for the slum design. It is there in the IS 456-2000 also. These are the values which you can see in the code. So I will not talk much on the workability tolerance. It is there. And then we talk about the hardened concrete. So when we talk about the hardened concrete, this compressive strength and flexure strength are the two important tests. Generally for building structures, we focus mainly on the compressive strength. But if the concrete is used in concrete roads, there the flexure strength becomes more important. So this is the quantity of concrete versus the number of samples. This table is similar to what is there in IS 456-2000. So not much to talk about this. But when we talk about the acceptance criteria, there is slight change. If you see the acceptance criteria in IS 456, it is slightly different from this. Here what you can see that for concrete grade M to M55, the minimum individual value for a single concrete cube specimens in a group of 3 cubes should not be lower than FCK-2. And if it is between M60 to M80, this value should not be less than FCK-0.5x. And when we talk about the average value, which is a 4 consecutive non-overlapping samples, in that case, it should be a maximum value of FCK plus 0.825 sigma or FCK plus 0.5x. So here 0.5x, the x value is a standard deviation, which you can take from the code. And if you have a site-specific standard deviation, that also can be used. But in both the cases, the value should be higher of this. So maximum value needs to be adopted. And for working out the standard deviation, as it was the case in the previous version, minimum 30 samples needs to be there. Then the more focus has been placed in the non-destructive test. If you see the IS 456-2000, there is a brief one-page, you can say, data on the non-destructive test. I think clause 7.
Just one point. This acceptance criteria you have changed from the earlier code. Now you have put it 0.5x.
Wait.
Just last one. Yeah, these acceptance criteria.
No, wait, sir.
Which you have changed it from the earlier code. Earlier it was FCK plus 3 or FCK plus 2. But now you have changed to plus 0.5x.
Yeah.
There is any basis or arbitrary?
No. If you see the code IS 10262, it gives the value x, which is the assumed standard deviation as per the code. There is a basis. The value which was used as a sigma earlier, if you see the table on the right-hand side corner, it gives the value x, particularly we say 5, 5.5, 6.5. So these values have come based on some data. So we are comparing FCK plus 0.825 sigma or FCK plus 0.5x. Earlier there was a single value, FCK plus 3.
Yes.
If you say. So if you see, for example, M10 to M15, the value is 5. So if you say 0.5, it is 2.5.
Yes.
If you say 6.5, so it is a marginal improvement, and you can say it is on the upper side. Then there was some changes in the code, something came, FCK plus 4. If you remember, there was for a single
specimen
set of cube, there was FCK plus 4. So that value, even if you use 0.5x, it is coming between, the maximum value is 8. So 8 by 2 is 4. So
my question is, yes, earlier it was FCK plus 3. Now we are made it FCK plus 2.5.
Sir, FCK plus 3 was in the 1978 or maybe 2000 version, earlier one. Then there was some changes were made, and there was again FCK plus 4 was made for a single set. Then there was for if you were 2 set, FCK minus 2 and plus 3, like that. Some changes.
Only my question is there, this FCK from FCK plus 3 to FCK plus 2.5. Is it arbitrary or is it based on something?
Sir, it's not arbitrary, sir. The point is that earlier we were dealing in our country mostly with M25, M30. If you talk about 20 years back, generally we were not even dealing with M40 and M50. But since this bandwidth is from M10 to M55, as this grade of concrete increases, your standard deviation value will increase.
Yes.
So if we keep that value FCK plus 3, it may not be a right decision. Because earlier, we were hardly dealing with M40, M50 if you talk about 2000. But now we are dealing in pre-stressed concrete, mostly M35, M40, M50. And for that, the
Your
state.
standardization high, maximum 6 year. It is not going to below 6. Standardization for higher grade, 0.6.
No, sir. That is the assumed standard deviation versus X. So this value is there, but if you see, if you go on the higher side, it's better to have this X value because there is a chances that your X will be more than sigma, right?
But in the lower side, it is becoming 1.5. Suppose the standard deviation 3.
1.5? Where is?
When the standard deviation 3. FCK plus.
FCK plus 3 are not 1.5 because earlier it was FCK plus 3. Here we are saying 0.5x. So whatever value I am showing as X in table, it should be 0.5 of that, half of that, right?
Yeah. The standard deviation is 4, it's becoming 2.
Sir, you were talking now, if we go for high strength concrete, even your standard deviation is as high as 8. Now, again, this table does not talks about the CND based aggregates, where your sigma will even be more. So still, we have to mention in this about the CND waste also, sir, because this FCK plus acceptance criteria may not hold good for construction and demolition based concrete. So we have to at least enhance by 0.5 or 1. So committee may look into that. Just now after the question, I thought, because for CND aggregate, we don't have anything in this. So acceptance criteria, because there your sigma is slightly higher, maybe by 1 MPa. So this acceptance criteria is for a concrete with a normal aggregate, not with CND based aggregate. Am I right?
Yes.
Yes, sir.
And based on that, we are fixing X value.
Right, sir.
Earlier it was 3, FCK was 3 was fixed.
Yes, sir.
Now we are varying from 2.75 to 4, depending on the grade of the
Right.
only change.
No, sir. What I am saying, we have done the research on CND waste, but there we are getting sigma 1 MP higher. So we need to have some note for a concrete with the construction and demolition based, right? So coming to this non-destructive testing, so this is being made given more importance for the non-destructive testing for a quality assurance level 3, where the test like rebound hammer and ultrasonic pulse.
Yeah, Dr. Singh, this non-destructive testing also I got a question.
Yeah.
This you have put standard rebound hammer and ultrasonic test both, but only you have not mentioned any age. Whether what age construction stage you are at what age you want to do this testing must be mentioned.
Sir, first of all, I will tell you, I am talking about the rebound hammer and UPV, right? If we talk about this rebound hammer is only an indicative test. First of all, this should be never used for making a decision. If you see the code, the first line itself says rebound hammer test is indicative in nature and has to be interpreted with other test results. Number one. Coming to your question of at what age we need to do. If you talk about the UPV, we have now the 2 different classifications, one up to certain grade, right? And then M30 and beyond, we have a different classification. So whatever is your strength, for example, at 10 days, 14 days, 18 days, right? If you do the UPV, you are getting the value in terms of quality, right?
Yes.
So according to that, even if 7 days, your quality has to be minimum good. It cannot be doubtful category. Number one.
Then are you suggesting you could do it continuously 3 days, 7 days, 20?
No, sir. We are not suggesting, sir. Anyhow, the concrete, for example, will attain a sufficient strength after minimum 3 weeks. Minimum 3 weeks is needed. If it's PPC, you need minimum 3 weeks.
Okay, 3 weeks you have to mention then.
No, sir. See, sir, everything cannot be mentioned in terms of age. What is the meaning of mentioning 3 days? Because if you talk about the concrete cube strength criteria, we have a 28 days acceptance criteria. If you remember the rebound hammer curve, which you are using 40 years back, it gives the value between 14 to 28 days. Why 14 to 28 days? At that time, OPC was more popular. Now PPC, composite cement, this limestone, sand clay cement, all those have come. So age is 28 days.
My concern is that you must mention some age.
Sir, age is 28 days, sir. Do you have any acceptance criteria for 7 days? No.
But
no,
then you are
sir.
telling at the stage of construction stage.
Yes, sir.
You are writing here at the time of construction.
Yes, sir. At
28
the time
days is long time.
Sir, at the time of construction means not at the time of casting, sir. At the time of construction means during the construction process, sir. It can be, in my opinion, it should be 28 days. Because now so many types of cements are coming and early strength can be a problem. So it's better to have a 28 days for all kinds of cement to go for rebound hammer and UPB test. But if you talk about, for example, Tandon Sahab, he wants to do a pre-stressing. He will ask for a 7 days strength or 10 days strength for pre-stressing for comparison purpose. Then he can use. See, I'm again telling you, rebound hammer is indicative. Don't compare with for making decisions. If you want to, yeah. Sir, again, ultrasonic and rebound hammer, even if we combine, we need to have a more than 28 days age. At 7 days age or 14 days age, it is very difficult to correlate the rebound hammer and UPB. For example, if your concrete is good and your values are less, what you will do? If your UPV is good and your rebound hammer value is less, then you will go for core cutting. So it's all a permutation, combination, and scientific evidence-based decision making. Nothing can be given directly into code that for 28 days you take X medicine, you will guess the Y answer. No, it will not happen, sir.
What you say, you don't mention the age.
No, we have taken decision not to already go to the
Yeah. And earlier also it was not there, sir.
after discussion. This is the testing stage. Test after
No, he's running construction stage.
testing stage, not
Sir, in those respective standards. that
No,
we
but
have
just a minute, just a minute. You see, when it say it is very specified, shall be carried out as part of the
pure machines.
Sir, quality assurance measures.
No, as a QA measurement we are doing it, so necessarily 28 days you will do it. Because if you are comparing 28 days, so you have to do it 28 days. So that is understood. I mean,
Yes, sir, that is there, sir, but we cannot mention the age, sir. Age.
What I'm doing the construction stage, what I'm telling you.
no, construction from construction, what it means is, see, one is a mixed design stage, other is construction stage. So what it means is,
Construction stage is going on
one
from
is,
say 0 to 28.
no,
But he
no,
said
no, that is not,
after
no, no,
28
no, that is not what it means. One stage is concrete mixed design stage, when we design the mix. Other is the construction. So in the construction, when you are doing it, then when you do the quality control, then it does you can do. So there, naturally, if you want to check 28 days, then you will do 28 days only. See, when you want to see the entity for 28 days, so naturally 28 days only.
Sir, if you want to do what you are trying to say, then it's better to calibrate your concrete with 7 days, 28 days in lab, and then try to use the curve according to your particular project. But it cannot be put in the code, because even the rebound hammer itself has a plus and minus 25% variation. So we are talking on test, which is having so much of, yeah. So now this. So now this.
I think he has already briefed. Brijesh, you can just
So now this
quickly finish.
new code is also focusing on this non-destructive test, where the rebound hammer and UPV, everything is being now given more comprehensively. Apart from that, this concrete core test is also being made mandatory for quality assurance level 3. So some limited amount of concrete core has to be taken for the structures which are coming under the quality assurance level 3. And if you talk about damping frequency, for a concrete core test, one sample at least for every 750 cubic meter of concrete is being suggested. So if your concrete is, for example, 1000 cubic meter, you need to have at least one concrete core samples. Apart from that, generally, if you see the IS 456 2000, we have a simple acceptance criteria, where if we have only 3 concrete cores, we have to meet the requirement of average strength should be 85% of equivalent cube compressive strength, and no individual core should have a strength lower than 75%. But if you have 1000 cubic meter of concrete or 2000 cubic meter of concrete, and if you have more than, you can say 30 cores or 20 cores, so there you have a different criteria. You have to work out the X values, for example, 0.85 FCK plus X by 2. So here we have to work the standard deviation, and the acceptance criteria is slightly different if the number of cores is more. Now coming to the durability test requirements, which sir was telling in the previous talk, that we have now introduced the electrical resistivity, oxygen permeability, and RCPT. So these tests are now going to be particularly mandatory for the quality assurance level 3, where if you have a 75 cubic meter of concrete or more, you need to conduct at least this test once. For example, up to 100 cubic meter, number of samples are 1, and more than 100, it has to be every 500 cubic meter, one more sample. So all these tests are being made mandatorily for the quality assurance level 3, and the acceptance criteria also has been given in the code for this electrical resistivity, oxygen permeability test, and RCPT. So as per this table and as per the sampling frequency, you have to conduct a durability test depending upon under which quality assurance class your structure is coming, and you have to make sure that it conforms to the required standard. Then I will not go into detail of this. This has been talked a lot in detail. All the materials needs to be tested at a different frequency. These frequencies are mentioned in the codes, but in quality assurance levels, if you are following the normal level of quality assurance, in few kind of materials, you can get rid with only MTCs. For example, steel testing, or for example, cement test. If your structure is under the normal category, you may use material test certificate. But if your structure is under the class 3, quality assurance level 3, there you have to go for chemical analysis, physical analysis. So all these tests has to be done, and there only MTC should not be accepted. So all these details are there in the code. I will not read all these things. It is more comprehensive and more, you can say, depending upon the type and importance of the structure. Apart from that, this reinforcement sampling frequency also has been made more stringent. If you talk about IS 1786, there generally we do a sampling at every, you can say, 100 tons. But in the new code, this table has been drafted based on the document of the CPWD, where depending upon the dia of your reinforcing bar, you need to have a more stringent sampling frequency. For example, at every 25 ton or a 35 ton or 45 ton, depending upon the reinforcing dia. And acceptance criteria is already given in IS 1786, so I will skip that. I will not go into that. Then coming to the quality assurance in the pre-stressing steel and groundwork, now this code is also covering the pre-stressing. So all those details related to this pre-stressing steel and the grout sampling criteria is given for all the 3 quality assurance level, like 1, 2, and 3 in detail. I think some more insight will be given by Professor Tandon in his talk. I'm not going to go into detail. Here also, some of the specific tests, particularly with respect to the grouts, has been introduced into the code, and its frequency has been mentioned. The last part of this slide is the one important inclusion, which was only in half page in the earlier code. It was only covering the load test. Particularly when we talk about the testing of structure or structure elements, there this core test or a rebound hammer test, they are only talking about this at the, you can say, at the level of the structural member. But when we talk about the structure as a whole, the load test has been given in more comprehensive way in the new code. So if we talk about the load test, all the criteria is given that load test shall be performed only after 28 days, and the load to be applied is basically a dead load plus 1.25 times the imposed load, and all the procedure is given that you have to do the loading in a sequential manner, keep the load for 24 hours, and then you have to check the recovery and deflection, or there is one more criteria of measuring the deflection directly, that is 40 L square by D. And according to these clauses, you have to make sure that your structure as a whole meets the requirement and structure is safe. If your structure is not getting a proper recovery, it means that your structure is entering into the plastic zone and it is near to the failure area. So more comprehensive this quality assurance framework with respect to test and both non-destructive as a material level, at the field level. Apart from that, the durability is also been included. So we hope that the structures should meet the designed service life, which we talks in the chapter of durability or in the code. Few lines are given on the vibration and impact test. These tests are important, particularly for finding out the, you can say, in case of the dynamic loading. For example, a vibration test is done by the mechanical shaker or something like that, where you need to find out the mode of vibration, or you can say a time period or damping. So for those, these tests are done. It's either a forced vibration or a free vibration, or then there is an impact test to find out the absorption capacity through the use of the hammers, where we find out in case of if some blast happens or some accident happens, how the structure will resist under those loadings. So coming to the last slide. So comprehensive quality assurance framework has been included in this particular IS 456. Integrated quality management is covering design, detailing, construction, testing, and acceptance in more comprehensive and detailed manner. Mandatory stage-wise inspection and focus on quality control levels are there in the code to ensure the structural integrity, workmanship, and durability compliance. Advanced non-destructive test methods, core test, and durability assessment techniques has been included to make sure that structures are checked during the construction stage itself. Proactive quality assurance driven documentation, traceability and corrective action systems will be a focus of this code. That's all from my side. Thank you. Sir, I have a question. Sir, you have a question? Hi, yeah. Yes, sir. Yes.
You mentioned about the load testing and the rebound, I think.
Yes, sir.
80% and 90%. I think in pre-stressing, it is probably different.
Yes, sir. Sir, I have only shown for RCC where 75% recovery is needed, and for that 85% is needed.
You have to, don't leave away pre-stress.
No, sir, I am not left away, sir. Actually, sir, actually, due to the paucity of time, I have not gone into detail. But yeah, it's a slightly different. There you need a more recovery.
Yes.
That I know, sir. Thank you.
Thank you, sir, for your discussions on provisions related to quality inspection, sampling and testing of concrete and testing of structural elements. Now I request Shri D, Head of Civil Engineering Department, to present bouquet and memento to Dr. Brijesh Singh as a token of appreciation. Now we will move to technical session 6. I invite Professor Mahesh Tandon, Managing Director, Tandon Consultants Private Limited, New Delhi. Professor Mahesh Tandon is an internationally recognized expert in structural engineering. He holds accreditation as International Professional Engineer and is a fellow of the Indian National Academy of Engineering. Professor Mahesh Tandon has been appointed as Chairman of the Research Council of CRRI, Central Road Research Institute. He is the recipient of several prestigious recognitions, including the Distinguished Alumnus Award of IIT Roorkee in the year 2018, Lifetime Achievement Award of Indian Road Congress 2022, Lifetime Achievement Award for Excellence in Bridge Engineering by the Indian Institute of Bridge Engineers in the year 2024, and Lifetime Achievement Awards by Consulting Engineers Association of India and also by Civil Engineering and Construction Review in the year 2025. I request Professor Mahesh Tandon to kindly deliver presentation on requirements of pre-stressed concrete in the draft revision of IS 456. Sir. Thank you. Thank you very much.
So, good afternoon, friends. I think that if you have survived without tea for so long, I'm sure you will be able to survive this lecture also. So, just the introduction part of it, although it has been mentioned several times during the day, but I would still like to mention it, that the title of the code itself has been changed, and this is now a unified code. That means that it has everything to do with concrete structures, or structural concrete is the correct word to use. Whether it's plain concrete, reinforced concrete, or pre-stressed concrete, they're all concretes after all. And once this code is published, and we hope it will be soon, the existing code IS 1343, which you can see there, that will be withdrawn because that was only for pre-stressed concrete. So I have a few suggestions on the draft of IS 456, which I will discuss. And I must tell you that we have received a lot of comments on the IS 456 draft. Many of those comments relate to pre-stressing. So we have a separate group which is looking after these comments which relate to pre-stressing. And of course, we are trying to reply to that. We are nowhere near the end. I think it will take at least 4 or 5 meetings more. I I think the first comment that is important to understand is that it should include a lot of figures, diagrams, photos that explain the text clearly. This is something which is missing in the code. As a matter of fact, even the existing code, 1343, has got some interesting diagrams which could easily have been brought here. But of course, we have now much better diagrams and more elaborate. So that has to be done. There are some printing errors, and of course, those things we are writing directly to BIS. Some items like limit state of fatigue have not been covered in the code. The code is quite complex to understand. Significant changes from existing codes have been made, and it is better to publish commentary as well as part 3, at least on bridges, simultaneously, because we got one comment that I think it was Mr. Arora who said that this is just the code and you have to go to a specialist code for other types of structures. But I think that as far as concrete is concerned, everything that you want to say should be only in this code. It should not be in some other code which is dealing with other subjects. Structural concrete, why it should also include pre-stressing is quite clear if you look at the history of concrete itself. We had patents in 1824 for cement, 1849 for actually this was given to a gardener who was making these flower pots out of concrete, and then he put some steel in it, and of course he got a patent for it. There is also the reinforced concrete system. That means that you have a column and you have a beam and things like that. That type of a thing was in 1892 that somebody developed. And finally, in 1928, pre-stressed concrete was patented by this Frenchman called Eugene Freycinet. So it's a logical development, and most of the codes of practice now dealing with this subject, they include pre-stressed concrete not as a separate code, but as a part of the structural concrete code. Now, coming to the first thing, which is pre-tensioned concrete, which is one of the types of pre-stressing. I think I better stand there. So there is, when you talk about pre-tensioned concrete, basically what we are trying to do is that you have two abutments and against which we are putting a strand or a wire or whatever pre-stressing element that you have. We have a jack on one side and we are pre-stressing this, and this incidentally is a very important issue, that we often debond part of the pre-stressing, so that when you do the concrete around it, you have a part of it which is debonded. That means that no concrete and steel interaction takes place. And this is very important because, as you can see, this is just a simply supported beam and you don't do the debonding, then normally you will put the pre-stressing strand or cable at as close to the bottom as possible to get a large lever. But at the end, this does not work. You start getting tensions at the top. In the middle part of it, yes, there is at least the dead load will be acting, so it will be okay, but not at the end. So this has become now a part of the design for pre-tension concrete. This, of course, after you have pre-tensioned the concrete. When the concrete has attained certain strength, it does not have to be 28-day strength, which we have been hearing. It can be as early as 3 days. We often have admixtures, we have higher strength than are required. Often these type of things we use in order to be able to pre-stress the or transfer the pre-tension to the concrete at an early stage. Because these things are expensive things. I mean, everywhere you can't, you have to make a casting bed, you have to make so many things. So you should have a quick turnover. For that, it is necessary to do all these things. Incidentally, it is not necessary to do only one girder or something like that at a time. You can have a number of them which are put in series, and all of them can have all of them can be used, concreted at the same time. यार आपका पॉइंटर ये बात तो है, पर ये तो कौन सा है यार? ठीक है, ठीक। लाइटर तो किसी काम नहीं करता है, सबके पास तो बैटरी। आपको तो 50 साल हो गए, अभी तक नहीं मिला। ओके, माइक ले लीजिए, वो पीछे वाली ऑडियंस माइंड देगा। Okay, so let's talk about pre-stressing system. Now, pre-stressing system, especially when you have post-tensioning hardware. Post-tension means what? It means if you look at the post-tensioned and hardware, what does it consist of? It consists of strands or wires. As you can see, it is going into what is called a duct or a sheath, and this is going into a guide, and finally it is all the strands or wires are coming out, and they are going into this bearing plate, which is normally made of forged steel, and each wire or strand comes out of each hole that you see, and it is here you have as many what are called wedges or grips, and so what you do is that when you bring them out and you are able to lock them separate, and of course you have different equipment like jacks which can pull all of them at the same time, and you have a system by which you push these grips into the conical hole directly. So you don't have to do it strand by strand kind of thing, although that is also a system that when you want to do, you can do strand by strand tensioning also. Both should be allowed, and I think it should be permitted in the court. आप कर रहे हैं? हाँ, कर रहे हैं। अरे थैंक यू सर। इसके आगे नहीं। ओ, ये तो सिर्फ दिखा रहा है। I've already explained that was pre-stressing type 2 is post-tension. Next one. Here, this is a very good photograph which tells you how the strands are coming out, and you have a wedge which is conical in nature, and it goes in, and you can see that it is slit into 4 parts. Some systems use 3 parts only, and very few of them use 2 parts. The idea is that when this thing tries to go in, the wedge tries to go in, it reduces the gap. No, it gets hold of the strand and then goes in. That is the idea. So apart from what you are seeing here, is a 7-wire strand. As you can see, there are 7 wires in each one of these pre-stressing elements. And this could have been, instead of 7-wire strand, you can have just one cable, one wire, or you can have one rod. All these systems are available. I will try to show you that. Okay, so here that wedges which we saw are here, and as you can see, it is got very carefully. I don't know whether your eyesight must be better than mine, but here you can see some teeth, blue color. So the idea is that when this wedge tries to go in, there are these teeth which catch hold of the strand, and that takes the wedge, the strand along with it. So this is what the system is. And of course, since you are measuring something, how much is the elongation and all that, basically what happens is that when this tries to go in and the final position is here, there is a slip, that is what we call. That means you have a loss of pre-stressing as a result of this. So this is what is shown here, and this is called reverse friction, because when you are tensioning, apart from, of course, this part of it, which is the anchor, the rest of the cable is in contact with concrete, and when you try to tension it, there is friction and there is a loss of pre-stressing by the time you come. So if you see here, if this is the jacking end, then you have the top part of it. By the time you reach the mid span, you got a loss which is happening due to friction. When the slip comes in to the picture, this part of it is the reverse friction. So this is basically just an idea in case you are not acquainted with pre-stressing. Next one, please. Okay, so these anchorages, these are proprietary items, and they have more to do with mechanical engineering perhaps than with civil engineering. But what does it consist of? This is, the forged anchor plate which you saw earlier. In front of that, you have a spiral of reinforcement. As a matter of fact, when you have such a high concentrated force applied to any place, there are tensions which are developed in front of it. So, how much of these the spiral, what should be the diameter, what should be the spacing, etc. All this is a part of the job of these system supplier. So, as you can notice, this is going to be connected again to the duct, which actually expands a little bit and includes this. So this is where you grout the pre-stressing cable from. You heard a lot about corrosion, and they said that the corrosion happens very fast. In pre-stressing, it happens even faster. The reason being that you have the diameter itself is so small that if you have some corrosion, even if it is the same amount, there is a large amount of area which is gone as far as its capacity is concerned. You also have anchorages like this, and these have, which are shown here also, and you have a duct which is no longer round, but it is a flat duct, and this is what we use in buildings, especially post-tension slabs. When we use, then this is the type of anchorage which is most commonly used. And you can notice these projections which are there, when the pre-stressing is applied, the force is transferred everywhere. It will be transferred in front of this, in front of this, in front of this. So it's that is why it is a proprietary item. Those people have done years and years of research before they can say what should be the height of this, what should be the distance of it, and all that. So that is why it is a proprietary item, and this needs to be checked. You can't accept a pre-stressing proprietary item. Any proprietary item must be checked. It is not cement. You have a very good code made by BIS. You have aggregates. You have water. You got everything. But unfortunately, so far, BIS has not made a code on testing of these proprietary items of pre-stressing. Next one can we have? This is just to show you that you can have PE ducts, polyethylene ducts also of this type, the flat. Next one. So now we come to something which is very tricky as to when you say the diameter of duct, what does it mean? Does it mean this one, or does it mean this one? And invariably, if you don't say in the code properly and well defined, what do you mean by internal duct and what internal diameter, and what you mean by the outer diameter? Now, when you are talking about, let us say, concrete cover, where do you think it should be measured from? Obviously from the outer diameter, not from the internal diameter at all. But when you are talking about what should be the minimum diameter that you should have, it should be 3 times the diameter of the area of all the strands that you are putting in. So that is something which is, I think so far it is not given in the code, but I think that this must be put in the code so that people know, and they know the definition of what is to be measured from where. Don't say diameter, because in the water pipe industry, the nominal diameter is the internal diameter. So that is what people think. But when you are talking about cover of concrete to the pre-stressing, it cannot be measured from there. Next one. Okay, this is something which is a bar. This is another type of pre-stressing. And you can see this is a bar, and it has got on its outer face threading. So here what happens is that we jack the bar up, and you have a nut which is possible to wind it so that the tension after you tensioned it, it remains there only. Next one, please. Here's another picture. So it is not necessary to have the whole bar to be have this threading. These are costly propositions. So if you know that this nut finally is going to rest somewhere, so you can have some on the other side, some small with some factor of safety, only that part which is threaded on the outer side, not complete bar as you saw in the earlier slide. This shows you the anchor, the jack, and it's quite a small jack, and the bar comes up to here, and then you tension it, and here you put a wedge after it is tensioned so that it remains there. So there are many types of systems and many types of way of doing it, and these are all proprietary items. So anybody can produce a proprietary item like this. But the problem is that BIS does not have any code of practice how to test those proprietary items. Anyway, let's go further. External pre-stressing. As you know, if this is a simply supported beam, you want the pre-stressing cable to be like this. That means that at the mid-span, you want the maximum lever arm, and at the end, you don't want any lever arm at all, because you don't want tensions at the top. So this is to replicate this or to simulate this in external pre-stressing. You have what are called deviators. What you see here, these are deviators, so that the pre-stressing cable can come like this, get deviated and go there. Now the question is, what type of deviator? This is one type of deviator which is shown. As you can see that this is where the cable is coming from, and it is then going up from here. So, but on the outer circle that you see here, you must have space. You don't want that when you pre-stress this cable, it comes in contact here, because if you have a high tension steel cable or wire or whatever, and you put a knife edge load on it, it breaks. So this is a special thing, and I will tell you a little more about it. Next one, please. At the deviation, what we do is this is the horizontal part of the cable, and then you are going up where you want to anchor it. At some point, there will be this PT is a point of tangent of the cable. So this thing requires a special design. It is something which the designer of the bridge is responsible for, not the supplier of the post-tension system. So if there is a problem, the first thing that happens in our field is that everybody wants to blame the designer, and the designer wants to blame everybody else. So really speaking, this part of it is something which has to be done by the designer, because this is a part of the permanent structure. So you have, depending on what is the length of this, you can have, trumpets on both sides, or you can have a straight part. If you want a bigger, we often call it diabolo. This word has come from France, but it is quite a nice word to use. Next one, please. This is just to tell you, in case I was not very clear about this post-tensioning external and internal. The pre-stressing cables in a bridge girder, which you see here, are located here. This is the internal pre-stressing, or the traditional way in which pre-stressing is done. The external pre-stressing is outside the concrete. And this is a deviator, incidentally. It is not outside the box girder. It is inside the box girder in this case, but it is outside the concrete. Now, the moment you do that, you must understand the primary protection against corrosion of all pre-stressing, let us say this one, is the concrete encasement. That is why it does not corrode. It corrodes very fast if it is exposed, but once you put something which has got a high pH value and contain it there, then it contains slower. So this is what the advantage is. And of course, It has a compact, impervious cover. If you've done what Dr. Brijesh Singh said about quality of type 3, the highest, or people who are following those things, you will have all this will be a highly compacted concrete, and that is absolutely essential if you want to have a good encasement which will prevent corrosion. But when you have external cables like that, there is no external, there is no concrete protection. So the primary source of protection has gone in this case. So you must provide something other than that to replace it. We'll see how that can be done. Next one, please. So this is again the 7-wire strand, which is the most common one which you use. This inside is a wax. When you are extruding the strand, you are making these 7 wires and they go through some contraption and they, like a rope it becomes. That is the idea. And inside you can put anything, and here they normally put wax inside. And outside, as it is being extruded, the strand, you can also have a PE coating. So this is called a PE coated PC strand. PC means pre-stressed concrete. So please note, Mr. Arora. Noted, okay.
So this is polyurethane, sir. Polyurethane PE.
Yes. Polyurethane, or correctly speaking, it is actually HDPE, high density polyethylene. So this is as a part of the extrusion process. You have to have a special factory for it. It can't be done where the normal strands are being produced, or a separate machine which does that. Okay, so this is improved durability provision of strand in any case. Next one, please. If you want further improvement, like you can have any design life, if you don't specify, then everybody will want this. This is a galvanized strand inside, not the normal strand. So you've got this protection of pre-stressing cables is actually a multiple system. If you just do one, it may not be enough. You have to evaluate. So in this case, there is a galvanized strand apart from whatever you saw in the earlier slide. This is what it looks like. The PE coating, and of course you can't make out whether it is galvanized or not, but these are galvanized. So this is the way in which you can keep on improving the durability considerations in pre-stressing. Next one, please. Now the question is that whose responsibility is what? There is something which is coming from the pre-stressing system supplier, which is a proprietary item, and you are putting it into the concrete, and you are stressing here, and invariably what you'll see is that there are a lot of cracks all over the place. So the question is, who's to blame for that? Whose responsibility it is? The part which is just in the vicinity of the anchor, this is the responsibility of the pre-stressing supplier, system supplier. All the remaining part is the responsibility of the designer of the structure. He must know that after this, let us say, concentrated force is applied, how it is transmitted into this whole structure. That is something which the designer has to know, and he has to provide for it. Next one, please. Okay, acceptance criteria, like I said, we have given it in IRC 112, but unfortunately that's a highway code and may not be possible. But if you look at the old IS 1343, they have given the testing of systems with mechanical anchorages. So, although it was there in the earlier code, but we have not put it in this code. It is extremely important to put this, and there are 3 types of tests that have to be done to check the proprietary system. There is a static load test, there is a dynamic load test, and there is a load transfer test. So all these are given in these FIP recommendations. They are pretty old, 1993, but they were used in 1343, and we are still using them in IRC 112. So it's extremely important to give these so that at least one can then pressurize agencies like Central Road Research Institute. I don't know whether anybody is there from CRRI, but we have to tell them that they must have facilities to check all those. Anyway, so we were talking about equations. Here is a simple one, Mr. Arora, for you. If you put some stress in the wire here, how does the friction reduce the value of the tension that you put? Simple equation, Px, that means that the distance x from the jacking end, P0, and e to the power minus mu theta plus kx. Of course, theta means that what is the change of angle, and k is what is called the wobble coefficient, and they are to be defined in the code. Without that, I think our code will not be complete. Although the final values you should ask the system supplier, but still you should give something. ये क्या यार? पावर आउटेज नेक्स्ट वन हो सकता है? अरे यार ये आप कर रहे हैं ये सब. अच्छा, anyway, so other things that have to be put into the code. What should be, if you got number of cables, let us say in a beam which is of this type, should you put them like this? You should not, because we only found out a few years ago that if you put it like that, you are going to get horizontal cracks here. And at that stage, I'm talking about 15 years ago, people couldn't understand why you are getting horizontal cracks in a beam. People have seen shear cracks which are inclined, or vertical cracks which are due to flexure, but what is this type of a crack which is going parallel to the beam? It is because of there is hardly any concrete left in this whole area, or at least there is a tremendous amount of reduction in area itself. So that is why you're getting these cracks. So this minimum spacings, what they should have, it should be given in the code. As a matter of fact, even in IRC 112, we have allowed 2 cables to be put like that, one on top of the other. And after seeing the number of places where you got these cracks, we are going to modify that. But I think in the IS 456, we should put. Next one, please. Okay, so what should be the clear cover to pre-stressing tendons? I know there are complicated formulas and there are only 2 of them, but you have still not told us what about pre-stressing. Okay, pre-stressing, what the existing one before IS 456 is published, and I hope that they tell us what to do about in the case of pre-stressing, not stop at reinforcing. So there is minimum cover for post-tension ducts shall not be less than 75 mm. This is what the current provision of IRC 112 is. which is of course a bridge code. And in the case of pretension members, it should be the nominal diameter plus 10 millimeter. Of course, this does not take account of fire resistance and other special durability requirements or something like that. These are just okay. Other things which are missing, I think, in the code. One is that we must specify the design life, and there is no use putting design life up to 75 years because design life can be 100 years, and that is specified and mandatory for bridges, for example. Then the crack width, I think that I have already explained to Mr. Arora, and they will remove that table. But there is another place where this thing appears. This also has to be corrected. There is no 0.1 millimeter crack width. You will never get that. And grouting is another thing which I want to spend 5 minutes on it because it's the most neglected part of it. And I hope IS 456 will make a starting point. Next one, please. Now, this grout has to be tested. One is fluidity, so that when you grout from one end, it comes out from the other end without difficulty. So for that, it must have fluidity. So there is a different type of container. It's very much like a slump cone, but it's not a slump cone, as you can see. And when you remove this, you don't measure what is the slump. That means how much it goes down. That is not what we measure. Because this has to be so fluid that there has to be a spread around it. So when you remove this, unlike what we use in normal parlance, what is that slump cone, where you measure only how much it's gone down. Here, how much has it spread? So that spreading, how much it should be, is what is measured here. So up to about 140 millimeter is what spread we are expecting when we are talking about grouting of pre-stressing cables. Next one, please. There is another code, another test that has to be done, which is absolutely essential. If you put a grout in, let us say, a cylinder like that, you will see that the solid particles come down and there is water accumulated here, what is known as 3 here. So this is something which is not allowed. So unless you make these tests, you will not be able to make something which is protected by grout. The idea of grout is to protect it from corrosion. But if you have so much of water in it, it will not be protected. What is allowed is this 10 millimeter, what you see here. Next one, please. There is also an inclined cube test, which is done the same way. The idea is the same. It's a bleed test. And you have to see how much of it comes down. From here to the solids are here, and the rest of it is water or air.
These are full-scale testing, sir?
Yes. Full-scale testing means, no, you don't have to have.
The span of they are saying 5 meter.
ये 5 मीटर है. आपको अगर ये वाला टेस्ट करना है तो आप 5 मीटर करिए. And you have to put it at a certain angle, 30 degrees. So you do these tests at every site. And unless you have these type of things specified in the code, nobody will do it. Next one, please. So what is the future of grouting, which is future of grouting, and we have already started this in India, is vacuum assisted grouting. That means that before you start grouting, you create a vacuum, and from the other end of the cable, the grout comes in. So about 80 to 90% vacuum is created in the gut before the grout is pushed in. So this is basically it. So thank you very much for your kind attention.
Thank you, Professor Tandon, for your detailed discussions on pre-stress concrete requirements. I request Shri D. Bhadra sir to present bouquet and memento to Professor Tandon as a token of appreciation.
Thank you. Thank you, Mr. Bhadra. Oh, there is something more coming.
So mementos.
Yes. Thank you.
Yes, sir.
We will now proceed for panel discussion and questionnaire session. I request all speakers to join dais.
One question to Professor Tandon. One. If you permit.
Yes, sir. You can ask in panel discussion. You can start with that question.
Somebody.
I request participants to kindly keep their questions relevant to this subject.
Sir, I ask sir one question?
Okay, 1 minute. So we are into the last session. Shuru karenge. So we have all the speakers on the dais, so we can raise questions one by one. First, identify your question, and you also specify to whom you are asking this question, and we will try to answer. I think Mehti Sahab is very patient. You can start. Please identify yourself and say who should answer this. Is your choice.
How to reduce the bleeding of concrete testing you are doing. So I was thinking that viscosity modifying agent can help. The bleeding test you are showing, sir.
Oh, bleeding test. Yes, yes. Of course.
At least viscosity modifying agent can help.
Yes, you can put any admixture, provided it does not corrode the reinforcement after you have put it there. So there are a number of admixtures which you can put in the grout. So in the old days, we used to say it is like a pan masala and why risk something. But nowadays, people have come up with admixtures which are very reliable and they have to be tested, of course, and they can reduce the bleeding tremendously.
Sir, I got another question. What, of course, it's not presented, but it is in the code. I was studying the code. In one place, there you have specified maximum rotation permitted in foundation structures. Even
Maximum what?
rotation permitted in the foundation structures. For example, in piles and oil, so many places, the structural analysis, is also to be done, but limits are given for the rotation. I wanted to understand any references to be given in the code, how to measure the rotation practically, or any analysis you have taken care. This is the details. I want to ask.
It is generally by analysis because the foundation nowadays, the foundation is also analyzed along with the main structure, and you put spring constants in the springs in the foundation for piles or simple footing, everything, so that when the analysis is done, you will know how much rotation is happening at the
How
foundation.
to verify in the field structures? How to
Field
verify-
structure, no, it's purely an analytical process. The analytical process, only it is done. As far as the pile is concerned, we always do the lateral load test and limit the lateral movement. But we don't check rotation. Limits are there. Analysis may you have to limit them. It's not the field value. Nowhere it is mentioned the field value. It is the part of the analysis. Field you can't measure. Any other question? Please.
Good evening, sir. I'm Amit Thakur from BHEF. This question will be for Ojha sir and Brijesh Singh sir. With these days with PPC getting so popular, what we have observed is that the rate of strength gain has changed. We have been using 28 days strength for a long time, and by no means I want to change it. But the thing is that just in case we are not achieving my target strength in 28 days, okay. In fact, we have seen occurrences where strength has been gained after 56 days even. In such cases, should we go for code test immediately? Because what we have seen is that if we have kept additional cubes and if we are testing it after 40 days or even 45 days, we have seen that the strength has been achieved. I am going to use my structure after a very long time. I work in an industry where the construction period itself is 36 months, 42 months. If if my structure is gaining strength, and that is also substantiated by my core test. I'm saying cube giving me good result after 42 days, for example. I'm doing core test also after 42 days, and I'm getting the required strength. Why should I be going for core test at all? Or at least this can be put as an intermediate step in the code before going for the core test.
You want to answer?
I can suggest.
Actually,
see what first of all,
first
of all, there are a couple of connotations to your question.
Yes.
What is the characteristic strength of concrete?
It actually is. Sir,
is
28 days.
28 days. So the first you are violating the characteristics of the concrete if you don't get the strength on 28 days. That is one thing. Number two is before you use your concrete, you do a mixed design and you make sure that you get 28 days strength there. And if it is not happening in the field, there is something wrong somewhere. Why you are not achieving it? So that should be investigated. But the last thing you said is correct. It need not be demolished. I agree with you. If the load is going to come much later, but maybe after 56 days you kept the cubes, that you had a premonition that it is not going to achieve, you kept the cubes and you were able to prove it. Structurally, I don't see any difficulty, but in a pre-stress structure and other things, there are other parameters, time parameters are there, time-based parameters are there, that will have to be checked. That's it. But again, the third parameter is the contract. So in contract, I don't think you'll get the full money for the strength. Yeah, because you have not achieved the strength on time. You will be penalized for that one. So, and the basic thing is why you have to investigate why your design, what just happened in the lab, you could not replicate it in the field. That should be investigated thoroughly before you accept the whole thing.
No, that's why I said that I by no means I want to change it. Because first of all, I don't even know why this 28 itself came. Okay, maybe then we had only OPC cement. Now that we are getting many different kinds of cement, should we not be revisiting that 28 itself without changing the characteristic strength definition?
There is nothing like that. You can specify 56 days. Nobody stops you from doing that. Code specified that the characteristics, and when you define it, is 28 days strength. That's all. You can define your own definition. I don't think any problem is there. If you want to get the strength only after 50 days, for example, Tandon would like to get a strength within 3 days' time. There is no objection from the code. You do that. Somebody wants it 7 days' time. Don't do that.
So can we do something in the...
That depends
in the
on
code
the
itself?
contract, you know. When you enter into a contract there, you have to decide. Code doesn't come in the way. If it is, you are specifying characteristic strength, 45 means it has to be on 28 days.
You have already designed for 28 days, your concrete.
Yeah.
And not passing means by what amount? Let's suppose M25, the target mean is 1031.6, and at 28 days at site you are getting 10.
No,
so then it's
not like
major fault.
Definitely.
But let's suppose because of some error you are getting a little bit less than acceptance criteria. Then decision can be taken what is to be done, and there is a process for that. So fail, pass by what margin? That is also to be.
But the way codes are written, it is either pass or fail. Because you will specify FCK minus 0.5 times
Yes,
something.
call like school admission, you have to become 5 years.
Sorry, sir.
You should be 5 years, 5.5 years before you go to class 1.
Yes.
But you will get admission 4.5 also. So you have to when you write a code, it should be a value for all. You can't specify for each person one number. So this is universally accepted characteristic is 28 strength. Any other question?
I have many, but I would like to...
No, please go ahead, because nobody else has raised their hand.
I think I'd just like to add something to what Jose has mentioned. You see, there is a design basis report. Supposing you are using one of these too much of fly ash and stuff like that, the development of strength is much slower than OPC, certainly. So you will get your strength much later. But all this should be specified in the design basis report so that it is established that, like for example, if you are making a building that has or a bridge, it has to be checked even for the when any load is going to be put, whether it's safe or not. So
Agreed between the client and the designer.
Yes.
And the contractor. That's why the DBR become very important.
yes, design basis report is important.
Let's complete. Yes, you're finished.
You can take mic that way. Hand mic you can take.
You are talking about PPC, but in the code, I have
PPC, sir.
PPC.
It is working, sir. It is working.
working. In the code, I have seen some places it is written there when the grade of concrete is more than 40. More than 40. We can use fly ash more than 35%. This is the statement given there. For higher grade, highest quantity should be more than 35%, and lower grade, it can be lower.
Yes.
So this statement is there. I sent the comment. I have not sent the comment, but what is your idea about it? That why are you allowing more fly ash quantity more than 35% for a grade of concrete of M40? And it is not possible to get M40 above. For higher grade, you cannot get with so much fly ash.
I will answer. You see, this limitation of fly ash of 35% in concrete is for the carbonation. Because more the fly ash, you have got a higher carbonation. But when you have a high strength of concrete, it is so dense concrete, the carbon dioxide penetration gets so much reduced. So you get a lesser carbonation coefficient. And there we can permit a higher fly ash also. So still it will be.
That you cannot achieve the grade with so much fly ash.
No, you can achieve. You may achieve, you may not achieve. That depends upon water cement ratio and all that.
You control your water.
The high volume fly ash concrete people are making M40 and 50 people are making.
40% fly ash, I cannot get M40.
See, people have made high volume fly ash concrete M40, 50 with higher volume fly ash also. Using lower grade, high grade of cement, yes, your cement grade is higher, the water cement ratio is lower. See, we have mentioned two things there. I think the water cement ratio is also mentioned.
Water cement ratio should be
Less than 0.4 we have mentioned perhaps. So it has to be both. If your water cement ratio is very low and your grade is higher, so then we are permitting, because that was a requirement from the field that for higher grades we are restricting the fly ash. So we said, okay, we don't restrict it.
Medisa, we are achieving 150. We are making a bridge in Kerala. 150 with fly ash concrete. High volume fly ash concrete.
My general observation is there. I've seen higher grade with 20% fly ash was possible, 25%, not in 40%.
That is generally, but in special efforts with ministers and other people are using it. So we are permitting that, that's all.
Any other question?
We are not saying that you can achieve it or you don't achieve it. We are permitting that.
Any other question? Anywhere?
Sir, I have one more.
Yeah.
This is regarding the design of foundations. Okay, so in the current draft, I have seen that values pertaining to uplift of foundation has been given.
Values pertaining to?
Uplift, percentage of uplift. Okay, so there what I have seen, this was actually missing from previous version for which we have faced a lot of difficulties. So this time it is there. But the thing is that from isolated footings, the uplift is no longer permitted. Now this is something which is going to make our lives very, very difficult. We the designers. Only in raft foundation, only in the raft foundation, some uplift is permitted. 15% of uplift. In the isolated footing, the uplift is.
We don't think. I don't know where it says uplift is permitted.
I have actually raised this comment also. I have also given it to.
वो लिखा हुआ है सर
कि isolated footings there is no uplift is permitted.
लिखा हुआ है about the isolated.
The clause of but we are not permitting that uplift. No, the clause is to limit. I mean, avoid the uplift. You have to avoid. For that, the clause may be there. But we are not permitting uplift of that.
Can you read the section?
If there is something, we can review that.
Yes, I have raised it also to you. Okay, so I will request you to.
No, please, which clause you left? Please see that. I'm not aware of it.
Sir,
so we can note down and we can review that, but I don't think it will be like
9.1.1.
No, I think that is fine. You have already shared your comments. It will be taken care when we discuss that comment.
Okay.
It is related to the foundation design that will be taken.
So it is uplift at column basis is the thing. Uplift shall not be acceptable in.
Shall not be, no? It shall not be acceptable, yeah.
Shall not be acceptable in columns resting on individual footings, which means that if I am not giving a raft footing, okay, the permissible uplift will become 0. So now this.
No, the wording we will review it, but actually it is not permitted.
So I put this in technical, editorial, and general.
Yeah, if it is confusing wording, then we can rectify the wording.
Any other comments from anybody? Would like to ask any question?
I think it was.
Sir,
somebody is there. Can you ask question?
Mike.
This is for Tandon sir. Sir, sometimes we discourage the unbonded, in pre-stressing, unbonded tendons. Why so? I mean, and sometimes even in precast, we are using unbonded tendons in pre-stressing.
You see, there is external pre-stressing and there is unbonded pre-stressing. Now, external pre-stressing, I have already explained that the primary protection that you have of concrete, it doesn't exist in external pre-stressing. So you should make up the lack of this primary cover by something which I showed you examples of. HDP, you can have those extruded strands, they are all available. And or you can have even galvanized strands. These type of things can be used. Now, what I was talking about in pre-tensioning supports at the ends, you don't want any pre-stressing because whatever pre-stressing you put, normally it is at the bottom and that will give you tension at the top, which you don't want. I mean, the cable, if it was like this, it will be fine. But if you have a straight cable, which we use in pre-tensioning, then what people do is to do a debonding of the strand for a certain length. I mean, that is up to you where you want it to, up to what length you want to use. And there are codal limitations. You can't use too much. You can't use too little. It depends on how many strands. You can't use it in all the strands. You can use it only. These are codal provisions, which my suggestion is that we should put it in the code. With sketches so that people understand.
Okay. In precast, we have IS 15923. And in precast, as you suggested that near the support, we have given that it should be unbonded. But the entire length, we can give the bonded tendon. Then how do we achieve those things? I mean,
how do we
achieve that at support this is unbonded and for entire length it would be bonded?
You see, the simple thing is that supposing I put a what do you use for electric conduit? There is a polyethylene or plastic cover. You put that on the strand for the length that you don't want it to be bonded. Where you want unbonded, which is supposed at the end only. So that length you put that so that the concrete does not set along with the strand or steel.
Some people use grease in that area.
So, I mean, in my understanding, that would be, I mean, without any grouting or there would be air, air pockets would be there.
Pre-tensioning has no grouting.
Okay.
You are first, pre-tensioning means you have first tensioned the strand, then you have put concrete around it, and then you have released the strand. That is how pre-tensioning works. That is why even what your question is absolutely right. I mean, this is not something which we should put it in the code. What do you mean by pre-tensioning? How is it done? Unless we will know at least these basic things, there is no use.
Those who have not actually done it, it is difficult to emphasize.
But this is the first time that you are introducing pre-stressing instead of a separate code into this reinforced concrete code, which is a good idea. But at least you should make some figures or sketches or something which is.
Sir, we can tell the convener to pre-stressing section.
No.
Kौन है sir?
Whatever you will provide, Jitendra, he will add it there.
Okay, so after having a wonderful panel discussion and the panel has already clarified all the questions, I thank all the respected panelists for participating in this panel discussion and sharing their views on the questions. Yeah, and
Close near the mouth.
yeah, and sharing their views on the questions from our participants and audience. So all the respected panelists can take their seats. With this, we end this panel discussion over here. Yes, you can take it. So with this conclusion of the panel discussion, we go to the end of today's seminar on the revision of IS 456. it is my privilege to express the vote of thanks on behalf of Bureau of Indian Standards. First of all, I would like to express my sincere thanks to Shri Josh Kurian sir, the chairperson, Civil Engineering Division Council, as well as Cement and Concrete Sectional Committee for giving the opening remarks of the today's session and sharing the briefs about the key drivers for including this comprehensive revision. I also thank Shri V.V. Arora sir, co-chairperson, Cement and Concrete Sectional Committee, for his valuable deliberations on the durability and service life design part of the 456 draft, which has been introduced very comprehensively for in this particular version, and we will be in the next future revisions, we will further elaborate and modify based on the feedback which will be received from the construction sector. I would thank Shri P.N. Oja sir for his insightful session on the structural materials and the main confusion among the users basically about the durability provisions of the standard. He also informed about how we can select different types of cement based upon the durability considerations which have been given in the draft standard. I also thank Shri Amandeep sir for sharing his perspectives on the loads, methods of analysis, as well as structural design aspects. Dr. Brijesh Singh for highlighting the importance of construction and quality assurance aspects in the construction phases, and Professor Mahesh Tanzan for sharing his expertise and insights on the requirements of pre-stressing concrete. I also thank Head Civil Engineering Department, Shri Doipanpan Bhadra, for successful organization of this particular seminar. All my CED, all the officers of Civil Engineering Department, as well as all the staff who have involved in this organization of this seminar for the fruitful success. With this, I thank you again once everyone, and wish everyone a safe journey ahead. Thank you very much. You all can go to the cafeteria for the tea session.